Then we'll move on to definition of terms. Then we'll move on straight to Venn diagrams. And we'll wrap it up with Algebra of Sets. Alright, so this will be the subtopics we'll be looking at under set theory, introduction, type of sets, definition of terms, Venn diagram, and Algebra of Sets. So let's start. Introduction. So from introduction, so let's know what set is. So let's define set. So definition. So we can say that we have a lot of definitions for set as far as set is concerned. So we can say that set is a collection of well-defined objects. So that is the basic and simplest form of definitions we can give to set, which is what? The collection of what? Well-defined objects. Now let's take that definition keyword to keywords. Now first thing is that before we can have a set, the set must be well-defined. Are we together? So that means we can have a lot of objects around, different kind of objects, but for those objects to be classified as a set, then they must be what? Well defined. I don't know if I'm trying to say like that. But for example, let's take example. Let's say look at footer student. If you have a footer student like in a crowd, they cannot be classified as a set because that crowd consists of a lot of students. We have probably people in AG department, people in SPS, people in SLS. I will get what I'm trying to say like that. But for us to have a set, we have all people in the same department come together to form one to give us a set. Do you understand what I'm trying to say like that? So that is the basic definition of a set, which is what? Collection of a well-defined object. So that's what set is, collection of well-defined objects. So now, also, if we have collection of well-defined objects, so the next thing we look at is how can sets be denoted as, like, which way can we write sets, like what format can set appears in. That will give us to description of set. Description of set. So now, first thing is that as we know that a set is what? Collection of well-defined objects. That's not disputed. Are we together? Now the next thing that must happen is that we must find a way to describe the set. Right? So now there are two ways to describe sets. Now the first way is tabular form. Yeah, tabular form. That's the first way to define sets. Tabular form. Now how do we define it in tabular form? Probably if you have come across this in your normal secondary school classes in SS1, yeah, you see something like this, probably A, and yeah, that reminds me, all sets are denoted with a capital letter and a curly bracket. All sets are denoted with a what? A capital letter and a what? And a curly bracket. So probably we are talking about tabular form. So let's say that we have A is set of factors of 20. So let's say that this is an example of a set. I want to describe it that we say that set A is a what? Set of factor of 20. So what does that mean? So that means that set A will consist of 1, 2, 4, 5, 10, and 20. Yeah, right? Yes or no? So whatever I've done here is a tabular form description of what? of set. Do you understand what I'm trying to say like that? So this is one way to describe set. So the other way to describe set, let me come to this part, is set builder notation. Set builder notation. Alright, so that's another way to find set builder notations. When you set builder notations, we'll be having, I think this is the part that confuses people a lot. We have something like this. An example, we have something like this, as I said, a curly bracket. Can I have x, something like this here, then x probably is, or let me say, x is greater than 7, or then something like this. This is an example of a set builder notation. Or let's say that x is lesser than 7 for all x squared minus 49 equals to 0. Yeah, aha. This is an example of set builder notation. So this one means that before you can break down the sets, you have to literally deal with this other part here. Are we together? So now let's break this one down to tabular form. So breaking this one down to tabular form, I'll have something similar as x squared minus 49 is equal to 0. Then from here, if I collect like terms together, moving 49 to the other side, I will have x squared is equal to what? 49. And according to our basic rule of algebra, we can know that if I take the square root of both sides here, I will have x equals to plus or minus 7. Yes or no? So that means that in this answer here, let me move on to this part. So in this answer here, from here, so that means I can say that x is equal to plus 7 and at the same time minus 7. Are we together, please? Now, but this element here is telling me that the only element I must have here must be that x is what? Less than, sorry, let's make it less than 7. So x must be less than 7. So for x to be less than 7 here, so which element satisfies that? Minus 7. So that means I can say that whatever this is, which is this, less than 7, for all x squared minus 49 equals to 0, will give me what? Minus 7. Are we together like that? So this is the two basic ways you can represent sets, or you can describe sets. The first way, as I said, is what is in tabular form, where they will give you what your set is meant to be defined as. Are we together, please? And the second one is the one that they will give you in sort of something that looks like something difficult. So here you just have to understand the equations they are giving you and you can work with it. Are we getting it like that? Alright, good. So that is that about that. And another thing I would like to add to it is that everything in a set is known as its element. Do you get that? That means that, for example, if you have a set defined as this. So this is a set A, which is what? A set of factors of what? Of 20, right? Now this one is trying to tell us that all of these things I have inside this bracket here is what? Are elements. Do you get what I'm trying to say like that? Do you understand? Alright, good. So I think that will be that about that for introduction. And then let's now move. Let's move. So let's move on to the next subtopic, which is types of sets. Types of sets. Now in types of sets, so let's start. We have a lot of types of sets that I think we have about 9 or so thereabout. So let's start listing. So the first type of set we have is singleton set. Yeah, we have singleton set. And what is singleton set? A singleton set is a set that has only one element. So now, so to make it interactive, let's do it in this way. I will define this set. We all come up with an idea about an example of set that can give us one element, and we continue. How about that? It sounds fun, right? Alright, good. So now, we talked about singleton set, and I said that a singleton set is just only a set that has how many? One element. Alright, so I'm open to ideas. What set has one element in it? So, alright, to ease the case, alright, I think, for example, let's say that I have set B is, let's just say, books, or, okay, most intelligent, alright, being in the universe. Alright, let's have something like this. Let's have B to be described as the set that is what? Most intelligent being in the universe. I think there's only one person that has the answer, which you have got, right? Right? Okay, good. Alright. Alright. Let's look out for another example of a set that has only one element. Alright. Okay. Let's say that set C is defined as a set of the colors, okay, colors present when you close your eye. I just forming a lot of single sets. Now, this part might look a little bit controversial in the sense that some people say that if they close their eyes, they see red. Some people say they see black, whatever color you see. But as far as science is concerned, the color you see when you close your eyes is something like this. Again, growl. That's the only color you see. I put together like that. So we can just come up with as many sets as you can come up with. But what classifies that set to be a singleton set must be that that set has how many elements? Only one element. I put together, please. Alright, the next the next type of set. Now let's now talk about finite set. So from the word finite, what does finite mean? So finite stipulates that that set has countable number of what? Countable number of elements. We can call it like that. That's countable number of elements. Or we can say that it is a set in which the element has a definite beginning and the element has a what? A definite end. Are we together, please? Yes. Alright, so we can count that as a what? And as an example of what? Of finite set. So it has two definitions saying the same thing, and say that it is a set which is what? A set which has what? A finite number of elements, or a set which has a what? A definite beginning and what? A definite end. Alright, good. Let's start. I can come up with a lot of sets here. So let's say that set E, let's say that E is a set defined as set of AGE class 27. So that means I know that this set here contains a finite number of students. Yes or no? So that means that from I don't know how many students that put admitted for AG. I do not know, but let's just say that, let's just pick a number. Let me do a wild guess. Let's say that we have 30. I don't know, might be more than, but let's just say that we have 30. So all this number of elements that we have in this set, as long as it can be countable, it is known as what? A finite set. Do you understand what I'm trying to say like that? Alright, okay, let's look at another example. Let's make this example more interesting. Okay, now, sorry, I'm a football fan. Let's say that F is a set of Premier League teams. Premier League teams. So, let's say that F is a set of Premier League teams. So, as usual, I don't know if you have footballers here, but I know that at least Premier League has about, if I'm correct, about 20 teams. Yeah, so 20 teams. So just note that anything that can best define finite set will be that a finite set is just a set that has what countable number of what elements, or is the set that has a what a definite beginning and also what a definite ending. Do we understand that? All right, now let's move on to the next type of set that we have. So next type of set that we have, let's have the opposite of finite, which is what? Infinite or infinite. You know what you call it? Alright. So in infinite set, infinite set is just the exact opposite of what? Of finite set. While infinite set will give you the total number of, or will give you a countable number of elements you have, infinite set is concerned with the fact that your elements cannot be counted. Are we together? So that's the best. So we can call it that an infinite set is a set which has infinite number of what? Of elements. Or you can call it that is a set that that doesn't have countable number of what? Of elements. Do you understand? So now let's give examples to that. Infinite set. Let's find one. Let's say that A is set of stars in the galaxy. Yeah, whether we know it or not, this type of set that I've listed here is infinite, right? So we can't count the number of stars we have in the galaxy. Alright, okay. Or let's be more specific. Let's say that I have a set B, which is a set of humans on Earth. Yeah, well, this seems a little bit controversial in the sense that it appears to be countable, but in the real sense, the population of humanity can only be estimated. Are we together? That means that it can only be approximated to, okay, let's take a wild guess, probably humanity is about 6.8 billion persons on planet Earth. Are we getting? Well, we can't get the actual number, so I can classify that to as what? As a set of what? An infinite set. Yes? So just know that anything that has an infinite number of set or infinite number of elements will make up for what? An infinite set. Do you understand? Alright, the fourth type of set will be an empty set. An empty set or a null set. Alright, so in case you want to define, an empty set is a set, as its name implies. An empty set is a set that has what? No elements. Yes or no? So any set that has no element is known as what? An empty set. So it can be denoted as this. Two curly brackets with nothing inside, or yeah, this Greek letter here. Those are the two ways you can denote an empty set. Is either it's written in this format or it's written in this what? Other format. But as long as it doesn't have any element, it is known as what? An empty set. Okay, let's come up with sets like that. Set as an empty set. Alright, okay. Let's say that set of pet that talk. Set of pet that talk. Do we have parrot? Does parrot talk? Alright. Or let me make it a little bit more interesting. Don't let me use talk. Let me use scream. Or let me give it another. Yeah, which pets do we know that can scream? Yes, like an human being, particularly, that screams exactly the way you scream when you see cockroach in your room. So, do you have any pet like that? I don't think we do. All right. So let's say that B is also a set of okay, of animals. Why am I with animals today? Of animals that has 17 heads. Even in myth, safe methodology. If you can check mythology, I don't think in myth we have animals that has 17 heads. Even in myth. So I'm even telling you that even if you want to come up with a story, there's no story that you can come up with that will picture an animal having how many heads? 17 heads. I would get what I'm trying to say like that. So as long as it's just a set that doesn't have any element, it is known as what? As an empty set or what? Or null set. Alright, good. So another thing I would like to add to this is that all sets as an empty set. All set as an empty set. So that's another note that you might have to note that whatever set that you have, all set as far as it is confirmed to be a set, it has what? An empty set. Okay, the best explanation to this is, alright, I hope you know that all numbers too has zeros in it. Do we believe that all numbers have zeros in it? Do we believe? Alright, if you don't believe, if you remember the time you did jam, no matter how much you are, you always find out you're having 0, 2, whatever. Yes or no? So you can just, this same 0 that is here can be likened to an empty set being in all sets. Do you understand what I'm trying to say like that? Okay, good. So now, the next type of set that we have, number 5, will be an equal set. Be an equal set. So now, equal set. So what makes set equal? Now, I want to take this down. Two sets are said to be equal if the following condition holds. I want to write that down. Two sets are said to be equal if the following condition holds. Yeah, two sets are said to be equal if the following condition holds. So the first condition number 1, is that both sets must have the same number of elements. So that's set number 1. That both of those sets can have what? Must have the same number of elements. And the second condition is that all conditions or all elements, yes, all elements in the set, in both sets must be the same. Alright, so let's talk about this. So as I said, before I can have an equal set or an empty set, what condition must be there? That both sets must what? Have the same number of what? Of elements. So that means if set A has 6 elements, set B2 must have what? 6 elements. Okay. And second one is that all elements in both sets must be the same. So okay, let's create something like that. Let's say that I have A to be a set of 1, 2, 4, and 7, and I have B to be another set of 7, 4, 1, 2. Let's look at this set. First thing first is that the number of elements in A is number of elements in B. Yes or no? So how many elements does A have? A has 1, 2, 3, 4 elements, and B also has how many? 4 elements. So condition number 1 is what? Satisfied. Now condition number 2 is that all elements in both sets must be the same, meaning that all the elements in A must also be present in what? In B. Is that condition satisfied? Yes. So A has 1, B has 1, A has 2, B has 2, A has 4, B has 4, A has 7, and B also has 7. So with this condition satisfied, I can say that set A is equal to what? Set B. Do you understand? Alright, okay. So to the next type of set. So this type of set, set number 6, should give me an equivalent set. Equivalent set. Alright. So in an equivalent set, an equivalent set is more or less like your equal set. It's more or less. But there's only a little difference in it. Now the only difference is that equivalent set necessarily does not mean that all elements in both sets must be the same. But for a set to be said to be equivalent, both sets must have what? The same number of what? Of elements. So I can say that equivalent set is both sets having same number of elements. So alright, let's pick examples. So as I said, that it necessarily must not mean that both of them have the same elements inside, but both of them must just have what? The same number of what? Of elements. Alright, I can say that if set A, let's make it in terms of dollars, or in terms of currencies now. Let's say that A has naira in it, it has dollars in it, it has yen in it, then it has I think this is euro, if I'm correct, even if I didn't get the diagram right. Okay, let's say that a set A is a set of all currencies we have, not all, but some currencies. And I can also say that set B2 should be the first 4 letters of the alphabet, which is A, B, C, D. Now, one thing that you notice that all number of elements in A is the same number of elements in B. Yes or no? But not all elements in A is present in what? In B. Are you seeing the difference? So for equal set, not only must they have the same number of elements, but at the same time, the elements must be what? Must be the same. But in equivalent set, on the other hand, the only condition that makes it equivalent is that both of the elements there must be what? Well, I mean, the number of elements there must be what? Must be the same. Do you understand? Alright, good. So the next type of set, now, your universal set. So universal set, if you want to define it, you can just, the best definition to give a universal set is that a universal set is a set of, or let me say, is a set that contains different types of sets. So I think that would be the best way to talk about it. It's a what? The set that contains what? Different types of sets. Alright, so let's say I have, and also that they are denoted with this, something that looks like a U and something that looks like this. So these are the two ways you can denote your universal set. They are either written in this format or they are written in the second format. Are we together? Alright, good. So let's give examples for universal set. Let's say that your universal set is defined as the first 7 numbers that we have. That's 1, 2, 3, 4, 5, 6, and what? 7. Alright. I hope you know that in this set, I can have subcategories of sets in the same set. So do you know that in this set, I can have A, which is a set of all even numbers, which is 2, 4, 6. In this same set, I can have B, set of all odd numbers, to be 1, 3, 5, 7. Same set, have set of all prime numbers, which is what? 2, 3, 5, 7. This same set, from this same set, I can have D to be probably factors of 2. Then I have what? 2, 4, 6. So from these two forces, I can say that A and D are equal to each other. Yes or no? Because not only do they have the number of elements, like their number of elements is the same, but at the same time, everything in A is also present in what? In D. I will get what I'm trying to say, please. So now, okay, from this same one again, I can have, let me say, I can have set E, which can give me what? Let me say, factors of 3, which is what? 3 and what? And 6. So I can have as many factors as I can have from this what? From this single set. That is what makes this one here a what? a universal set. So far as for it to be classified as a universal set, that set must be able to produce as many sets as it can produce. Do you understand? Alright, okay. So the next one, number 8, the next one should be your subset. Yeah, subset. That's next one. Now, while we have universal set to be a set that generates other type of sets. So we can say that those sets that are generated by your universal subset are known as your what? As your subsets. Do you understand what I'm trying to say like that? So let's probably put it in a definition. So I can say that a subset is a subcategory of a universal set. I hope you get that. So it's a subcategory. So probably if you have universal sets, then the breaking down of your universal set should give you what? A subset. Do you understand what I'm trying to say like that? Alright, good. So for this subset, there are a few notes in it. So the first note in this subset should be that there are two types first. So there are types of subsets. There are types of subsets. So the first type of subset that we'll have is something we call proper subset, and the second one is obviously the opposite, improper subset. Are we together? Okay, so let's define proper subset, or let me give you an idea of what a proper subset looks like. So you can say that a proper subset is the all subsets that are really, let me use the word visible to the eyes. You can easily know them, or let me say, you can easily describe them from your universal set. That will give you what? A proper subset. I'll get what I'm trying to say like that. Okay, good. So for example, let's still work with this. So this is what? A universal set. And in this universal set I have what? 1 to 7. And I'll put that all of these my subsets that I've drawn out from here are visible. Yes or no? Alright, good. And also I hope you know that from this universal set I can also have a subset, which is what? An empty set. Yes or no? Because I said earlier on that all sets, I said that all sets what? Has what? An empty set. That can just basically tell you that this my universal set also at the same time contains what? An empty set. I get what I'm trying to say like that. So now the other part or the other family, which is the improper subsets. So these are the subsets, although they appear to look visible to the eye, but it takes some level of discerning to know that, because the only improper subset that we have in any set is the set itself. That is, for example, if I have my universal sets to be 1, 2, 3, 4, 5, 6, 7, and I also have, let me say I have set G also to give me 1, 2, 3, 4, 5, 6, what? 7. So this scenario here, this G is an example of what? Of an improper subset. Do you understand, please? Do you understand? Alright, what I'm trying to say is that I have a universal set defined as 1 to 7. Are we together? Then from this 1 to 7 I have detached as many subsets from it as I can detach, which is even numbers, odd numbers, prime numbers, factor of 2, factor of 3, empty set. And out of all of this one, I now have a subset again, which is what? G. And everything in that G is the same thing as what? Everything in your universal set. So this G here is an example of what? Of an improper subset. Do you understand? So I can say that an improper subset is a set, is a subset of a universal set itself. Do you get what I'm trying to say like that? So that's about that for subset. The next type of set that we have, now let's talk about power of set, or power set. Yes, let's talk about power set. So now this power set is not necessarily a kind of set. Are we together? Power set is the one what is not necessarily a kind of set, but it is just a mathematical representation of generating the number of subsets present from a given universal set. Do you understand? Do you understand what I'm trying to say? So, as I've said, that it is not necessarily talking about number of sets that we have. I'll get what I'm trying to say like that. It's not like defining a set, but just a mathematical representation of what? The number of subset I can get from a given universal set. So that's the definition. So all power sets, or a power set, is denoted by this formula, 2 to the power of what? 2 to the power of n. That is the formula that denotes a power set. Are we together? Okay, so 2 to the power of n. So this n here means your number of elements. That's what it means. So number of elements. So for example, let's create. So let's check out this formula. Let's say that I have a universal set of 1, 2, and 3, and from this universal set, I want to generate another type of. Okay, I want to generate the number of subsets I can have from this universal set. So let's list. So this time around, I might not necessarily be defining it as A is equal to this to make things fast. So let's say that here from this universal, I can say that I have a subset of 1, yes or no. I can have a subset of 2. I can have a subset of 3. I can have a subset of 1 and 2. I can have a subset of 2 and 3. I can have a subset of 1 and 3. Then, alright, then I can have an empty set, right? And I can also have 1, 2, and what? And 3. So let's count everything. How many subsets did I generate from this set? Then I have 8 subsets. Now let's verify with these 2. So here, so how many elements do I have here? I have 3. So from this here I can have what? 2 to the power of 3, which will give me the same number of elements here, which is what? 8. Do you understand what I'm trying to say like that? So as I said, power set is not necessarily a type of, or it's not necessarily a set, but it's just a mathematical representation of telling you how many subsets you can have from a what? From a given set. Do you understand what I'm trying to say like that? Alright, so from here I can also add that if you want to know how many proper subsets you have, number of proper subsets is given as 2 to the power of n minus 1. That's another number. So this n minus 1 is telling you that this my 1 here means that this my 1 is denoting my what? My improper subset. So now if I want to know how many proper subsets I have in this set U defined as 1, 2, 3, so how many will I have? I will have how many? 7. Yes or no? And all of those 7 are those 7 that are, as I said, visible to the eyes that we can see here. Do you understand what I'm trying to say like that? So that will be whole for the number of, for the type of set we have. Are we together? Alright, good. So let's move on to the next subtopic here, which is so now let's talk about let's start defining terms. Alright. Definition of terms. So I'll talk about the definition of terms. So in definition of terms, so let's start defining some cogent terms we have in it. Some cogent terms we can have here. Let's start with the first one. Cardinality or cardinal number. Alright, so let's talk about this. So cardinality or cardinal number. So cardinality or cardinal number now will tell you basically this cardinality or cardinal number is telling you how many elements you have in your what? In your set. I got an like that. So this cardinality or cardinal number. So if I ask you that, what is the cardinality of a particular set. So the only thing you are interested in is what? Knowing the number of what? Elements present in the set. Yes or no? Alright, good. Or yeah, or cardinal number. So let's take for example, let's take I have a set A to be defined as 1, 4, 6, and 7. Let's take a set A defined as this. So if a set A is defined as this, so if I want to know the cardinal number, which at the same time is denoted in this form, n of A. So n of A. So it is denoted basically in this format, n of A. So n of A here means that how many elements do I have here? So let's count together. So I have 1, 2, 3, and 4. So I have 4 elements. I can say that the cardinality of set A, or the cardinal number of A of set A, is what? Is 4. Do you understand? Alright, okay. So the next one we're looking at here, number 2, should be union of sets. So union of sets. So alright, let's give a definition. Let's give the definition. So we can say that the union of sets is a single set formed by combining all kinds of sets that we have. You get what I'm trying to say like that? Let me come again with the definition. So a union set, as I've said, will be a what? A set that combines all the elements of as many sets that we have. Do you get what I'm trying to say like that? So that's what a union set is. It's just one type of set that will combine probably 2 or 3 sets, inclusive with all their elements. Are you getting that? Alright, good. Quick one. I just remember that, dropped in my head now. So we talked about 9 types of sets. So let me dash you this type. Let me give you one as a bonus. And that one will be a multi-set. So now a multi-set. So in a multi-set, so I hope if you can find out, you find out that here, all of the elements that we have been listing together, we don't really repeat elements. Yes or no? Or if you have seen before, there is no set that you have here that has its element repeated. Yes or no? So that is what set is concerned all about. So in set, you can't repeat your element, but that law is broken by what? By a multi-set or a multi-set. So a multi-set is a set that can have as many repeated sets as you can have. I guess what I'm trying to say like that. So while in set I can only have, let's say I have set A to be 1, 2, 3, and 4. A multi-set can be like this. A equals to 1, 2, 2, 3, 3, and 5. So this is what? This is a multi-set, because in this set, how many times is 2 repeated? 2 is repeated twice. At the same time again, 2 is also repeated what? Twice. So this type of set that allows repetition of element is known as a what? A multi-set or a multi-set. You get? Now let's quickly rush down back here, which we'll be talking about what? Union of sets. So I told you that a union of sets is one set that is formed by combining all the elements I have from what? From different sets. Yes or no? So it's denoted like this. So that's the denotion of a union of set. It looks like U, but I can't necessarily call it a U, but this is the symbol of union of set. All together. So now let's have an example that talks about union so that we can understand better. Let's say that I have A is 2, 3, 5. All together. A is 2, 3, 5, and I have B also to be 2, 5, 9, or 2, 1, 5, 7, 9. Are we together? Alright, good. So let's say that we have something like this. So if I say I want to find A union of B, which we talk about the combination of the two sets. So what will I have here? I'll have 2, 3, 5, 1, 7, 9. Yes or no? And another thing in set again is that set necessarily does not mean it must be arranged in a particular order. I can sometimes say like that. So I can choose that. I can choose that this set that I have here, I want to arrange it otherwise, which will start from the highest number there to the what? The lowest number. Probably starting from 1, 2, 3, 5, 7, and 9. You can do that if that's what you want. You can also do it in descending order, which will be from 9, 7, 5, 3, 2, and 1. So arrangement does not really what matter. I will get that. But the only thing is that the number of union of sets will compute all the element I have in A and all the element I have in B. Will bring both of them together to form what? One single set. Do we understand? Do we understand? Alright, good. Now let's look at this type of set too. Let's say that I have A to be set of A, B, C, D. Then I have B also to be a set of 1, 2, 4. Then I can also have C to be a set of, let me say, points, star, and plus. So let's say I have something that looks like this. So now if I want to compute A union B union C, so according to the definition of set, it means that that set will just give me one type of set that will what? Combine all of these sets together. So what would that be? I told you arrangement does not matter. So I can have A, B, C, D. At the same time I have 1, 2, 4. At the same time I have point, multiplication, and what? An addition. Do we understand? Do you understand, please? I want you to cheer up now. Yeah. Are we getting it? So that will give you what? A union of a set. That's union of a set. So now let's go on to the second terms that we like to define. So let's move on to another type. Let's talk about intersection now. Intersection of sets. Alright, so while the union of a set will compute everything that both number of sets have, while the union will compute it, intersection won't compute everything. The only thing that is concerned with intersection is what one set and the other set have in common. They are not concerned about whether they have, I'm not joining them together, but intersection will just give me two different sets, match two different sets together, and just pick out the only common terms they have in between them. Are we together, please? Are we together, please? Yeah, if you are still alive and you are still active. High wave your hands. Alright, good. I love that. Let's continue. So for those of us that are going, let's come back. Alright, now let's look at this now. Let's say that I have A to be this set. Let's say that A is 4, 6, 7, 9, and I have B to be also 3, 6, 8, 9. Alright, good. I have this set. So now I want to work with what? Intersection of the set. And also note that intersection is denoted by, it looks like n, but it isn't n. It looks like n, but it is not n. So let's say I want to work with this. So now if I will compute A intersection B, so it means that the set that I will have here will be what A have that B also has. Are we together? So let's look at it. What does A have and B also have? 6 and 9. So for me, I can have 6 and 9 to be their what? To be their what? Their intersection. Are we getting what I'm trying to say like that? Alright, good. Let's take another example. Let's say that you have A also to be 4619. I'm not using 4619 again. Let's say I have okay, 1349, and I have C to be 1234, and I want to compute A intersection B intersection C. So what would this one mean? It will mean that you are looking for one thing or one element or number of elements that A have, that B have, and what C also have. So can we get that? So that means we have 1 and what? And 4. Are we getting this, please? Alright, good. So this is intersection of set. Don't forget, union of set to combine what? Combine both of the elements together. But intersection of set to just what? Pick the only common thing that you have. Form it as a set. Do you get? Alright, good. So number 4, another definition. Let's talk about disjoint set. Yeah, disjoint set. So disjoint set have probably as many definitions as we can give it. Now the first definition that I can give disjoint set is that two sets are said to be in disjoint if they have nothing in common. Yes, if they have nothing in common, that's when you can have disjoint set. If they have nothing in common, I get what I'm trying to say like that. That is one example of a disjoint set. Another example of a disjoint set that you can have is that a disjoint set is a set that the intersection is what? Is an empty set. Yes or no now? Okay, that's another definition we can give disjoint set. So let's create one example of disjoint set. Let's say that I have A is A, B, C, D, and B is 2, 1, 4, 9. So here, so I can say that A and B are what? Disjoint sets, because A does not have anything that has to do with B, and B does not have anything to do with what? A. At the same time, the intersection between this set is what? An empty set. Yes or no? So since this condition is satisfied, then I can say that A and B are what? Are disjoint sets. Do you get what I'm trying to say? Alright, good. So let's continue. Alright, so we've talked about disjoint set. Now, number 5, let's talk about complement of a set. Complement of a set. Now, complement of a set is, alright, let me say it in simpler terms. What a universal set have that your given set does not have. That's what will give you what? Complement of a set. Let me repeat it. Let me repeat myself. Complement of a set will be what a universal set, what it has that your particular set does not have. Are we together? So that will give you a complement of a set. So they are denoted by something like a prime symbol or something that looks like C, but it's not necessarily a C. Okay, now let's create a scenario that will give me complement of a set. Alright, let's say that I have a universal set to be defined as A, B, C, 1, 4. Are we together? Then also I have a set A to be, let me say 2, 4, 1, B, D. Are we together now? So now for me to get the complement of A, so A complement or A prime, for me to have something like this, it means that I want to compute everything that my universal set have that is absent in my what? In my set A. Are we together? So what will that give me? So what does my universal set have that A does not have? I think it's only A and C. So A complement or A prime is what? A and C. Are we getting what I'm trying to say, please? All right, good. So another one here, number 6, is talk about complement of a set. So now let's now talk about the difference of a set. Now I'll talk about difference of a set. So now in the difference of a set, so what will happen in difference of a set? So the difference of a set now is just computing. This time around, when I'm dealing with difference of a set, I necessarily will not be having a universal set to deal with in difference of a set. I don't need that. But here I would have two sets. I want to explain. So you have set 4, 1, 3, 7, and I have set B to be 2, 0, 1, 9, 2019. I love that here. 2019. So now let's say that we have this set A and we have this set B, and I want to compute the difference, which is either written as A minus B or is written as A slash B. Now what this one means is that I am writing all elements that A have, but is absent in what? In B. It's more or less like complement, but the only difference is that in complement you are only dealing with what? Your universal and the set. But in difference you have no business with your what? Your universal set. I guess what I'm trying to say like that. So now A difference of B or A minus B or A slash B means that you are writing out all the elements that A have, but is absent in what? In B. Are we together? Are we together? So from here, so I can now have so what? Let's write out all of those things. So what does A have that is absent in B? A have 4, B does not have. A has 3, B does not have, and A has 7, and B does not have. So this one here, you have computed the difference between what? A and what? And B. Are we together? Alright, good. So let's talk about the other way around. B minus A, or the same thing as A slash of what? I mean, not A this time around, but B slash what? Slash A. So as it implies, what goes around for A is what comes around for B. So it means that I'm writing all the elements that B have, but it is absent in what? That's absent in A. Are we together that? Now let's write that out. So what does B have that A does not have? B has 2, 0, 9. So that's the difference. And I hope you know in real sense, in the real life sense, A minus B can never be equal to what? B minus A. Yes or no? Alright, good. So probably you should not expect that the answer you get in A minus B should give you the same thing as B minus A. Do you understand? Alright, good. Alright. So let's talk about another term that we have to define. So, all right, let's talk about symmetric difference. I want to talk about symmetric difference. So, symmetric difference is combination of your normal difference and the union of sets. That's the best way you can define symmetric difference. It's the combination of difference of sets and the union of sets. Are we together? Alright, good. So it is most of the times denoted as this. Sometimes depends on how the question wants you to have it. Can be written as this or this. Anyhow it is. But most of the time it is written as what? As this. I'll go around and say like that. Okay, good. So what's now the symmetric difference? So if I have A symmetric difference of B, or the symmetric difference between A and B, what this one means is that you are creating a set that obeys this law of A subtracted by B union B subtracted by what? By A. So this is what it means. So it's like this, or probably you use this this symbol or this symbol, but either way, whenever I see any of these symbols and you're in set notation, it means this. Are we getting it? All right. So let's look at probably let's say we have A is A1 2B C3, and I have B to be C1 B2 A3, and let me put 7 here to make it a little bit different, and let me put 0 here to make it a little bit different. I will take that. All right, good. So let's now say I want to compute A of B here. That's symmetric difference between A and B. So what this one means is that I have A subtracted from B union what? B subtracted from what? From A. I will say that. So now, so from here, so let's start getting it one by one. A minus B here should give me, don't forget that it is everything that A have that is absent in B. So that will give me what? That will give me 0. Alright, okay. No, 0 and A is A, not 9. So 0 and A. So I think the only thing that A have that B does not have is that A has 0 and B does not have it. Are we together, please? Alright, good. So let's talk about B minus A. So talking about B minus A, it means that I am writing out everything that B have that A does not have. So let's look at that. I think the only element there is what? Is 7. Yes or no? The only element there is 7. So A has 0. B has C, has 1, and all of those kinds. So the only thing that doesn't have is what? Is 7. Are we together? Alright, good. So let's now combine the two of them together. Now the A symmetric difference of B here should now give me the union of this set and this set, which at the end of the day would give me what? 0 and what? And 7. Do you understand what I'm trying to say like that? So that will give you what? The symmetric difference. The symmetric difference coming once again is giving us this formula. I hope you understand. Alright, good. So any questions so far? Any questions so far? Ask questions now. Any questions so far? Alright, no questions. Alright, yes ma'am. It's also in capital letter. Alright, that's insightful. I love that. Yes. Okay, let's say we want to go by that rule. Alright. That will give me a lot of differences in that case. That means, alright, let me make it fair enough. Let's make this small lettered and this small lettered. I think that makes it balanced like that, right? Alright, good. So this is what the symmetric difference. Do you understand what I'm trying to say like that? Alright, good. Now let's now move on. Before we move on to Venn diagrams now, let's now move on to a scenario where we can have all of these 7 definitions combined together. Let's have scenarios. Let's look at how we can start decoding them one by one. So let's start. So I can call it, what name should we give it? We give it combination of terms or what? Alright. So let me call it, let me give it a funny name. Let me say, let me give it cocktails. Yeah. Yeah, let me say cocktail of what should we call it now? Cocktail of terms. Let's make it like that. Cocktail of terms. It might look a little bit funny, but that'll be like that. So now let's now define a set. Let's say that I have a universal set defined as 1, 2, 3, 4, 5, 6, 7. Are we together? Then I want to deal with A, which is a set of, let me say, 4, 6, 5, 1. Then I also have a set B, which is 2, 1, 3, 7. And I have a set C to be 0, I mean, no, we don't have a 0 yet. Let's say 3, 0, 1, 9. So let's have something like this. We want to have something like this. So let's say that we have our universal set defined in these terms, and we have all of these things in place. So from here, let's evaluate the following. Let's evaluate number 1, A minus B complements. Let's deal with number 2, B union A intersection C complement. Let's have number 3 to be A union B complement minus C. Yes, let me put this one in bracket. Then everything complement. Then number 4, let's say we have the symmetric difference between A and B union symmetric difference between B and C. Then let's make the case look more weirder. Let's say I have 5 to give me A complement difference of B minus C. Then everything here, let's say, let me put complement here. Then I have intersection of A minus B of C complement again. Yeah, it looks weird, but let's have it this way. So it might look as weird as this, but let's break it down. It looks fun now, isn't it? It looks fun now, isn't it? Alright, let's play with it. Let's play with it. Are we together? So now, playing with this. So playing with this now. So let's start. Number 1. So now, the key word to this thing is that if you want to master it well, is that you start taking it step by step. Are you getting it? Now, if I want to do this now, what will be the first thing I'm supposed to look for here? A minus B. So please don't go and make the mistake of finding the complement straight up. I get it. Now let's now look for A minus B. So let's for that set A minus B. So talking about the set A minus B will mean that I will have to look for, okay, yes, the set. I will have to look for what A have that B does not have. So what is that? 4, 6, 5. So A have 4, 6, and what? And 5. That will be the difference. Yes or no? Alright, so with this also, A minus B, then let's now look for what? The complement. What would that complement give you? The complement will give you that everything that my universal set have, that this particular set here does not have. So what would that give me there? So I have 1, 2, 3, and what? And 7. I think that's, so I finally computed A minus B complement. Do you understand? Alright, number 2. So number 2 looks, okay, I think I did the difficulty in, I did the question in order of difficulty from simple, you understand, you move higher and higher and higher, you get. So now let's now look at it. So which one am I doing first? You can probably decide to do B union A first. So what's B union A? That means I am computing everything that B have and everything that A have. I'm putting them together. Yes or no? So now let's look at that. So B union A there should give me 1, 2, 3, 4, 5, 6, 7. That is beautiful because B union A here is the same thing as what? My universal set. Yes or no? Alright, good. So now let's look at the next one. C complement. Now what does C complement mean? C complement means that I am writing everything that is present in my universal set but absent in my what? Set of C. Right? So let's write that out. So I have 1, okay, 1 is there. So I have 2, 4, 5, 6, 7. Alright, good. I have this. Then from here, so now what is the next one? The next one I said that I should find the intersection between this set and the next set. So I can now have B union A, are we together? Intersection C complement should now give me that what is common between this one here and this one here. So what do they have in common? 2, 4, 5, 6, 7. Do we have a set similar to this there? Nope. That's the answer. I hope you're getting it. Alright, good. So the next one here will be number what? Number 3. So what's number 3 now? So we have A union B complement minus C, everything complement. So to start picking it piece by piece, I'll start by dealing with what? B complement. Now what is B complement? So B complement is picking everything that your universal set have as abstract in B. So what would that give me? So that will give me 4, 5, 6. Alright. So I'll have 4, 5, 6. Okay. So the next step is to look for the difference between B complement and what? And C. So that means that I am writing out everything that B complement have that C does not have. And I think it is everything, which is what? 4, 5, 6. Yes or no? Yes or no? Alright. Then the next one here should now be, let's now look for the union of A and this particular set I've just found. So now, what would be the union? So, A union. So that means I'll write everything in A and everything in this set. So let's just arrange it in ascending order. So what can I have here? I can have 1, 4, 5, and 6. Right? Alright, good. So from here, then the next thing that I can now have is that I am now supposed to look for what? The complement of this set. So now the complement here, which will be A union B complement minus C. Are we together? Are we together? So what would this give? What would this give me? So this one here should give me 2, 3, and 6, right? 2, 3, and what? And 7. That's the end of the answer. We see that it's simple, right? It's simple, right? Aha. So that's how math is. Basically, math is simple. Now number 4. Okay, in number 4, so now we have the symmetric difference between A and B union the symmetric difference between B and C. So let's start taking it step by step, which will start with A symmetric difference of B, right? And what does this formula compute? This formula computes what? A minus B union B minus what? A. Yes or no? Alright, good. So let's look for A minus B. So A minus B here means that I'll be finding everything that A have that B does not have. So which is 4, 6, and 5. Right? Okay, so the next one is B minus A. So B minus A will be writing everything that B have that A doesn't have, which will be 2, 3, and 7. Right? Alright, good. Now let's now look for A symmetric difference of what? Of B. So which will be the union of A minus B and what? B minus A. So what set will that compute? That will compute 2, 3, 4, 5, 6, 7. Okay. This is interesting. Right? Okay, now let's go to the other part. So permit me to move to the second part of the board. So moving to the second part of the board here now. So we can now have so we've dealt with A, the symmetric difference between A and B. Now let's now deal with the symmetric difference between what? B and C. So now the symmetric difference between B and C. So now what would the symmetric difference give us? So it's the same as computing B minus C union what? C minus B. Let's start. So what is B minus C? So B minus C is writing everything that B have that C does not have. So what is that? So I have 2 and 7. Good. So the next one is what? C minus B. And C minus B is that I'm computing that everything that C have that B does not have, which is what? 0 and 9. Okay, good. So let's now find B symmetric difference of what? Of C, which should now give me 0, 2, 7, and what? And 9. Are we together? Alright, so from here, so let's now combine the final answer, which is what? Let me move here a bit. So that will give me A symmetric difference of B union what? B symmetric difference of what? Of C. So what is A symmetric difference of B here? I had 2, 3, 4, 5, 6, 7. Right? Then union, what's the next set I have here? 0, 2, 7, and 9. Then from here, so let's find their union. So what would their union be? 0, 2, 3, 4, 5, 6, 7, and 9. That's beautiful, right? Okay, good. So now we've dealt with number 4. So let's do the weird looking number 5 question. Looks weird now. Let's do the weird looking number 5 question. Alright, so number 5. So now number 5 looks looks a little bit weird. But it looks as if we've done part of it here sometimes. Have we? No, I don't think we have. So let's start. The first thing there I'm looking at is what? Let's start picking it piece by piece, which is what? A complement. So let's find A complement. So I can say that A complement here. So what will A complement here give me? So A complement here will give me, let's do it together. So I have 1, 2, 3. Okay, 1 is not there, right? Thank you. So instead of 1, I can put 7. Right? 7, 2, 3. Is that whole? I think that's all. Right? Okay, that should be all. Alright. So the next one I'll be looking for is B minus C. And I think I've done B minus C here. Let's ease the stress of ourselves. So I can say that B minus C should give me 2 and 7. Yes? Right? Alright. Also, the next one that I have here is now that I want to find the symmetric difference between A complement and B minus C. So let's deal with that. So A complement, symmetric difference of B minus C. So what would this mean? It means I will have A complement minus what? B minus C, right? Please don't go and do your normal algebra. Minus open the brackets, then you have C minus B. No. This minus here mean another thing entirely. I get what I'm trying to say. Then here I have union. What do I have? B minus C subtracted by what? A complement. Okay, so let's start. So I can now have A complement minus B minus C. I hope you know what this will mean. This will mean that I will compute the difference between, what's that now? I'll compute the difference between A complement and B minus C. That is, what A complement have that B minus C does not have. So what would that give me? That would give me 2 and what? 3, right? All right, okay, just 3 alone. Yes, nice. So that will give me only 3. Okay. Then the next one, which is B minus C subtracted from A complement. So that will give me, what does this one have that this one does not have? What would that be? Yeah, that would be an empty set. So let's deal with that as an empty set. So now if I will combine this together, so A complement symmetric difference of B minus C will now give me what? All that elements give me? It will give me only 3. But I hope you know that despite the fact that I have 3, at the same time I also have what? An empty set in 3. Yes or no? Do you understand? Alright, good. So I think I'm done with the first part. Okay, now to now round it up. So that means I'll have to find the complement of this set. B minus C complement. So that means I'll write everything in my universal set except from what? Except from 3. So that will give me 1, 2, 4, 5, 6, 7. Do you get that? Alright, good. So I hope you're not bored, because I feel excited as I'm doing this thing. It's interesting now. So now let's start with the second one, and with second one, which is a minus b symmetric difference of c. And let me see, I think to have the case softened, I have done b symmetric difference of c. Yes or no? So what's b symmetric difference of c here? We did that and we had what? 0, 2, 7 and what? And 9. Right? Right? Okay, good. So now the next thing that we have to do here is to what? To look for what? To look for the complement of this set. So let's look for the complement of b, c here, complement. Then that means I'm writing, okay, let's write. So what do I have there? I have 1, then I have 3, 5, then I have what? 6. Yes or no? Okay. Then the next one here is, let's take the difference of that. So I now have a minus b symmetric difference of c, complement. So what does that mean? It means I want to look for the difference between a and this one here. Yes or no? Does a have that this set here does not have? Is there anything? Is there anything? Alright, then I can round over to give me as what? An empty set. Yes or no? Okay, good. So that means I'm done with this part. And I think from the first part, what was my answer? I had 1, 2, 4, 5, 6, and what? 7. And the second part there is what? An empty set. Yes or no? So now to now combine everything together, which means I have to find the intersection of this one here and this one here. So what will be the intersection? Eh? The empty set, yes. The answer here will be what? An empty set. Do you understand? So we did all of this just to arrive at an empty set. Please, do you understand? Okay, probably if you have not written it, you can write it, right? I mean now. Okay, let's write that. So before we move on to the next term, which is Venn diagrams. Any questions so far? Any questions so far? All right. Okay, so let me just leave the stage so that I have the chance to write. Yes, my sister. All right, I have questions. The complement of what we did last here. Okay, this one here. Yeah. Okay. Oh, thank you. I didn't see that. Thank you. Thank you. That means that after I'm done with this, at the end of the day, everything still had what? A complement. Yes, thank you. I didn't see that. That a minus b's symmetric difference of c complement. Everything now has what? Complement. And what would I give you? That will give you what? Your universal set. Yes or no? So let's write your universal set, which is 1, 2, 3, 4, 5, 6, and what? 7. Okay, so I think so now we can I find the intersection now. So what will be the intersection? The intersection here will now give me, let's go. So that will give me 1, 2, 4, 5, 6, and what? 7. Okay, thank you for that observation. Thank you very much. Alright. A couple of times. Alright. Are we done from this first part? Okay. Alright. So now, while we've done cocktail of terms, as the name implies, so probably when you get home, so that you can practice more, just as long as you know the principles, you can just sit down in your room and create as many problems as you can create. At the end of the day, you should solve your problems, actually. You created them yourself. Yes, ma'am. The answer should be A. I can't. The answer should be 3. Intersection. Alright. It said everything we had here, intersecting everything I have here. So everything I had here was 1, 2, 4, 5, 6, 7. I think by the time I did everything here, which was the workings is here. Then when I did a minus b, whatever this is here, I think I had my universal setback. Yes. Then intersection is finding what one set have in common and the other set have in common. Yes. Then that means I'm computing what this one have and this one also have, and it appears to be that it is still everything here. Do you understand? So I think that should be my final answer. You get now? Alright, good. So as I've said earlier on, once you get home, create as many problems as you can create, and don't leave until you solve the problems you created. You see, I did my own here. I created the problems and I did what? I solved it. So do yours also. Let's talk about Venn diagrams. Right? So Venn diagrams. Venn diagrams. So to take a little bit, to do history on Venn diagrams, you can say that Venn diagrams is, I think it was created by John Venn. I don't know who did it, but the name Venn diagram was named after the person that created it. Are we getting it, please? Alright, good. So now, why Venn diagrams? What do we need Venn diagrams for? What is its usefulness? So we can say that Venn diagram is just a pictorial representation of sets. So that's the definitions. So if you have sets, the way you can represent sets with pictures is what? Venn diagrams. You need Venn diagrams to represent sets. I get what I'm trying to say like that. Also, there are two types in this part. That will be probably when you are dealing with 2 types of sets and you are dealing with what? 3 types of sets. Although there are some Venn diagrams that can lead you as many as dealing with 4 types of sets, 5 types of sets. I've not seen one before, just saying. So then let's talk about the first type. So, and yes, let me state that before I continue that. Whenever you're dealing with Venn diagrams, you are free to use any shape of a preference. You can use pentagon, you can use decagon, you can use kite, you can use as many shapes as you want to represent your set. You are at liberty to deal with that. But I would just say that for easy sake and for easy understanding, it's best to use your normal rectangle and your what? Circles as your what? Subset. Yes or no? Okay, good. Let's start with that. So now let's now start drawing some basic concepts. Yeah, some basic. So let's say that the first Venn diagram here, let's say we have 2 sets, or let me give it 2 sets Venn diagrams. 2 sets Venn diagrams. Okay. So now let's say that, so the first one here I can have as many as I can have. But let's say I have this and I have this. So let's go the first set here A and the second set here B. Are we getting it? So now let's say that, so from here, if I shade this part, now if I shade that part, that means I am only concerned with what A have and B have in common. So from that part here, I can have A intersection what? B is what I've represented in that Venn diagram. Do you understand? Okay, let's move on. Please note that what's it called? That rectangle that I'm drawing outside is telling you of your what? Of a universal set. You understand that? So please note it. So and also, okay, let's have this. I have A here and I have B here, and let's say I shade everything. Are we together? So since I've shaded everything in A and B, so that means I'm talking about what? A union what? A union B. Right? Okay, good. So let's have another one. So let's talk about the differences. So let's say I want to find the difference between alright, I have A here, I have B here, and you have a Venn diagram that states that everything you are shading here is strictly A alone. So can we guess what type of Venn diagram that would be? A minus B. Thank you very much. It will be what? A minus B. Because what does A minus B tell you? A minus B tells you to compute everything that A have that B does not have. Are you getting it? So which will be everything shaded here. And on the other hand, so I can have something like this, and I can also have something like this. Then I have A, and I have B, and I shade here. Okay, I have another idea. Thank you. It's dropped in. Okay, good. So from here, so what does this one tell you to? This one is telling you about what? B minus A. Okay, let's elongate the matter. So from here, so let's say also we have okay, and I have A here, and I have so what does this one tell you? A complement. Good, that's beautiful. A complement. And what is A complement telling you about? A complement is just telling you about everything that your universal set have that your what he does not have, right? Okay, good. So okay, all right. So we can. There are many basic Venn diagrams you can have, but these are probably the most basic. Let me now teach you how to create complex Venn diagrams with these ones that I have here. Yeah, complex. I love complex. So let's say now I want to create a Venn diagram that has this information. A minus B complement. I think that should be even easier to create. Yes, because A minus B complement. It looks easy, but let's deal with it. So first thing first is that let me teach you the step. So whenever I want to create a complex diagram that does not really have is that it's not from your basic ones that you have. Let's just construct a mini Venn diagram. So from here I can have something that looks like this, and let's just construct a mini Venn diagram. I don't know what it is yet, so let me label this one to be A, let me label this one to be B, as I told you. So let's label everything outside here to be your universal set. Yes or no? Okay, good. So let me just do a minor labeling with numbers, which will give you here to be 1, 2, 3, and what? And 4. At your discretion, pick the numbers at your discretion. So from here, don't forget that your universal set is everything in this rectangle. So what are the numbers in that rectangle I can have here to be 1, 2, 3, and 4? Please permit me, I won't be putting the curly brackets, but we all know that this means a set. Yes or no? Alright, good. So let's talk about A also. Then A also. So what are the elements that A have? That is what? 2 and 3. And what does B also have? 3 and 4. Okay, so I have gotten this. So let's now deal with this here. So from here I can have, so I have A subtracted from B. So A subtracted from B means that I'm writing out everything that he have that what B does not have. Yes or no? Which is 2. Yes or no? Then since I have everything to be 2, don't forget what's the last thing I'm looking for? The complement. So I can have A minus B complement. So what will be the complement here? That is 1, 3, and what? 4. And I said it looks easy to construct, but this is it. So this 1, 3, and 4 means every part on this board I'll be shading will be what? 1, 3, and 4. So I won't shade what? 2 alone. So let's go on with that. So I'm shading everything inside. Okay, I think I'll shade 3. Alright. I'm shading 3. I am strictly meticulous so that I don't have to shade 2. So, okay. So this will be the Venn diagram that represents what? A minus what? B complement. Do you understand? Okay, so as I said, you can have complex diagrams. So let's create more complex questions, and okay, let's create them together. You help me solve. So once you help me solve, I want to help you solve your problems actually. So can we come to this part? Yes, sir. Yes, sir. Okay.
And the A2 is intersect with B.
Okay, all right. I get your question, but this time around, as I said, the basic ones is what we have here, right? So, but this one that we have here does not follow our basic knowledge. Shall I get what I'm trying to say? So, for me to ascertain what this one will look like, I have to bring it out of Venn diagrams to your normal set knowledge. Shall I get what I'm trying to say like that? So like if you say I had probably something that it's from here, and I can easily construct it. But for me to have something as complex as this, which does not really follow your basic law, you just have to bring the whole idea into your what? Normal set theories. So that you can easily understand. Because you might think that because A intersection B here is this, and you are looking for, A minus B here is this, and I'm looking for the complement. So you might think that since it is complement, and then when I shaded the complement, I shaded everything except that one. Wait, it actually answers the same law here, right? Because here, when we talked about A complement, I shaded everything except A complement, right? And also, if you look at this one here, if I'm dealing with A minus B complement, so that means I'm shading everything I have except what? A, which is exactly the same thing I've done here. Yes or no? So just a simple way to just, it's not everybody that can have that sharp eyes to quickly understand. So you can just create this. This is faster. Just create your number, the shapes you have there, and follow the law with your normal basic set theory, and you continue. Are we together? Alright, good. So let's look at another one here. Okay, so let's look at probably when we have something like this, which is B complement minus A all complement. Now, want to find out what this will look like. So you have B complement minus A complement, right? Okay, so let's look at it. So, as I said initially, what do you have to do? Let's create a prototype first. I have 2, which will have a circle, right? Then I have here to be A, then I have here to be what? To be B, then I can number at my discretion, pick numbers at any of your choice. 1, 2, 3, and what? And 4. So as usual, my universal set here will be 1, 2, 3, 4, right? Then my A here will be 2 and 3. My B here will be 3 and 4. Okay. So now let's start picking it step by step. So the first thing I'm dealing with here is what? B complement. So B complement is giving me 1 and what? 2. Right? Then the next one, let's find B complement minus A. That means that what B complement have that A does not have, which is what? What B complement have that A does not have? 1. Are we together? Oh, okay. Okay. Then what is now the next one? The next one is now that I will now look for the complement of this answer. So what will be the complement here? That will be what? 2, 3, and what? 4. And if you can observe, 2, 3, 4 is the same thing as shading what? A union B. Yes or no? Yes or no? So let's do that. So that would be what represents B complement minus A all complement. So the last one we'll do here, before we proceed and we increase the difficulty of the problem now, that's what we'll do here is, let's not learn, no, we have been dealing, we have not done symmetric difference, right? Let's look for symmetric difference. Okay. So for the symmetric difference, so let's say you have a symmetric difference of what? Of B. Should I leave it like this or I should make it more complex? Let's do it gradually before we increase the complexity. So let's look for this. I hope, okay, as usual, let's create the prototype, right? Then this, so you have A, you have B, you have 1, 2, 3, and what? 4. Then as usual, you have your universal set to be 1, 2, 3, 4. You have A to be 2 and 3. You have B to be 3 and what? 4. Okay, I think we are very fast with that. Right? So now the next one that we will be dealing with will now be A symmetric difference of what? Of B. Right? Now what's asymmetric difference of B? What's the formula? Asymmetric difference of B is saying the same thing as A minus B union what? B minus A. I think I can see the answer from here. But let's work. So from here, so what is A minus B? So A minus B is what? What A have that B does not have, which is 2. B minus A is what B have that A does not have, which is what? 4. Alright. So they are union now. So A symmetric difference of B would give me what? 2 and what? 4. So everything I'll be shading on the board here will be what? 2 and what? And 4. So it should be 2 and 4. I hope you get that. That's how it should look like. So I won't shade everything outside and I won't shade everything inside. Okay, let's increase the complexity now. We said we should do it step by step. Let's go higher. Let's jump. So now what if I have A complement, B complement, then I have the complement? How about this? How about when everything has the complements? Let's go now, right? I can see the excitement in our face. So let's continue. So as usual, you create the prototype, right? Then you have A and you have B. Then you have 1, 2, 3, and what? And 4. Then you have your universal set, which is 1, 2, 3, 4. Your set A is 2 and 3. Your set B is what? 3 and 4. Okay, so first thing first, let's deal with A complement. So what is A complement? A complement is 1 and 4. Then what is B complement? B complement is what? 1 and 2. That's beautiful, right? So let's now look for, okay, the symmetric difference of, okay, let me move here so that we can see it. So I have A complement symmetric difference of B complement, which should give me A complement minus B complement union B complement minus what? A complement, right? Okay, so from here, so what is A complement minus B complement? So what will that give me? So that's 4. Do you know what it means? It means that everything that your A complement have, that your B complement does not have, right? The next one, B complement minus what? A complement. So what will that give me? That will give me 2. Alright, good. Then A complement symmetric difference of B complement should give me, what's that? 2 and what? And 4, right? Then the last one, which means I'm finding the intersection of this fine boy here. So that should give me what? That should give me what your universal set have. Now this one, so that will give me what? 1 and what? 3. So let's shade that. We're shading that, so 1 and 3, I have everything here outside. Are we together? Then I'm shading what again? 3. So that should settle that, right? Right? Okay, good. So now we're done with 2 sets Venn diagrams. I hope you understand. Alright, so the next phase, let's increase the eats. So now let's talk about 3 sets now. 3 set Venn diagrams. So 3 set Venn diagrams this time around. That will happen when you have 3 subsets. So let's go. So from here I can have, let's create the basic ones as we did for the other ones. The basic ones here, 1, 2, and 3. Then I'll have A here, I'll have B here, and I'll have C. Right? Okay, good. So now let's find the basic ones first. So this one here, shading everything that is inside here. Shading everything that is inside here. Look at it. If you can observe, find out that everything that is inside this section here is the same thing. This section here is representing A, is representing B, and at the same time is representing what? C. So with that section I can say that I have drawn A intersection B intersection what? C. That's what that one look like. Okay. So the next one, okay. So this one is A, this is B, this is C. Are we together? Okay. So from here now, so let's imagine I shade everything here. So shading everything here. If I shade everything here, so what does that mean? That means I've drawn A union B union what? C. We together? Okay, so from here now, let's now move on to, let's increase the heat. This time around, let's do something a little more spicy. Let's add pepper to it. So next one here that I want to do is, okay, so now I know, because these are the 2 basic ones we can have. So now let's say from here I want to do A intersection B union C. Okay, let's do like this. So what does that mean? First of all, that means, do you know where you shade? No, I can't guess. I don't want to guess wrong. So let's create a prototype for it. So we have 1 and we have 2 and we have what? 3. Are we together? Yeah, so from here, let's label it as A, let's label it as B, and what? C. Now, as I said, let the numberings be at your own what? Discretion. So, but for me, I choose to number it this way: 1, 2, 3, 4, 5, 6, 7, and everything outside here will be my what? Will be 8. So I want to solve this first. I don't know what it will give us, but let's find out. So from here, I can say that, let's start. So my universal set should give me what? 1 to 8. Yes. Right? Then what is A? So A is 1, 2, 4, 5. B here is what? 2, 3, 5, 6. The next one, which is C. C is what? 4, 5, 6, 7. I love the excitement in our voice. Alright, so now let's now take it step by step. So the first one that I want to do here should be B union C. So let's start. B union C. B union C here should give me what? So B union C should be what B have and C have in common, which is B union C should give me 2, 3, 4, 5, 6. Okay, yeah, and there's a 7 there, yes. And also, I want to now compute A intersect B union C. So from here, what do I have? So what does A have in common and this one have in common? So that should give me 2, 4, 5. So that means the only thing I'll be shading here with this section, so I can have this, yeah. So that will be the part that represents A intersection B union what? Union C. Are we getting it? Okay, good. Should we increase the heat? Yes, let's increase the heat. So increasing the heat here, let's say let's deal with. Now let's add complements. Let's add complements now. Okay, let's do it like this. Let me put one complement. Don't let me put B here. Let me put just one complement. So let's deal with that. So as usual, so let's have to draw your prototype as usual. So you have this to be like this, second like this, third one like this, which is A, and this is B, and this is C. And same way I number this one, which is 1, 2, 3, 4, 5, 6, 7. Yes or no? Okay, so to ease myself of the stress of writing out the same U's, writing out the same V, since I will be following the same constant stuff, so I don't want to write it out again, right? So let's just go straight to solving. Is that okay by us? So let's go straight to solving. So going straight to solving here. So what will A complement give me? So A complement will be everything that my inverse set have that A does not have. That means except from 1 to 8, I will be removing 1, 2, 4, and 5. So that should give me 3, 6, 7, 8, right? Then the next one is, so let's look for it, A complement minus what? Minus B. So A complement minus B means that whatever this one have, that B does not have, right? And I think that is only 8 and 7. Then next one should not be the whole of this union C. So dealing with the whole of this union C, that means what will I have at the end of the day? Well, I have 4, 5, 6, 7, and 8. That means 4, 5, 6, 7, 8. So that means I'll be shading. It appears that I'll be shading everything outside, including C, right? Shading everything outside, including C. Okay, sorry. Okay, so the only thing I didn't shade here is what? 1, 2, and what? And 3. I hope you get. Okay, good. So one more increasing the heat, and we continue. Is that okay by us? Okay, let's take a very high jump to something that is, something that is breathtaking. Alright, so now let's deal with this. On this case, let's deal with this. Are we ready? Yes. Alright, good. Let's look at, okay, downloaded. So I have A complement, symmetric difference of B complement minus C complement. Then here I have complement too. Alright, to me this doesn't even look hard. So let me increase the heat again, but let me leave it like this. So let's deal with this now. So I want to, now this one look a little bit like it's out of our league. Now we have A complement symmetric difference of B complement minus C complement, then everything complement. So let's start taking it one by one. So as usual, what will I have to do? Let me create the prototype first. Let me create how it should look like. I believe it should look like this, which is 1, okay. This is A, this is B, and this is C. Then this is 1, this is 2, this is 3, this is 4, 5, 6, 7, and what? 8 outside. So as usual, I know what my universal set is, I know what my A is, I know what my B is, I know what my C is. Is that okay by us? So from here, so let's just go straight to what? To solving. So from here, what is A complement? A complement, I think we did A complement there, which should give me 3, 6, 7, 8. Okay, I have not done B complement, but let's do B complement now. So B complement is what my universal have that B does not have. That will give me 1. I can have 2, I can have 3, I can have 4, I can have 5 and 6, I can have what? 7 and what? 8. Yes or no? Then the next one is that let's find B complement minus what? Minus C, right? So now what's B complement minus C? It means that what B complement have that C does not have, and it appears to be everything except 4. 1, 7, and what? 8. Yes or no? Right? What? Okay, C has 7, so that will be 1 and 8. Okay, that's very good. Okay, so the next one is, so let's look for the complement of this answer. So if I look for the complement of this answer, which is B complement minus C, everything complement should give me everything in my universal set except from what? 1 and 8. We should start from about 2, 3, 4, 5, 6, and 7. Yes or no? Okay, so the next one is that we are moving on to the symmetric difference part. So the symmetric difference here is what? A complement symmetric difference of B complement minus C, everything complement. So so from here, this one is the same thing as saying we have A complement minus what? B complement minus C complement union. What do I have here? B complement minus C all complement minus what? A complement. Yes or no? So from here, so let's now have it. So what is A complement minus B complement minus C all complement? So what does A complement have and this fine boy here does not have? I mean, no, it's here, right? So what does A complement have that this one does not have? I think the only element there is what? 8. Don't forget, what does this one have that this one does not have? That is what? 8. I was scared there for a bit. Then the other one, which is B complement minus C, all complement minus what? A complement, which should be what everything here have that this one does not have here, right? So what this one have that this one does not have? So what will that be? So that will be 2 first, right? That will be 4, 5, right? Then what else again? I think that's all. Yes? So at the end of this, so let's combine everything. So A complements B complements minus C all complements, right? So everything here should be giving me what? 2, 4, 5, 8. Then let's now look for the intersection of this. I mean the complement of all of this. See, all complements, everything complements. So that means I'll write everything in my universal set except from what? 2, 4, 5, and 8. So that should give me 1, 3, I can have 1, 5, I can have 6, I can have 7, and I can also have what? 8. No, I can have 8. So that's it. So what am I shading now? I'm shading 1, I'm shading 3, I'm shading 6, and I'm shading what? 7. So this is 1. What else am I shading? I'm shading 3. Then the next one I'm shading is what? 6. Okay, let me shade 6 also. Then finally, I'm also shading what? 7. Alright, so the only one I did not shade here is what? 2, 4, and what? And 5. Do we understand? Do we understand? Are you getting bored? Don't be bored now. So let's start. So we're done representing stuff on Venn diagrams. The other part here of Venn diagrams is how you can represent real life problems on Venn diagrams. So okay, so we can have questions on that, how we can represent real life problems on what? On Venn diagrams. Is that okay by us? Is that okay by us? Should we start? Oh, not yet. You still writing? Okay, let's be quick with our writings. I believe we're done with this part. Are we? Okay. So let's start. Let's pick it Venn diagrams by Venn diagrams. Now we started from 2 Venn diagrams, then we moved on towards 3 Venn diagrams, right? Right? Okay, so let's start picking it. So let's move from 2 also, then we'll proceed towards 3 Venn diagrams. Okay. The first one here that I have is, let's take this example. Okay. Let's taking a look at this example. So I can have that the number of people who takes English in a class of 30 students is 17. The number of students which takes math is 18. Question is, how many students takes both? Okay, good. Now we have something like this, which is that a number of people who takes English in a class of 30 students is what? Is 17. And are we together? The number of students which take math in that same class is what? Is 18. Are we together? Now the question is now asking us to find how many students takes both mathematics and what? And English. So let's start. Solution. So most of the time it is best to use word problems to quantify or describe. Use your normal words to describe it. So from here I can say that my universal set here is what? 30. Yes or no? Okay, good. Then I can say that E is a set of people taking English people. How many elements do I have in E here? I can say I have 17. Yes or no? And at the same time, in my math is how many here? I have what? 18 to be math. Yes or no? And at the same time here, the question is asking me to find how many people take E and what? And M. I don't know that. So let's represent that. Let's represent this information on a Venn diagrams. I personally would not like to go past this place because people at the back. So let me move here. So moving here now. So let's draw a Venn diagram. So from here I can have a sample like this, which is I have 1 and I have 2, right? Then my universal set here, it can be what? 30. Are we together? Then here I can have E to be what? 17. M here to be what? 18. Now the question asks me to look for what is in between here, which is, let me give that as what? As X. Are we together? Alright, good. So let me call our attention to something. Now from here, I hope you know that everything in this diagram here, everything here is meant for E alone. Yes or no? Everything in this circle here is meant for E alone. But out of that circle that is meant for E alone, X has taken a part of it. So if X has taken a part of it, so that means the remaining part here should give me what? 17 minus X. Are we together? Now also, the next one here is here. Everything that is here belongs to what? M. And out of that M, X has taken part. So the remaining part here will give me what? 18 minus what? X. Are we together? Then from here, I max to look for x, which is what is in the middle, obviously. Then how do I do it? Whenever I have scenario like this, everything here must be added up to give you what? Your universal set. Yes, probably if we enter algebra of sets, then we'll now have to start dealing with all those petty laws. Although we might prove some, and we might not prove some, depending on us. So let's start. As I've said, whenever I have scenario like this, try as much as possible adding here must sum up to what? 30. So let's do that. So what can I have? I'll now have what? 17 minus x plus what? 18 minus x. Then I put together. Then so from here, everything must sum up to give me what? 30. And if everything is summing up to give me 30, then what do I have? I have these 2x here to be cancelled out, obviously. Then I have 17 plus 18 here should give me what? About 35 minus x equals to what? 30. Then if you can play with algebra very well, you're very good in algebra, taking one side to the other side, then what will I have here? I have x equals to what? 35 minus 30, and x here should give me what? 5. Good. So that means the number of people that can take math and English is what? Is 5. So if I have 5 that can take math and English here, I can just easily, without any stress, put x inside this equation and get another new Venn diagram. Right? So let's do that. So create another Venn diagram based on the information I have here. Should now give me something that looks like this. So from here I have your E, which is equals to what? 17. I have M, which is equals to what? 18. Your universal set here is equals to what? 30. So I put together. So from here, how many do I have here? I have 5 in the middle. Then if I have 5 in the middle, so what is this space? This space I had here was 17 minus 5, or 17 minus x, and my x is 5. So 7.5 will give me what? Yes or no? So that means that each student. So let's go and do now. Some of us might have. Okay, let's put. So let's say, okay, in a party, 15 people likes rice, and 20 people likes beans. I would get that. Also, 8 people, or 8 people, yeah, or 8 persons, anyway, 8 people likes rice and beans. I would get that. Now, question is, how many persons, or how many persons attended the party? How many people attended the party? How many people attended the party? So now, from here, we have that 8 persons. So let's represent it in the Venn diagram. Are we ready? So let's start. So I can say the first thing first, that how many people like rice? Rice is what? 15. Are we together? And how many people like beans? Which is what? 20. How many people like both? I have 8. So that is R and B here should give me what? 8. Yes or no? Okay, so from the next part here, so let's represent it on the Venn diagram. I don't know how many people attended the party. I don't know. So that's what I want to find. So let's find how many people attended the party. And we have 1 and we have what? 2. Are we together? So this one here, let's say this is rice. This is what? Beans. So rice here is what? 15. Beans here is what? 20. Are we together? Then so from here, let's start. So what do I have in between here? I have what? 8. Good. let us in team of 20 players, right? Okay. 15 players are tall, 18 players are short. Six players are neither, or let me use neither. 16 players are middle height. That is this middle height here. They are the ones that are talking about person that they are not too tall and they are not too short. They are staying in between. So now let's now look for, okay, middle height. Full stop. Now how many players? How many players are yes. Okay. Let's have something like this. Now this time around, this looks like alright. So let's see with this. So let me start by doing solution
Underneath here, so I have my universal set here should give me what? What is my universal set here? 20, right? Then how many tall persons do I have in this place? I have 15 tall. How many short do I have? I have 18 short. And how many middle height do I have? That's middle height, and that's T intersection. Okay, T intersection S, which is what? 6. Now the question asks me a very weird question, which is that how many people do I have that is not even on the team? So that will be, okay, let me just use that. Not on the theme. How to get that? So from here, we can have a diagram in this form, which is this. So let's draw a Venn diagram here that represents that. So I have something like this. Tall here. Can have short here. So okay. Now when they are talking about people that are not on the team, are we together? When they are talking about people that are not on the team, so they are telling you to find persons that are what? Outside here. That's X. When here with the word not, so they are talking about people that are what? Completely off the grid. And so from here, how many people do I have there? I have what? 20. Yes or no? Okay, good. So from here, I have, how many tall do I have? I have 15. How many short do I have here? I have 6. I have 18. Good. Now what do I have in between? I have what? 6. Yes or no? So out of that 6, don't forget, out of that 6, I'm picking out 15. Right? Then let's say I have this one to be 15 minus 6 to give me 9. Then this one here is what? 12. Yeah. Okay, 12. Okay, good. 12. So from here, let's look at this. So now the thing is that I don't know how many people that are not on the team. That means I must what? That's hard. And everything must give me this 20 here. So what do I have here? I'll have probably 9 plus 6 plus 12 plus X here should give me what? About 20, right? Okay, good. Then from here, if you add up everything here, you have what? 20 plus X equals to what? 20. Is that right? No, it's not like that. Abby? 9 plus 6 is what? 15. 15? Okay, that's 27. Alright. 27 plus X equals to what? 20. Then from X here, you can have what? Negative 7. Now, here, you can have negative answers in your what? In your set. So, touching this question here, let's say and this one is x, and the people that is here also, let me make it twice the amount. Then let me change the old look of the question here to give me here to be x and 2x, right? Okay, so from here, what do I have? I'll have 15 minus x, 8 minus x, and I have this one here, right? Hello, are we together? Okay, so from here, and I have 15 minus x plus x plus, let me increase the number here, plus 18 minus x altogether plus 2x here should give me what? 30. Then so from here, this one's here should cancel out. Then I have 15 plus 18, which is what? 35 plus what? Right? Okay, 33 plus x, which equals to what? 30. Yes or no? 15 plus 18 here is 33. Minus x plus x here. Let me increase this one then, sorry. To 40. Alright, good. Minus x plus x here. Are you getting it, please? Okay, good. Then so from here, I think it's okay like this. So I can have that my x here is equals to what? 7. Yeah, good. So I have x here to be 7. So if x is 7, the question asks us for how many people that are not on the team. So if I want to write that out now in a new look, so I can have 1, 2, which is what? 15. Your universal set here is what? 40. So I changed a lot of variables here. Okay, I think that's better. So I have to change the question here. Middle right, and the number of people not on team is twice those at middle light. Then question, how many players are not on what? On team. So I think I've touched the question like that. So let's now reinterpret. U is 40 years. So I have this one to be x. Yes or no? Okay, so if this one is x, so I have my middle here will be what? 7. The one outside here will be what? 14. Yes. Are we together? Then the next one here, 15 minus 7 should give me what? 15 minus 7 is what? 8. Then my s, which is what? 18. So 18 minus 7 should give me what? 11. So by the time I add up everything here, I have what? 40. Which makes my question balanced. Do you get what I've done, please? Do you understand? Okay, good. So now let's ask a 3 Venn diagram question. A 3 Venn diagram question. So look at this 3 Venn diagram question. So there is this popular question that's inside your manual. A very, very popular question. So I might not get the number right, but I know the question. So if I with our manuals, so let's go check the question together. Are we together? Okay, so is that question that has to do with number of people studying MTS 201 courses, number of people studying MTS, you understand? So if you have that question, call it, let's write it, and let's solve. Is that okay? Okay, we have seen the question. Okay, let's see. So I have in a group of, we have 120 full-time students.
72 of them offers MTS 201.
So then I have 72 MTS 201. Next.
65 offers physics
65 offers physics 201. Right.
And 53 offers bio.
And 53 offers Bio 201. Next.
If 35 of the students offers both MTS 201 and
That
Physics
is
201.
35 is offering MTS 201 and
Physics 201.
Physics 201. The next one.
30 offers both MTS 201 and Bio 201.
The 30 offers MTS 201 and
Bio
201.
21 offer Physics 201 and Bio 201.
21 offers Physics
201
201 and
Bio 201.
Bio 201.
And each of the students offers
And each of the students offers at least one of the courses. Now, question is number 1. Draw a
Venn diagram.
Venn diagram that represents the information, right?
Yes, sir.
All right. Next question should be
How many of the students
how many students
offers
now how many students offers okay, let's start.
the three
I'm having gone 1.
courses?
Yeah, what's that?
All the three
All
courses.
three. Then number 2,
Exactly one of
exactly
the three
1.
courses.
Next one,
Exactly 2 of the 3
exactly
courses.
2. And the last one,
MTS 201 alone.
MTS 201 alone. So this is the question. So I might not necessarily be writing it word for word. You get? I'm not necessarily writing it word for word. So that's why I've just paraphrased it. But this is everything that the question have. Are we together? So let's draw the Venn diagram. So you draw this on the Venn diagram. So let's start. So if I draw this on the Venn diagram, so first thing first that I will have is this. You have the first one, the second one, and what? The third one. Are we together? Okay, so this one, let me label it as M. Let me label this as P, and let me label this as what? B. Are we together? So how many people are interested in MTS 201? 72, right? How many people are interested in physics? 65. How many people are interested in biology? 53. Okay, then your universal set here is what? 120. Okay, so with this, let's start. So now, the first thing that says here is that if 35 offers MTS and physics, this is MTS and physics, this is their intersection here. You can have this one to be what? 35, right? Now the next one is MTS and biology, which is 30. So this is MTS, this is biology. This place will give me 30. Are we together? Now the next one here is 21 to be what? Physics and biology. That's what? 21. Are we together? So now, so after this, after we have this, now I don't know how many people are taking all the 3. So I can say that one to be what? Let me call that one X. Let me call the next one here W, because I don't know it. Let me call the next one here to be Y, and let me call this one to be what? Z. Okay, that will be the first diagram that I will ever draw. I think we have 4 Venn diagrams that we are drawing. So now I want to reinterpret this Venn diagram. So follow me. So now the next one that I'll have here. Okay, so we have M to be what? 72, P to be what? 65, B to be what? 53, your universal set to be what? 120. So yeah, I have X. Are we together? Okay, good. So let's do a little bit of touching with diagrams so that we can get some things clear. So whenever we are talking about MTS and physics, according to the Venn diagrams, this region here painted with blue is your what? Is your MTS and what? And physics. But the question says that out of that, how many people take MTS and physics? We have what? 35. But out of that 35, I also have an X here. So that means for me to get the remaining one in that place alone, what do I have to do? Subtract X from what? 35. So this place can give me what? 35 minus X. So the same scenario that happens here, the same thing that will happen here. So what would this place be? 30 minus X. What would this place be? 21 minus X. Good. Now, don't forget that another thing I wanted to know is that everything in this circle here belongs to M, right? Everything in this circle here belongs to P, and everything in this circle here belongs to what? B. That means that if I add everything up in this circle, don't forget this place is what? W, this place is Y, and this place is what? Z. That means if I add everything in this circle here, I must get what? 72. If I add everything in this circle, I must get what? 53. If I add everything in this circle, I must get what? 65. So let's try that. So adding them, I can say that 72 now, that I'm starting with M, means that W plus what? 35 minus X plus what? X plus what? 30 minus X. So don't forget, I'm looking for W. I want to write W in terms of X. So if I can have 72 is equals to W, then what do I have here? Plus, now 35 plus 30 will give me what? 65 minus X plus X. What do I have here? Minus X. Don't forget, I'm writing W in what? In terms of what? In terms of X. So to make W the subject of the formula here, what do? I have 72 minus 65 plus what? X. I can say that my W here should give me what? 72 minus 65 should give me 7 plus what? X. So I've gotten W. Are we together? Now let's do the same thing. Let's repeat the same process to get my Y, and same process to get my what? Z. Can we start that? So let's go. So to get my Y, I can say that 65, I'm moving on to physics now. So 65 here will give me 35 minus X plus Y plus X plus what? 21 minus X. Yes or no? Then from here I can have 65 equals to Y plus, now 35 plus 21 should give me 56. Are we together? So minus X cancels plus X here, and I have minus X here. Are we together? So writing Y in terms of X here, so what should that give me? So I can say that Y is equals to what? 65 minus 56 plus X. Your Y here should give me what? 9 plus what? X. Alright, good. I've gotten Y, I've gotten W. So the next one I'm looking for here is to get what? Is get Z. Now how do I get Z? The same process that I have here, which will give me 53. No, it's not like this, it's not this way. And I have what? 53 is equals to what? Z plus 30 minus X plus X plus what? 21 minus X. So you have 53 here is equal to Z plus 30 plus 21 should give me about 51, right? Then minus X minus X. Now together. Then collecting like terms together, moving all of these things. So what do I have here? I can have Z is equals to what? 53 minus 51 plus what? X. And the same time, Z here gives me what? 2 plus what? X. So I think I've got another Venn diagram. So with this Venn diagram, I can now confidently rewrite or redraw this Venn diagram to another one. Can I clean this part? Okay. So now let's now redraw that Venn diagram that I have there. So redrawing that Venn diagram that I have there, I will have something that looks like this. Yes. Okay, so let's go. I have to make it a little bit bigger, but I can look. Okay, I think this is big enough. So let's start. So this one here is M equals to 72. Your universal set here equals to 120. This is P equals to what? 65. This is, what's that? B is equals to what? 53. So let's go. I had Z here, right? So what was my value of Z here? I had 2 plus X. Here I had W. And what's the value of my W here? 7 plus what? X. And the next one I have here is what? Is Y. And Y is what? 9 plus X. Nice. So what do I have in the middle here? The one in the middle here is what? Is X. Good. What is the one up here? You have 35 minus X. The next one here is 30 minus X. And the last one here is 21 minus what? X. So that Venn diagram that they asked you to represent it on is this. The Venn diagram that they asked you to do here, they said that draw a Venn diagram that represents this information. This is what? This is the answer. Now the next step that we now have to do is what? Let's now proceed on to what? Find all three. And I told you that whenever I have something like this that I don't know your X, it means that you must add up everything in that Venn diagram and it must give you your what? Your universal set. Yes or no? So let's follow suit with that. So what do I have in this space? So let's start from here. So I have 7 plus x, the next one here, plus 35 minus x, the next one here, plus 9 plus x, so the one in the middle here, plus x, plus the one outside here, plus 30 minus x, plus the one here, plus 21 minus x, plus the last one here, plus 2 minus x, and everything should give me what? 1. Okay, 2 plus x, thank you. So everything was given 120. So from here, let's start cancelling out. So plus 7 cancels minus 7. I mean, plus x cancels minus x. Plus x cancels minus x. X here cancels this x. Yes or no? So let's go. So let's now start adding. Let's do mental math. 7 plus 35 is what? 42 plus 9. 51 plus 30. 81 plus 21. 102 plus 2. So I have here to be 104. What do I have here? Plus x is equals to what? 120. So from here you can say that your x equals to 120 minus what? 104, and x here is giving you what? 16. Nice. So I've gotten x to be 16. Since I've gotten x to be 16, I can now draw another Venn diagram and put this 16 inside. Right? So let's do that. So from here, the last Venn diagrams that I will draw. Okay. So from here I have 1, I have 2, sorry, it looks a little bit big, 3. This is m equals to 72, p equals to 65, b equals to what? 53. Your universal set here is equals to what? 120. So let's start. So what is your x here? Your x is 16. Now what was this space? This space was 35 minus x. I know that my x is 16, so 35 minus 16 should give me 19. Yes. Now 30 minus 16 on this part should give me what? 14. 21 minus 16 on this part should give me what? 5. 2 plus 16 should give me what? 18. 7 plus 16 should give me what? 27 plus 16, which was giving 23. Then 9 plus 16 should give me what? 25. Right? So now let's now see if we add everything up here. I'll still have my 72. So let's start. So 23 plus 19 should give me 42. So let's keep 42. I have 14 plus 16 is what? 30. So 30 plus 42 should give me what? 72. Is correct? Okay, next one. 40 plus 16 is what? 30. Then 30 plus 5 is what? 35. 35 plus 18 is what? 53. Right? Then the last one is what? 6. Okay, 5 plus 25 is what? 30. 30 plus 16 is what? 46. 46 plus 19 should give me what? 65. So that is its balance. So from here, I've gotten my Venn diagrams now. Question 2 says that how many people offers exactly only one? So what it means by offering exactly only one is that they mean that it is either you are offering only MTS 201 or only Physics 201 or only Bio 201. So I can write it as M only plus what? B only plus what? P only. So why is my M only here? My M only here is what? 23. My B only is what? 18. My P only is what? 25. So if you add up all of this one, what do I have here? 66. That's beautiful. And the second one here, I mean the third one here, which is what? Exactly 2. So exactly 2 means it's either you are doing M and P only, or you are doing plus M and what is that? M and B only, right? Then the last one plus what? P and B only. So what is M and P only? This is M and P only, which is what? 19 plus what is M and B only? This is M, this is B, which is what? 14. And the last one is what? P and B only, which is what? 5. Then if you add up everything here, I have 19 plus 19, which is what? 38. And number 4, I think number 4 should give us a problem, which means you should find what? M only. So what is M only here? M only is what? 23. So we have come to the end of that question. Do you understand? Alright, good. So that's beautiful. Alright, so probably for us to write, then we continue. Any questions so far? Any questions so far? Okay. So if you have any questions so far, now, so you can probably go home and practice a lot of questions I want to practice. There are a lot of questions that do with Venn diagram. I wish I could have another type of Venn diagram that is 3, but unfortunately we can't. So you think, okay, probably we have one from the manual, no problem about that. It's beautiful to have one. Yes, sir. Yes. Yes, that is the first Venn diagram here. This is the first Venn diagram. Yes. So whatever Venn diagrams I did here were just ways to get to this part. Check what I'm trying to say like that. So if you open to the solution manual of your textbook, you find that Venn diagram as your answer. Yes or no? Is that not what is there? That's what is there in the Venn diagram. So I get what I'm trying to say like that. So this Venn diagram that I've drawn here is just a solution to whatever question I have here. Do you understand? Okay, good. So that's that about that. Okay, let's see if we can have one more question from a manual that has to do with a 3 sets question. Okay. All right. Okay. I think let me clean this part. Okay. A survey of, all right, 100 students. Okay, university. I know. Student. Leave that one. Another one. 41 is equals to Spanish. S. 29 will give me French. Next. 26 is giving me Russia. Right? Next. 15 take Spanish and French. Next. 8 takes French and Russia. 19 takes Spanish and Russia. Okay. So 5 takes Spanish, Russia, and French. Okay. Okay, fine. What am I looking for? I'm taking X. Okay, none. Let me just read. None. Equals to what? X. Number 2 is how many take just what? Just 1. Alright, I think that's all. Okay, good. So, as I have said, as usual, let's express this on the Venn diagram. Are we together? So, but this time around, it should be a little bit fast. Do you know why it should be fast? The reason why it should be fast is because I already have the number of students that takes all the 3 of them. Right? So it will be faster that way. So from here, I can now have your Venn diagrams here. What's your universal set here? 100. Okay, I have French, I have Spanish, and I have what? Russian, French, and Spanish. Anyhow, label it anyhow. So how many people take French? Here I have 29. How many people take Spanish? I have 41. How many people take Russian here? I have what? 26. Good. Now, so that we can start picking it step by step and it should make our work a little bit fast. So how many people takes everything? 5. I was get that. But we got states that out of that 5, 15 people takes Spanish and Russia. Right? 15 people take Spanish and Russia. But out of that 15 that take Spanish and Russia, I have 5 already. So that means the next one that will be what? 10. Right? Now how many people take Spanish and Russia here? Spanish and Russia here is what? 19. But out of that 19, I have 5 out. So this one should give me what? 14. Now the next one here is, how many people here takes French and Russia here? 8. Out of that 8, I have 5, which should give me what? 3. Are we together? So now the question is asking me to find how many people is not on the team, which is what I have outside here. Now, so from what I have outside here, I also need to know what this one here is, what this one here is, and what this one here is, right? So I can call this one, let me call it X, let me call, sorry, I have X here. Let me call it W, let me call this one Y, and let me call this one Z. Yes or no? Okay, so from here, How do I get my W? Do you know I can say that 29 is equals to what? W plus 10 plus 5 plus 3. So 29 here can give me W plus 18. Yes? And W on this case can give me what? 11. Yes or no? Yes or no? Yes, where did I see 10? A very nice question. Now, don't forget that the question said that S and 5 is 15. And this is what? S and F. Everything here is S and F. But out of this 15 that is supposed to be here, I already have a 5 here. So if I subtract that 5 from that 15 that I have here, now I have 10 to be on that part. Sure, you understand? So now W here is 11. The next one here is that I have 41 equals to 10 plus 5 plus 14 plus what? Y. And your Y here should give me 41 minus 19. Yes or no? 29. Okay. 29. Then 14 minus 29 should give me what? Huh? What is that now? 12. Mathematics student. And the next one here is Z. So what will Z give me? Z is giving me, what is that? Z is giving me, okay, 26 minus 3 minus 5 minus 14. Yes or no? Yes or no? Okay, good. Then 26 minus 3 is 22. 22 minus 26 minus 3 is 23. Abi? Yeah, it's the same thing. I just, okay, let me take it. I already flipped it. I had 26 equals to Z plus 3 plus 5 plus 14. So I have 26 equals to Z plus, this is 22, straight up. Then Z here is equals to what? 4, right? So now let me now draw another Venn diagram that I have this. So what will I have here? I'll have, so for me I'll have, what's W? 11, 10, 5, 3, 4, 14, and what's my Y here? 14 and 12. What do I have here? F equals to 29. S is equals to what? 41. And R equals to what? 26. Don't forget what am I looking for? X. What's your universal set here? 100. So from our information, that means I must add up everything in this square, this rectangle, and have what? 100. So let's do that. So I can have 100 is equals to what? 100 is equals to 11 plus 10 plus 12 plus 3 plus 5 plus 14 plus 4 plus what? X. So another round of mental math. Are you ready? So 11 plus 10 is what? 21 plus 12. 21 plus 12. 21 plus 12. 20, I'm hearing 43. It's 33. Then 33 plus 5. 33 plus 3 here is what? 33 plus 3. 36. 36 plus 5. 41 plus 14. 41, 55. And 55 plus 4 here is what? 11 plus 10. 21 plus 12. Jesus. 33 plus 5 is what? 36. 36 plus 5 is what? 41 plus this what? 55. 55 plus 9 is 55 plus 4 is what? 59. Abba. Plus X. Then find X in this time around, and your X is what? 41. Yes or no? So that will be the final answer here. Do you understand, please? Do you understand, please? Alright, now let's deal with the last part of set, which is algebra of sets. And let's deal with that last part. Are you bored? Alright, let's talk about the last part of sets. So that part will be the algebra of sets. The algebra of sets will be where we want to combine. There are some laws that guide sets. So we want to look at those laws that guide sets. So we want to look at them. So can I clean this part? Okay. So I think that will be the end of Solomon Grodin for set theory. So let's start. Algebra of sets. Algebra. Now, so this algebra of sets. So let's talk about Let's look at the laws that guides it. Law. So the laws that guides algebra of set. Number 1. Let's talk about commutative law. Commutative law. Now commutative law is this. So in commutative law, this is what you have in commutative law. Oh, it's 1 plus 2. Is it the same thing as 2 plus 1? Are you sure? Okay. 2 multiplied by 7. Is it the same thing as 7 multiplied by 2? Okay. So that means if I have, in commutative law, so if I have A union B, it's the same thing as saying B union A. Yes or no? Okay, good. Do you want to prove it? I'll give it to go and prove at home. Then also if I have A in okay, that's commutative law. Now for the second one, which is number 2. Now let's look at this one, which is associative. Associative law. So in associative law, so this is what we have. So if I have A intersection B intersection C, associative law, if I have A intersection B intersection C, it's the same thing as saying you have A intersection B intersection C. Are we seeing it? This is associative law. We'll prove some of this. We'll prove some, don't worry. Calm down, we'll prove some. So this is associative law. Now the next one, if you also have A union B union C, it's the same thing as saying you have A union B, everything, union what? Union C. Are we together? Okay, so these are laws. Now the third law we have is, let's look at distributive. Distributive law. So in distributive law, so let's look at this. So what will happen if you have A union B intersection C? Now this one here will give you A intersection B. So A union B intersection A union what? C. Are we together? Okay. Then the next one here, A intersection B union C, should give me what? A intersect B union B, or no, union what? A what? C. Are we together? Are we together? Okay, these are laws. You don't really have to, I won't say you have to memorize them. You can just, you can play with them in your leisure time. Don't memorize. Just play with them. So now, the next one I want to look at, number 4. Let's look at identity law. Identity law. Okay. So in identity law here, so let me ask you. A union A is what? A union A is what? Right, that's beautiful. That's A. And also, A intersect A is what? Is what? Are you sure? A intersect A is what? Still A. Complementary law. The complementary law. So your complementary law now. So let's say, what will happen if you have A complement of complement? What will you have? Are you sure? Are you sure? Yeah, you have A. That's correct. Now what will happen if you have the complement of a universal set? You have an empty set. That's beautiful. Now what will happen if you have complement of an empty set? Universal set. I love you guys. You guys are smart. Yeah, you can clap for yourself for that. That's beautiful. Do you understand, please? Do you understand, please? Okay, good. So now, the other ones we want to look at now is this. It's number 6. It's something they call De Morgan's law. Yeah, De Morgan's law. So De Morgan's law will be like saying that if you have A union B all complement, will give you A complement intersect B complement. That's what De Morgan's law states. You can prove them. And also, we can have A intersect B complement, which will give me what? A complement union what? B complement. Are we together? Are we together? Okay. So, alright. So, these are, I think there are about 7, but these are the 6 basic ones we can work with. So, okay, let me ask us this question. What will happen if we have A union your universal set? What will you have? Thank you very much. That's beautiful. You have your universal set. And what will happen if you have A intersect your universal set? Eh? That's beautiful. Nice. Okay. Okay, what will happen if you have A union empty set? What will you have? Thank you very much. You have A. And at the same time, what will happen if you have empty sets, or better still, A intersect empty set? What will you have? Empty set. That's beautiful. So these are all the laws that we have that guides what? That guide set. So you can go home at your leisure time and you can practice all of these laws that you have here. You can prove them. For example, I don't believe that this one is true. So let's. So let's prove now. So I want to prove De Morgan's law, which states this. So I want to prove. So let's say I have A union B complement, which is supposed to give me A complement intersect what? B complement, right? Okay, good. So now for you to prove, I will leave it at your discretion to pick any values for your A, pick any values for your B, and at the same time pick any values for your what? For your universal set. Do you understand what I'm trying to say like that? So let's create a value. I think so far so good. We have been working with U, right? So let's say our universal sets, let's create 1 to be 1, 2, 3, 4, 5. Let me stop at 5. Then from here, let me create A. Let's say A is 1, 3, and 5. Then let me say B is what? Let me say you have 2, 3, and 5. So now, the thing says that, okay, let's now start. So let's start. I want to prove the right hand side first, which is A union what? B. And I hope you know that A union B will give me what? 1, 2, 3, 5. Yes or no? So now let's find the complement of this answer. So A union B complement, and we have 4. Okay, so the next one here. So let's look for A complement. So what is A complement here? A complement is what? 2 and 4, right? What is B complement here? B complement is what? 1 and 2. Or 1 and 4, sorry. Yes, 1 and 4. Right? So let's look there. Intersect B complement. What would that give me here? 4. So which means that this law is what? Is correct. Do you understand what I'm trying to say like that? So you can prove at your own discretion. I hope you get that. Alright, ma'am. Okay, we want to prove number 5 that the complement of A complement is still A. Okay, so working with that, I can say that. So let me still use this same set. I'm not changing the set. Let me just use it. So for me, I can now say that A complement now. So what will A complement give you here? 2 and what? 2 and 4. Now, let me now look for the complement of this complement. So what this one means is that it means that I'll look for everything that is in my universal set that is not in this set. So it will give me what? 1, 3, and 5. Right? And 1, 3, and 5 is the same thing as what? Your set A. So which means that this my law here is what is correct. Do you understand, please? Do you understand? Any question? Any question? Any question? No. Okay. So in the remaining of our time, before we call it a day, now let's quickly regurgitate on what we've learned so far. So we can start flipping our pages to the back. We started by defining what set is, yes or no. Then move on, we talked about the fact that set is what? A collection of a what? Well-defined objects. You guys want to go? Now, collection of well-defined objects is what we define set as. And I told us also that sets can be described in how many ways? In two ways, right? Set can be described using the tabular form. Set can also be described using the what? Set builder notation. So from there else, we moved on to talk about types of sets. So we started by listing them to be what? A singleton set. We said a singleton set is set with what? One element, right? We moved on, we talked about what? Finite set, and we said that a finite set is a set that has what? Countable number of elements, yes or no? Then we move on to talk about what? Infinite set. An infinite set is just that type of set that the element in it cannot be what? Counted. Good. Then move on to what? Move on to equal sets. Yes. And we said that two sets are said to be equal if and only if the number of elements in A is the number of elements in B, and all elements in A is also equals to elements in B. Good. Now the next one after that, we talked about what is that again? Talk about equivalent set. And we said that equivalent set is two sets can only be equivalent if all the number of elements in A is equal to the what? Number of elements in B. Are we together that? Then what else? What type of set do we talk about again? Now talk about universal set. I said that universal set is just one type of set that contains a lot of what? Other type of sets. Yes or no? Then we'll talk about subset, which is what? Subset is a what? It's a subcategory of what? Of a universal set. And I told us that we have how many type of subsets? We have two type of subset, which is your what? Proper subset and your what? Improper subset. And I told you that how many type of improper subset do we have? One, which is what? The set itself. Yes or no? Then we moved on to describing what again? Now we talk about power set. And we said that power set is a set that is what? That is like is a kind of mathematical formula that describes the number of sets that you have. Yes or no? And told us that the answer was what? 2 to the power of what? N. Number of calculated number of proper subsets you have is what? 2 raised to the power what? N minus 1. Alright, good. So all of those things that we have learned, and I think we talked about Venn diagrams, definition of terms, and lastly we rounded up our lessons with what? Algebra of Sets, which has about how many laws here? About 6 laws. And I told you that at home you can go and prove those laws. I also remember I said something that for you to learn master terms, you have to go home, create the problems yourself, and make sure that you solve the problems that you created. So in the lieu of this, thank you very much. You can have another class. Thank you.
It means equal. It's not a single.
So, good afternoon, everyone. Good afternoon, everyone. Yeah, it's lovely to have you around. And I'm really happy and delighted to see our faces. So, now we start with MTS 05. And MTS 05 will be equations. Let's not talk about differential equations this time around. So I cannot say that if we're at the back, let's do well to move forward and let's compile the spaces together. If we have for MTS 05, let's move together. So differential equations. Now we want to talk about differential equations, but looks as if from the first class, let's take it slow and steady as usual now, right? Let's take it slow and steady. So now first thing is that let's define what is a differential equation. So definitions now. What is a differential equation? So let's write that. Differential equations. So want to define what the differential equation is. Yes, want to define what the differential equation is. So can we start? Now, a differential equation is any equations that consist. Are we together? Now, a differential equation, I repeat, is any equation that consists of, number one or more dependent variable. Let's write that. A differential equation is an equation that consists of, number one or more dependent variable. Now, comma, it consists of one or more independent variable, right? Now, the last one is that it consists of one or more dependent variable, or one or more derivative. Yeah, that'll be the last one. One or more derivative. So let's take the definitions together once again. Are we ready? So let's take the definitions together once again. So we said that a differential equation is any equation that consists of, number one or more dependent variable, right? That's the first one. The second one is that it consists of what? One or more independent variable, right? And lastly, it consists of what? One or more what? Derivative. All together. So now, first thing first, let me just briefly explain the concept of dependent variable and what? An independent variable. Let's explain that concept. Let's get it right. So now, let's say we have something that is like this, which is y equals to 2x plus 9. Let's say that I have an equation that looks like this, which is what? Y equals to what? 2x plus 9. And in this one here, I want to ascertain which of them will give me a dependent variable and which of them will give me what? An independent variable. But first of all, we have to understand something first. What is a variable? That's the first thing we have to get first. Now, variables from the word varying means that they are anything that are what? Susceptible to what? To change. Meaning they can what? They can change at any time. So in mathematics, what English calls alphabet is what mathematics calls variables. I get what I'm trying to say like that. So anytime I see x, as long as I am in mathematics, I know that this x is the same thing as what? Variable, right? That is, I can have this x appear in another place that will have another entire value. Yes or no? And if I am in English, I can say that this x here is what? Is an alphabet, right? Are we together, please? Okay, good. So I'm not going to alphabetism today. We are doing mathematics. So now we've ascertained that variables are what? Are letters. Now let's now understand independent and dependent. So independent means that I don't need anybody to exist, right? And independent means that before I exist, I need something. Okay, good. So now let's look at this function. I hope you know that it is very, very impossible for me to have y exist without knowing x. Assuming I don't want to make x the subject of the formula. Assuming I don't want to do that. Do you know that there is no way I can know y without having to know x first? Yes or no? Okay, that's point number one that I want you to note. Another thing that I want you to note is that I hope you know that x cannot just pick any value. Yes or no? That is, x cannot pick any value. That means for each value that x will pick, it will be depending on what? On what x has already picked. Yes or no? I get what I'm trying to say like that. And also I can say that with this, I can say that x here can choose any value that x wants. X can pick any number from negative infinity to what? Positive infinity. That is his own choice. But y cannot do so. Do you understand what I'm trying to say like that? So in that case, I can now say that my x here is a what? An independent variable. And my y here will give me a what? A what? A dependent variable. Please, do you understand the concept like that? So that's just a brief explanation on the concept of what? Dependent variable and what? an independent variable. Do you understand? So now let me now talk about derivative. Yeah, we have done MTS 102, which is basically calculus and probably peripherals. The fact they are dealing with limits, continuity, name it again, composite functions, all of this kind of stuff. We did that in under level second semester. So that one's just a continuation of this. So I believe that if we have something like this, the y dx is no longer in use, that this is what? A derivative. Yes or no? Yes or no? So I can say that this is a derivative. And with what I have here, I can say that my y here, or if I want to write this one here, it means I am differentiating y with what? Respect to what? X. Yes or no? Then that means that I can say that in this case, my y is a what? A dependent variable, and my x here is what? An independent variable. Are you getting what I'm trying to say like that? So that's the whole concept of what? Of derivative. So what will now happen if we now cook a stew, or we cook a food that contains as many number of dependent variables that we can have, or as many number of what? Independent variables that we can have, and also derivative. What do I have at the end of the day? I have what? Differential equations. Do you go and say like that? So just know that differential equation is what? Addition of what? Dependent variable plus independent variable plus what? Derivative. All of those three will give you what? Your differential equation. Do you understand what I'm trying to say like that? Okay, good. So let's talk about the types. 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 So let's talk about types of type of differential equation. So we have two broad categories, like two types. And the first type here is your ordinary differential equations. Then the next one we have is a partial differential equation. Yeah, so they have their short forms respectively. This one is what you can call ODE. Sorry, permit my bracket. I just finished a class with sets, so the sets bracket is in my hand. And I can have PDE too. So you can. So these are the two types of two categories of what? Differential equations that we have. So now let's start talking about them one by one. So how do I know an ordinary differential equation? So can we start? Okay, now another differential equation has one dependent variable. Next one, it has one independent variable. Then at the same time, it has one kind of derivative. Yeah. So these are the three pointers to ordinary differential equation. For you to have an ordinary differential equation, first thing you have to know is that that equation must have only one type of what? Dependent variable, only one kind of what? Independent variable, and what? Only one kind of what? Of derivative. Are we together? Alright, so from here, let's give an example of an ordinary differential equation. So based on all of this one, I can have something like, let's say, 2x squared minus 3y dy dx plus 30 equals to 0. Now, this thing I've written here is an example of what? Of an ordinary differential equation. Should we state why? So let's start by stating why. The first thing is that, how many type of dependent variable do I have here? One, which is what? Only y. And permit me to state, let me state this. As far as you are concerned in MTS 209, basically, we can say that all our all our dependent variables will be what? Will be y. And all our independent variables will be what? Will be x. Let's save that for now, because the higher we go, the more it becomes complex. But let's just have that as a what? As a guide. So I will together. So I can say that. So how many type of dependent variable do I have here? I have only one kind, which is what? Y. So that means condition number 1 is what? Satisfied. How many type of independent variable do I also have here? 1, which is what? X, right? Then how many kind of derivative do I also have here? 1, which is what? Dy dx. Since all these 3 conditions are satisfied, I can call this one a what? An ordinary differential equations. Do you understand? Okay, now let's talk about partial. Partial, on the other hand, is the exact opposite of ordinary differential equation. So you can have 2 or more dependent, then also 2 or more independent. Are we together? Then we can have what? 2 or more what? Derivatives. So when I mean derivative, I mean kinds of derivative. Do you understand what I'm trying to say like that? I mean kinds, like types of derivative. This is one type of derivative. Are we together? This is another type of derivative. Are we going to say like that? So any differential equation that have separate kinds of derivative, we have them as to be partial. Okay, so let's have an example. Probably, let's take this partial square u over partial x squared plus partial square u over, let's say, partial y squared. Then let me equate this one to 0. That is an example of a partial differential equation. First thing first, you notice that even the way I'm writing it is completely different from the way I had it here. I would get that because ordinarily here I had a D shape, a D letter, but here it looks like an incomplete R sound, right? And if you did phonetics, you have something like this. This is your R sound, your short R sound. So if you remove this other part here, the shape you have left is what you have in terms of your partial. Are we together? Now that's how you recognize the partial differential equation. First thing that you use to recognize them is that they all possess this kind of thing here. I will get some apprentice like that. That's number 1. Number 2 is that now this kind of derivative, I have 2 kinds of independent variable. X here is independent, and at the same time, Y here too is what? Independent. I will get some apprentice like that. Although it looks as if I have one kind here, but there are some scenarios, there we go, where we can find out that there are some partial differential equations that have what? More than what? One type of what? Dependent variable. Do you understand what I'm trying to say like that? So I believe now, if we can see any equations now, or any differential equation, it should be easier for us to easily ascertain which of them is an ordinary differential equation, and which of them is a what? Partial differential equations. Do we understand that? So let's continue. Can I rub this off? Okay. So rubbing this off, we've talked about types. Now the next one we'll talk about now. Let's talk about characteristics now. Characteristics of ordinary differential equation. Okay, let me state this. Part of the differential equations, the higher you go, we will still have to deal with partial differential equations. But for now, let's just base our attention on what? Ordinary differential equations. So the characteristics I'll be listing now will be what? Characteristics of what? Ordinary differential equations. During the course of this program, you are guaranteed that we talk about partial differential equations, we talk about the characteristics also. Are we together? Okay, let's start. So the first characteristics of ordinary differential equation will be number 1, which is the order. Yeah, order. Now, I want to specify that the same thing as you mean by characteristics here is also mean as things you use to name. For example, if you say that, what is the characteristics of a dog? Number 1, a dog barks. That is, that barking of a dog is giving it is what? Its identity. Yes or no? Okay, good. So that's the same thing. So if I say the characteristics of an OD, that means I want to start giving different kind of ODs identities. Do you understand? Let's define it. So order will be the highest derivative in a differential equation. If you want to write that as a definition, that's what is defined as. Your highest derivative in a what? Differential equation will give you what? Will give you order. Do we understand? Alright, so let me write a list of differential equations, and it should be easier for us to, to ascertain. Let's say that I have something like this: the 5y dx5, which is greater than the 4y dx4, which is also greater than the cube y dx cube, which is also greater than the square y dx squared, which is also greater than what? The y what? Dx. So this would be, let's give this as a minimum order. I mean, as a yes, let's give it as a minimum order of how our derivative, or our derivative can appear in equation. Let's give it as a minimum order. So let's say that we have a differential equation that all of this one appears. Now the order of that differential equation will not just be any derivative, but will be the what? Highest derivative in that what? Differential equation. I get what I'm trying to say like that. So for example, if I have a differential equation that consists of this derivative and this derivative, what will be the order? The order will be what? Based on what? This derivative. So let's give examples. Let's say that we have 2y the square y dx squared minus 4 dy dx plus 8 equals to 0. So let's look at this now. How many type of derivatives do I have? I have 2 of the same kind, which is what? The square y dx squared and what? Dy dx. But in this order, which one is greater? The square y dx squared. And the square y dx squared being the greater means that this should be what? A second order. Okay, let me now mention something here. This one here, I hope you know that the 5y over dx5 means I have to differentiate a particular function y how many times here? 5 times. This is 5 times, this is 4 times, this is 3 times, this is 2 times, this is what? Once. I get what I'm trying to say like that. So the highest one that appears here will give you a what? Will give you your order. So I can say that this one here, if I don't know anything about it for now, I can say that this one here is a second order ordinary differential what? Equation. Yes or no? Do you understand? Okay, let's go to another one. Number 2, which will give me another type of example. Let's say the cube y dx cube plus the square y dx squared minus 2y equals to dy dx all squared. Okay, let's look at this now. How many types of derivatives do we have there? We have 3 kinds of derivative. I have the y dx, I have the square y dx squared, and at the same time I have the cube y dx cube. So which is the highest derivative here? The cube y dx cube. So that means with this I can say this is a what? A third order ordinary differential what? Equations. And let me clarify something. Please, let me write it up here. The y dx all squared is not the same thing as the squared y over what? Dx squared. They are different. Now what do I mean by this? This one here means that you're having dy multiplied by dx, dy times what? Dx, which is not the same thing as differentiating dy what? Dx. Please note that. I'll get my branch like that, because if I wanted to confuse you, I might have probably erased this one away and leave you with this. I might be tempted to say that whatever you have here will give you your order, but just don't make the mistake that the power here does not mean that this power here automatically jump inside. Do you understand what I'm trying to say like that? So this is the first thing that we have to deal with, which is what? Order. Now the next characteristics that I want to deal with is what? Is degree. I want to talk about the degree. Now what will be the degree now? Now the degree will not be, I can give it 2 definitions. I can either say that the degree is the power of your order. That's the simplest definition you can ever have. Power of your order. Or you can say that the degree is the power of your what? Highest derivative. And I hope you know that highest derivative is the same thing as talking about your what? Your order. Yes or no now? Alright, good. So let's now figure out the degree here. Okay, but before I figure them out, let's create another one. The next one I want to create will not be the one we'll now have to start. We'll name with order and we'll move on to what? Degree. So first of all, let's start here. Let's find the degree of these 2 differential equations here. So from here, what is the order here? This is the order. Yes or no? Now what is the power of this order here? Everything is reduced by what? 1. Are we together? So I can say that this is second order first degree. Are we getting it? Alright, good. So now the next one here will now give me, okay, I'm concerned with what? The power. So what is the order here? This is the order. Are we together? So since this is the order, what is the power of this order here? 1. So this is a what? A third order first what? Degree. Are we getting what I'm trying to say like that? Okay, good. Now let's create more examples, solve more problems. Okay, what if I have something that looks like this? Dy dx plus 2y, everything squared, equals to the square y dx squared. Now let's have this. So now, assuming I have this, as I told you, what do you have to first start naming? Start naming the order, and from the order you move on to what? To the degree. So let's start. So what's the order of this? So this will be what? A second order, because this is your what? Highest derivative there. So you have a what? A second order. Now what will be the degree? What is the power of this one here? 1. So this will be a second order first degree. Are we together, please? Alright, okay, now the fourth one. Now let's now have something that looks a little bit complex. Let's increase the pace. Now what will happen if I have square root of the squared y the x squared plus y equals to the cube y the x cube? Yeah, what will happen if I have something like this? Yeah. Now first thing that we have here is this. First thing first. What is the order? I think that's easy to ascertain, right? What's the order here? What's the order here? Third order. So this is a what? This is a third order. Now since this is a third order, now what will be the degree? Yes. Yes, you have a first degree. You said that you have a first degree. I totally accept. I agree with you. You are correct. You have a first degree. But as far as differential equation is concerned, I shouldn't have fractional powers. I should not have anything that has to do with square root. I don't want to have anything that has to do with cube roots, fourth root, whatever roots that I can have. I don't have any roots. So the first thing I have to do here is that I have to find a way to remove this square root. Then how can I remove the square root? What do? I square both sides. So by squaring both sides here, what will happen? I think this thing here can now transform to give you the square y, the x squared plus what? Y equals to what? The cube y, the x cube, everything here squared. So with this squared here, I can now have it as a what? A third order, second degree, ordinary differential equation. Do you understand, please? Are we sure? Okay, good. So the next one. So now, the next one now, we've talked about order, we've talked about degree. So let's move on to the third one, which is, which will give us now linearity. So linearity in the sense that now we want to determine if a differential equation is linear or non-linear. So there are some conditions that guides linearity, some conditions that guides it. So let's write those conditions out. So we can say that a differential equation is said to be linear if all of these conditions holds. I'll get my branch like that. So you can't say that because one condition holds, the other condition is violated, we say that it is linear. No. It can only be linear if what? All the condition what? If all of them holds. Do you understand? Do you get? Now, what is condition number 1? The first condition is that. Are we ready? Okay, good. Your dependent variable must not be more than the power of 1. So what's your dependent variable? That's your dependent variable is y. That means any differential equations that you have, that you're having y squared, y cube, y to the power of 4, y to the power of whatever power that y can have. All of this one is telling you that your y, because of that condition, and so know that your y there is what? Non-linear. I would get one apparently like that. That's number one. Now, number two condition is this. Second condition, your derivative you have in that your differential equation, the power of that derivative must not be more than 1. I get what I'm trying to say like that. It must not be more than what? More than 1. So that means, and also if that will be the case, so that means the degree, apart from the degree self, or let me just start, the degree of that differential equation must be what? Must be 1. That's the first condition. And second condition is that despite the fact that the degree is 1, I must not also have any other derivative that the power is greater than 1. Do you understand what I'm trying to say like that? That's condition number 2. Now the third condition is this. Your dependent variable y must not multiply your independent variable. Must not multiply your derivative. That means I must not have a scenario where I have y multiplying dy dx, y squared multiplying dy dx, y cubed multiplying dy dx, or any form of dy dx that I have. I'll get what I'm trying to say like that. Am I too fast? Alright, good. I love responses from us now. Let's talk. Yeah, that's great. So we've talked about linearity. So that's the second condition. Are we together? Now that's the third, right? The third condition. Okay. So now let's look at all of these things that we have here, and let's look at all of those conditions. Let's look at these differential equations in light of those conditions. Now, number one, can I say that number one is linear or non-linear? Let's start with it first. Now, what is condition number one? Condition number one is that y must not be what? The power of y must not be what? Greater than 1. I think that condition is satisfied here, right? Y is to the power of 1 here. Okay. Condition number 2 is that your derivatives too must not have what? Any power. Yes or no? I think that condition 2 is satisfied here. But condition number 3, which says that your y must not multiply your what? Your derivative. I think that condition is not satisfied here. So because of that one condition, I can say that everything here is what? Non-linear. Because of one thing, this thing here is what? Is wrong. I'll get what I'm trying to say like that. Okay, now let's move on to the second one. So let's look at the second one here. So let's look at it. What is condition number 1? Let's state it together so that we can master it. Condition number 1 is that the power of y must be 1. Is that satisfied here? Yes. Condition number 2 is that your dependent variable, the power of your dependent variable must be what? Must be 1. Is that condition satisfied here? No. I have what? dy dx all squared. Now the condition number 3 is f. Okay, I think that's the only condition that is violated. So because of that, this one here is what? Non-linear. Are we getting it? Okay, now this one here, let's look at it. So this one here, I have dy dx plus 2y equals to what? The square y over dx squared. So this one is obviously non-linear. Do you know why? Because my derivative here is what? To the power of what? 2. This fine boy here is what? Non-linear. Are we together? Now the next one here is this. So I think this one is obviously what? Non-linear also. So non-linear. Question, which one can I give us linear? Abi? So let's find a linear differential equation that will satisfy all of those conditions. So I can have first one 2x dy dx minus 4y equals to 0. Whatever I've written here is what? Is a linear differential equation. Do you know why? The first thing is that the power of your y here is what? 1. Satisfied. The power of your derivative here is what? 1. Satisfied. And y is not multiplying your derivative. Satisfied. So let's now name it. So if I want to name this differential equation, I can say this is a what? What's the name? Let's start. First order. Then what would this be? First degree. Then what would this be? Linear. Yeah, this would be a linear ordinary differential equations. Do you understand? Okay, now the last part, which is number 4. So that last part, number 4, will give me the homogeneity. Now homogeneity, I don't know if that English exists, but in homogeneity what we are concerned about is that we want to find out if a differential equation is homogeneous or non-homogeneous. You can't be semi-homogeneous. It's either you are homogeneous or you're what? You're non-homogeneous. So are we together? So now, there is a particular condition that guarantees or satisfies homogeneity. Okay, now let's take a look at these differential equations. For example, let's say that you have let me a the 4y the x4 plus b the cube y the x cube plus c the square y the x squared plus, let me call this one e the y dx, right, plus fy equals to 0. Let's look at this differential equation. First of all, is this differential equation? What is the degree first? What is the degree of this differential equation? It's a 4th degree differential equation. Now, what is the, it's a 4th order differential equation. Now, what will be the degree here? 1. So it's the 4th order 1st degree differential equation. Now, this same one again, is it linear or non-linear? It's linear, because there's none of this power here that is to the power of 1. Greater than 1. Y is not multiplying any derivative, and power of y here is also what? Also 1. So that means it is what? Linear. Now, we now want to ascertain if it is homogeneous or non-homogeneous. So how do I know if it's homogeneous? So this how. I know if it's homogeneous if after this arrangement, the next thing I have, which is neither pertaining to a derivative or pertaining to y, is 0. I don't know if you get what I said. Now, it is homogeneous if you have observed this arrangement now. Are you seeing it? Now, if after this arrangement, the last thing that follows this arrangement, which is y, if after this y, the next thing I have on the other side, which might sometimes not be on the other side, is 0. Because of that, I say that it is what? Homogeneous. But if after whatever I have here, I now have another entire function, which is not 0, what will I have there? Non-homogeneous. Do you get what I'm trying to say like that? Let me explain again. If you have this order, that is from, I just picked the 4y, I will together. If you have this order, then after this order, to the last point here, which is y, then after this y, the next thing that followed there is what? Is 0. So I can say that it is what? Homogeneous. Then if after that, if after that one, if this one here is another function of x, then I can say that this one is what? Non-homogeneous. Do we understand? Okay, now let's look at these definitions here now. Is this one here homogeneous or non-homogeneous? Now let's start. After my d square y dx squared, what do I have here? I had what? dy dx. So from this dy dx, although I do not have a y, but after my dy dx, what followed here was what? Was 8. And 8 is not pertaining to any of this. So because of this 8 that is here, I can say that this one is what? Non-homogeneous. Are we getting it, please? Huh? Okay. This, you see this order here? Now this order, after this order is explained, after the last term here, the next that must follow must be what? 0. I guess I'm trying to say like that. So if after what I have here is not 0, another function, then because of that function that I have, it's what? Non-homogeneous. Now look at this. I have the square y dx squared, I have dy dx. Then after this, the next thing I was supposed to have was what? Was a y. But here I do not have a y. And the next thing I had here was what? Was 8. And 8 is a constant. So because of this 8, which does not have anything to do with, probably it's not having a y, and it's not having any of this derivative. Because of that 8, this one is what? Non-homogeneous. Do you understand? Okay, the next one here, let's look at it. So if I arrange this order very well, I will have the cube y, the x cube, the square y, the x squared, the y dx, and I have 2y. So if I bring this one to the other side, what will I have left here? 0. And so because of that, I can call this one what? Homogeneous. Are we together? Okay, good. So now here, let's look at it. Is this homogeneous or non-homogeneous? Homogeneous, because after the square y, I have what? The y dx. Then the next one I have here is what? 2y. So after I've arranged everything, the last term that I will have there will be what? 0. So this is what? Homogeneous. And the last one here should not give us what? So let's look at it. Is it homogeneous or non-homogeneous? It's homogeneous also, because after the cube y, the x cube, sorry, it should be the x cube. The next one I had was what? The square y, the x squared, and the next one I had here was what? Was y. Are we together? Okay, so after all of these arrangements, if I carry whatever should be on the left hand side to the left hand side, I will have 0 left. Yes or no? Because of this is what? Homogeneous. I'll get my branch like that. So now, so I have fully named all the differential equations we have on the board. I think this is the 5th differential equation we have on the board. Order, degree, linearity, and is this one homogeneous or non-homogeneous? Homogeneous or non-homogeneous here? Is homogeneous. So this is homogeneous. So now, if I give a differential equation to name, all that differential equations must follow this order. So that means for you to name a differential equation, you have to start with what? The order, then followed by the degree, followed by whether it is linear or not, or followed by when is what? Homogeneous or not. So if I want to describe this differential equation I have on the board, I can call it a what? A second order, first degree, non-linear, non-homogeneous, ordinary differential equation. So I have completely named this differential equation. Do we understand, please? Do we understand? All right, good. So now let's create problems. Have we now? Let's create problems. Now let's say now want to name this together. Want to do the naming together. Now creating this problem here. Let's say I have y squared minus 4y dy dx equals to, okay, let me put the cube y dx cube raised to the power 1 over 5. Yeah. So let's look at this first. Are we ready? So let's name it first. So the first thing I can name is what? Is the order. So what is the order of this? What is the order of this? So I have the cube y dx cube. So because of this will give you a what? A third order. Now, the degree. What degree is it? What degree is it? We have, some people say first degree. Some people even have 1 over 5 degree. Nice, I love that. That's beautiful. Clap for yourself for whatever answer you have said. So now, with this, I told you that whenever you are dealing with degree, you cannot have fractional powers. That means, and this one here that I have is what? Raised to the power of what? 1 over 5. Although I know personally that the degree is what? Is 1. I know. But now let's find a way to know why it is 1. Now, why do I know it is 1? The first thing is here that I have to the power of 5 here. And from the power of 5 here, what do I have to do? Then I have to raise both sides to the power of 5 to cancel out this fraction here. So raising both sides to the power of 5 will now give me something that is y squared minus y dy dx here. Everything here raised to the power of what? 5 will give me what? The cube y, the x cube raised to the power of what? 1. Yes or no? So with this now I can now ascertain that this is a what? Third order, first degree. Are we together? All right, good. Now let's now talk. Is it linear or non-linear? Linear or non-linear? Non-linear, obviously, because number 1, my dy dx here is having a power. And the second thing that is having here again, my y squared itself again is what? Having another power. So this is what? Non-linear. So if it's non-linear, is it homogeneous or non-homogeneous? It's homogeneous because after your arrangement of this order, the next thing I'll have there will be what? 0. This is what? Homogeneous, ordinary differential equation. Do we get that? Okay, let's do another naming, but this time let's make it a little bit more complex. So let's say I have square root of 2 dy dx all raised to power 1 over 3 plus y is equals to 2x squared. Yes. So let's have something like this. Okay, now let's start. What is the order? Let's start with the order. What's the order? The order is a what? Is a first order. First order. Now, the next one here is what? Is to ascertain the degree. Now, looking at it, to ascertain the degree here, you find out that I have 2 problems attached to it. First of all, I have a square root which I have to decompose first. Then I now have what? A cube root which I have to what? Decompose later. So let's now start. So what I do here first, I what? Square both sides. So squaring both sides here will give me what? D2 dy dx raised to power what? 1 over 3 plus y equals to what? 4x to the power of 4. Yes or no? That's by squaring both sides. Then after that, I still have fractional power. So what do I have to do? Take this fine boy here to the other side. Then I can have 2 dy dx raised to power what? 1 over 3 equals to what? 4x to the power of 4 minus what? Minus y. Then so from here, then what will be the next thing I have to do? In order for me to remove this one here, what will I do? I will have to what? Cube both sides and cube both sides. So because of that, I now have 2 raised to power 3 what? 8 dy dx equals to what? 4x to the power of 4 minus y. Everything raised to power what? 3. So with this now, so let's now ascertain what will be the degree now? Should be what? First degree. Then as it is the first degree, now is it linear or non-linear? Is it linear or non-linear here? This is non-linear. Why is it non-linear here? By the time I expand this, I will have y to the power of what? 3. This is what? Non-linear. Then at the same time, is it homogeneous or non-homogeneous? Let's look at it very well critically. Homogeneous or non-homogeneous? It is a non-homogeneous. Do you know why? Let me explain why it is non-homogeneous. Because by the time I'm done with this expansion here, I will have a single function of y, which will be what? 4x raised to the power 4, everything raised to the power 3. Yes or no? And as I've said, in this order, after I've gotten this order, the next thing I must follow must be what? 0. But if I break down this cube, the last thing I'll have here will be what? 4 raised to the power, 4 raised to the power 3, x raised to the power 12. So because of this little boy that is here, it is what? Non-homogeneous. Non-homogeneous, ordinary differential what? Equations. Do we understand? Do we understand? Alright. It depends on the type of fractional power you have. What if I tampered with this one and I put 2 here? Okay. Now I've played with alright. Let's make it more interesting. Alright, I still have 1 here, right? Let's get another question. Now from here also, and let's say that I now have 3y minus 4x squared dy dx raised to power half. Are we together? Plus, okay, don't let me equate it to plus, equals to 2 d square y dx squared raised to power 3 over 2. Now, want to name something that looks like this. So to name something that looks like this now, so first of all, let's ascertain the order. The order is very easy for us to know. So what will be the order here? The order will be what? It will be second order. I think by now, we should be able to, anyway, we should be able to discern the order of any differential equation we see. Yes or no? Alright, good. So from that, so now here, I have a lot of problems. Now the first problem that I have here is that I have 2 of them to the power of what? Of 2. I have fractional powers here. The first thing I have to do is here is that let's try as much as possible to linearize this differential equation. What do I have to do first? Let's collect like terms together from here. Then what can I have here? I can have 3y. I put together 3y minus minus 2 open brackets the square y the x squared. I put together raised by what? 3 over 2 equals to what? 4x squared. Then what do I have here? The y dx raised by what? Half. Now for me to do this, what do I have to do next? The next thing I have to do is what? Is to what? Square both sides. So by squaring both sides here. Yes, by squaring both sides here. So what will I have? I think I can expand this if I square it, right? So let's expand it together. What will I have? I will have 9y squared minus 12y the square y the x squared, everything raised by what? 3 over 2, right? Then minus, it shouldn't be minus now. It should be, yeah, plus 4 the square y the x squared raised by what? Raised by 3. Then everything here should not give me what? Everything should not give me what? Everything will not give me 8x to the power of 4 dy dx. Yes or no? Okay, sorry. It shouldn't be. Okay, it should be 16. Thank you. It should be 16 x to the power of 4 dy dx. Yes or no? All right, good. So while it looks as if I've attained it, but do you know that for me I can determine the degree? How did I get 12? Yes. There's this. You know that if you have a plus b, you want to expand it all squared. There's this trick you use, binomial expansion trick, that this one will give you a squared, then plus b squared, then one inside the middle, just multiply 2ab to it. I mean, from your binomial expansion, which is 1, 1, 1, and what? 1, 2, 1, right? This 1, 2, 1 is what I have here, and that is the same thing as I have here. So 2 multiplied by 3 multiplied by 2 here will give me what? 12. Are we together? Okay, good. So now from here, I hope you know that it's easy for me here to ascertain my degree. Do you know why? Do you know why? Because from here, since I still have a fractional power here, let's say I want to remove that fractional power. So what do? I take both of these ones to the other side, right? Then at the end of the day, what will I have here? I will have, if I take this one to the other side and I square both sides, I think I'll be having a 3 left. I'll be now. Is it a 3 or a 6? I'll be having a 6. So from here, and also again, this differential equation here, also here is having another, this one is the same differential equation, but with different power. So I don't think we have a scenario like that. So I don't think this one here is too complex enough to determine its degree. Do you understand why? The reason is because by the time I expand all of this one, at the end of the day, I will still have a cube here, and I will have this one raised to the power of 6. Yes or no? So let's just say, probably if I had not squared this one here, I think my case will have been easy. Yeah, because I can't have two differential equations of the same order having two different degrees. You get what I'm saying? So for me now, so let's assume that I just did like this. What will have been my answer here? What will have been my degree? I have touched the question, so let's say I didn't have and half here, and I just have it. So what will have been my degree? I will have squared both sides, and this will have given me my what? My third degree. I mean now. So then from my third degree here, then what will be the next thing here? Is it linear or non-linear? Linear or non-linear? Linear or non-linear? Linear or non-linear? It should be what? Non-linear, right? Why is it non-linear in this time around? Because my derivative here is what? Is having a power, and also this derivative here too also has a power. Are we together now? Then the last one, is it homogeneous or non-homogeneous? By God's grace is what? Homogeneous. Are we together now? So now we have gotten an ang, or we have, I can say that by now you are able to name any differential equation you can see, right? Right? Alright, good. So now let's continue. Now talk about types, right? Now let's move on to the next subcategory on this. Okay. Are they on differential equations? I hope you have everything I have on the board here. Okay, so next one we're moving on to now will be forming differential equations. Now this time around I want to learn how to form. That is, I want to learn how to create problems for ourselves. How to create problems. Life is full of problems. We create and we solve, or they create for us and we solve. We cannot live life without solving a problem. That's just by the way, actually. Now, from differential equations, there are some there are two keywords there that I would like you to note. There are two notes there. The first note I want you to observe is that the number of arbitrary constants, you might want to write that down. Number of arbitrary constants in a differential equation. Number of arbitrary constants that we have in a differential equation. Are there? Now, the number of arbitrary constants we have in the differential equation means two things. It means two things. Now the first thing that it means is that it means the order of differential equations to be formed. Are we together? The first thing that it means, I said that the number of arbitrary constants we have in a differential equation means how many things? It means two things. The first thing is that the order of differential equations to be formed. Are we together? Now the second one that it means is that it means the total number of times you will differentiate your differential equations. Yes or no? Alright, good. So if we have that scenario satisfied, okay, let's now start. Another thing I wanted to know is that, you know that I said it earlier on that apart from, for easier cases, we can say now that the only dependent variable you have is what? Only dependent variable you have is what? Is y. And the only independent variable we have is what? X. We can just say that for now. I'll get what I'm trying to say like that. So now how do we recognize your arbitrary constant? Your arbitrary constant are all other kinds of constants or all other type of letter except from your what? X and y. I'll get what I'm trying to say like that. So any other letter, you see a question about you to form. So if they ask you to form, they will give you a sort of equation which you have a y, you have x, and some mixture of letters. So any other type of letter apart from y and x is telling you about your what? Your arbitrary constant. Okay, let's look at this example. For example, if I have number 1, I want to form this. Y is equals to ax squared plus bx. That's number 1. Number 2, I want to form y equals to a divided by x plus bx. This is another one. And number 3, I want to define y equals to, let me give that a sine 3x plus b cos 3x. Let's have something like this. Now number 4, then I can have y equals to a exponential 3x plus b exponential 2x. Or let me use x this time around. Okay. And put minus here. It's 4, right? Okay, can we have one more? Okay, let's have one more, which is number 5. Let's have y equals to ax cubed plus bx squared plus what? Cx. Let's have this. So now, these are differential equations that by the time we are done with, the end product must be that we get a what? A differential equation. I will get one approach like that. So as I said earlier on, let me put solution here, and let's be prepared to write. As I said earlier on, I said that the number of arbitrary constant tells you two things. Number 1, it tells you the order of the differential equations you will get, and at the same time it tells you what? How many times you differentiate that equation. Yes or no? So with that, let's look at this. So what will be the order of a differential equation in 1? To be what? A second order, because I have how many arbitrary constants? 2 arbitrary constants. How many will I have here? A second order, because I have how many? 2 arbitrary constants. How many will I have here also? A second order, because I have what? 2 arbitrary constants. But this one here looks a little bit different, because how many will I have here? I have what? A third order, because that's how many arbitrary constants? A, B, and what? C. So how about we have 1? That's 1 arbitrary constant. Can we have 1? So let's say that we have 6. Y equals to mx. So how many arbitrary constants will I? What will be the order of this differential equation here? To be a differential equation of what? Of 1. I'll go to my pencil like that. So I can say that y equals to mx plus m put plus 7 there to make it look a little bit easy. Are we together? So now let's start solving. Number 1. So I have y equals to what? Ax squared plus what? Plus bx. And I told you that the number of arbitrary constants we have will tell us how many times I want to what? Differentiate. Yes or no? Okay, good. I have 2 arbitrary constants, so that means I'm differentiating how many times? I'm differentiating twice. So let's start. My first differentiation. Please, yes, before I continue, please note that dy dx, to make it easy and to make your work look a little bit more professional, dy dx is the same thing as y prime, and the squared y, the x squared is the same thing as what? Y double prime. I hope higher derivative you can compute the rest. Okay, good. So we have this as a thing. Then so from here, let's start. So what will be my y prime here? My y prime here will give me, let's differentiate, that will give me what? 2ax plus what? Plus b. So I can call this one here, I can call this equation 1. And at the same time here, I can have y double prime equals to what? 2a. I mean now, I think that will be the only thing I will have there. So from here, this is equation 2. So from here, I hope you know that it is easy for me here to, what can I do here? I can make a the subset formula here, very, very easy. So from here, I can say that a is equals to what? Y double prime divided by what? 2. I've gotten my a, so the next thing would be to what? To get my b. Then how can I get b? I have to substitute this answer back in what? Equation 1. So what is my equation 1 now? Equation 1 is what? Y prime equals to what? 2ax plus what? Plus b. Then what will I have here? I will have y prime equals to 2, open bracket. What is your a here? Y double prime over what? 2 multiplied by what? X plus b. Then these ones can cancel out, so I can have y prime equals to what? X y double prime plus what? Plus b. Are we together? Then from here, get your b. Easy. So your b here will now give you what? Y prime minus what? X y double prime. Yes or no? So I've gotten b. So the next one now, since I've gotten my a and I've gotten my b, so the next one that I have to do is what? Put both of them back inside your what? Original equation. Right? Right? Okay, let's do that. So I will now have y equals to, I have here to be ax squared plus what? Plus bx. So let's substitute. I can have y equals here. What is my a? Can have a is what? Y double prime over 2 multiplied by x squared plus b is what? Y prime minus x y prime prime multiplied by what? X. So now let's open the bracket here. What will I have? Y equals to what? X squared y double prime over 2 plus, using x to multiply this bracket will give you what? X y prime minus what? X squared y double prime. Yes or no? Then I can call this one over 1, or better still, without doing that, I can multiply everything by what? By 2. So multiplying everything here by 2, what will I have? I will have 2y equals to what? X squared y double prime plus what? 2x y prime minus what? 2x squared y double prime. Yes or no? Then from looking at this, you have 2y equals to, now if you find out and notice that x squared y prime prime and minus 2x squared y prime prime are the same thing, then I can have something like 2xy minus what? X squared y double prime. Are we together? By collecting the like terms of this and this. Yes or no? So for me to continue here, so I can either leave my answer like this or decide to take everything to the other side. So what will I now have here? I will have x squared y double prime minus what? 2xy prime, right? Plus what? 2y equals to what? 0. Are we together? So from this, I can say that this one is a what? Is a differential equation. So that let's name this differential equation together. So this will be what? A second order. Yes or no? It will be a second order. What will be the degree? A first degree. Yes or no? Is it linear or non-linear? It's what? Linear. Yes or no? Is it homogeneous or non-homogeneous? It's what? Homogeneous ordinary differential equations. Do you understand? Are we sure? Alright, so moving on to the next one. I hope you're not getting tired. You can't get tired now. Alright, so let's look at number 2. Number 2 looks familiar to some people because probably you have done that as a part of assignment before, right? So y equals to a over x plus what? Plus bx. Are we together? Are we together? Okay, good. So as usual here, the same way I did there, the same way I'm going to do here. But here I want to make my work look a lot more easier. Are we together? So let me rewrite this equation here. So I can say that this equation is the same thing as saying y equals to ax to the power of minus 1 plus what? Bx. Yes or no? By law of indices, right? Then so from here, let's differentiate. So y prime should give me minus ax minus 2 plus b. Are we together? Then again, I can call this one here equation what? Equation 1. Then differentiating again, what will I have? Y double prime equals to what? 2ax to the power of what? Minus 3, right? Okay, good. So if I rewrite this equation again, I want to write it. So I hope you know that this one here is still the same thing as saying y double prime equals to 2a over what? X cubed. Yes or no? Then from here, let's what? Cross multiply. So by cross multiplying, what do I have? I have x cubed y double prime equals to what? 2a. Are we together? Then from here, what do I have to do to get my a? Divide both sides by 2. I can say that my a here is equals to what? X cubed y double prime divided by what? 2. This is what? Sorry, I can't call it equation 1. I've gotten my a. Now the next thing I want to do here is to what? To substitute. So now let me put this answer here inside what? Equation 1 to get for what? Get for b. Then I can say that I have y prime equals to minus a, or let me say minus a over what? X squared plus what? Plus b. Are we together? Okay, good. Then from here, I let me manipulate it again. So by manipulation, it's still the same thing as saying minus a multiplied by 1 over x squared plus what? Plus b. Yes or no? Okay, good. Then from here, so I want to move up. So from here, it's still the same thing as saying. So let's substitute now. I can have y prime is equals to, what do I have here? Minus, what is my a, please? My a is what? X cubed y double prime over 2 multiplied by 1 over what? X squared plus b. And I hope you know that from here, x squared here can cancel x cubed to give me what? X. Are we together, please? Then so from here, what can I have? I'll have what? Y prime equals to what? Minus x y double prime over what? 2 plus what? Plus b. Then I think it's easier if I don't want to prolong matters, because if I wanted to prolong matters, I would have said that I multiply everything by 2, and at the same time 2 will come here, then at the same time I have to divide everything by 2 again. Yes or no? So let's keep that process. So let me take everything here to the other side. I can have b here will now give me what? Y prime plus what? Xy prime prime over what? Over 2. Are we together? Then from here, I've gotten a and I've what? And I've gotten b. So I've gotten both of them. So what else do I have to do? I have to substitute them back inside this space here. Now where's my general equation? My general equation here is what? Y equals to. So let me write it in a way that looks a little bit more more straightforward for me to write. So I can say that I have a multiplied by 1 over x plus what? Bx. Yes or no? Yes or no? Alright, good. So from here I can have y equals to, what is my a now? My a is what? X cubed y double prime over 2 multiplied by 1 over x plus what? B. What is my b now? Y prime plus what? Xy double prime over 2 multiplied by what? X. Yes or no? Then from here, what do I do? So let's open the bracket. So I have x here. So if x here cancels x cubed, what do I have? I have y equals to what? X squared y double prime over 2 plus, let this x open this bracket. So what will I have there? I will have xy prime plus what? X squared y double prime over what? Over 2. And I hope you know that these two here are the same thing. Or better still, instead for you to do fractions, multiply everything what? By 2. So multiplying by 2, what do I have? I have 2y equals to what? X squared y double prime plus what? 2x y prime plus what? X squared y double prime. Then rewriting everything here, you can have what? 2y equals to what? 2x squared y double prime plus what? 2x y prime. Yes or no? You know why it's like that? It's like that because of the fact that I have this one to be what? X squared y double prime. This one is what? X squared y double prime. So from here I have 2 all through. So what do I have to do? Divide both sides by what? By 2. So dividing both sides by 2, what do I have? I have y equals to x squared y double prime plus what? X y prime. Then if I want to write everything that looks like a normal equation. So what do? I carry this y to the other side. Then I can have what? X squared y double prime plus xy prime minus y equals to what? 0. So this is a what? Differential equations. Do you understand? Don't be tired though. We have created a lot of problems that we must solve. Have you now? You gotta solve all the problems. Do you understand, please? Do you understand, please? So I hope by now you might have been able to get the technical know-how of how to form equations. What is the technical know-how? The know-how is that whenever you have a differential equation, the first thing you have to do is what? Find the values of your corresponding A and B, right? Then if you have got the value of your corresponding A and B, then the next thing for you to do is what? Substitute that value back inside your what? Original question. Yes or no? Okay, good. So now let's look at number 3. So looking at number 3 this time around, what will I have? What is number 3? I have y equals to what? A sine 3x minus b cos 3x. Are we together? Are we together? Then from here, I can say that this one here is very easy for us to differentiate. I hope by now I don't have anybody that is a newbie in differentiation. No, we don't have that. So now let's differentiate y prime here. So by differentiating y prime, what do I have? I hope you know that we have 3a cos 3x. Yes? Alright, good. And here, what do I have? I have plus 3b sine 3x. Yes or no? Right? Alright, so this time around, let me say I have y double prime, which is the same thing as what? Minus 9a sine 3x plus what? 9b cos 3x. Are we together? Are we together? Are we together now? Let's talk, please. Let's talk. Now from here, you look as if I'm supposed to find A and B now. As usual, sorry, as we usually do it. So from here now, do you know that if I factorize minus 9 out from this place here, what would I end up having? I will end up having A sine 3x plus B, minus B cos 3x. Yes or no? And if you can observe, you find out that your y is the same thing as what? A sine 3x minus what? B cos 3x. Yes or no? So that means, so from here without stress, I can say that y double prime is equals to what? Minus 9y. Then take this one to the other side, then you can have y prime prime plus 9y equals to what? 0. So differential equations. Do you understand, please? Are you sure? Alright, good. Let's continue. So we've treated 3 of our problems. Have you now? So let's solve. So let me drop a practice question for you to go and try at home. It should be the longest you'll ever, probably, if you do it. It should be the longest you ever do. Y equals to exponential ax, or don't let me put ax, exponential x open bracket, a sine, let me put 3x plus b cos 3x. So if you do that question, it will be the longest you ever. I think I can still get the question. I hope we wrote the question down. Now the other question that we have here is that y is equals to a exponential 3x plus b exponential what? X. Right? Okay, we are still writing. So let me wait. I never have beautiful faces, eh? Faces are beautiful. I do not. Alright, so yes, ma'am. Okay, thank you very much. That's a good question. Why did I have to replace everything here with y? Okay, now the thing is, sometimes it's good to avoid stress. Sometimes very, very good. So now, if you observe here, you see that a sine 3x minus b cos 3x. What I have here is the same thing as what I have here. Right? Good. So it will be, how do I call it? It will be a misnomer on my own part. Or let me say, the fact that I love stress a lot. Stress is my middle name. And for me to now move from here, then solve simultaneously, you understand? Then now start cancelling out. You get what I'm trying to say? So since I have this to be equal to this, and everything here is y, so it is easier for me to just move from here to this place here, and you get your answer. Then I can guarantee you that if you will try it in the other way, by solving a and b, you will still get the same answer. But I said, if you will try it, it's you that is trying it, it's not me. So let's do that. Can we continue, please? Okay, good. So from here, y prime here, by differentiating y prime, what do I have here? I have 3a exponential 3x plus what? b exponential x. Yes or no? On the other hand, also, second differentiation here, y double prime here would give me 9a exponential 3x plus what? b exponential what? X. This is equation 1. This is what? Equation what? Equation 2. Now, you'll find out that unlike the other two examples that we did, that it was easy for us to, and I find out that towards the end of the probably the second differentiation, one of the variables will have left. Yes or no? But this time around, none of the variable here is leaving. They don't want to leave. But we have to make either of them leave. So what do we do? So let me rewrite it, or let me write it on another way around. Or before I do that, you observe that b exponential x and b exponential x is the same thing on this part. And I can solve simultaneously. Yes or no? So let's solve simultaneously this equation. And how do I eliminate b on this part? I what? I subtract both sides. So now, before I do that, okay, let's do the subtraction together. So by subtracting both sides, by saying equation 2 minus equation 1. So what will I have here? So what is equation 2 minus equation 1? That means everything down here minus everything that is up. So that will have, what will I have? I will have what? Y double prime minus y prime. Are we together? Is equals to 9a exponential 3x minus what? 3a exponential what? 3x. And at the end of the day, b exponential x minus b exponential x will give us what? 0. So I have eliminated what? I have eliminated b. Then from here, what will I have? I'll have y double prime minus y prime equals to what? 6a exponential what? 3x. Then from here, it is easy for me to what? To make my a stand alone. What do I do to that? I divide both sides by what? 6 exponential what? 3x. So by dividing both sides, I will have y double prime minus y prime divided by 6 exponential 3x is equals to what? A. So I've gotten a. Then the next thing we have to do is to what? Is to find a way to get b. So let's get b on this part. So how do I get b? So you can choose at your own discretion to substitute any way you want to substitute. So I will say, I think it looks easier to substitute to equation 1. Okay, so let's say, so I can say put a equals to y double prime minus y prime over what? 6 exponential 3x in what? Equation what? Equation 1. Are we together? Are we together? Alright, good. Let's talk now. Good. Aha. They're human beings. And human beings what? Human beings what? You talk. Yes. So now what's in equation 1? You have y prime here, right? Equals to what? 3a exponential 3x. Are we together? Plus what? b exponential x. Then what is y prime here? Y prime here will now give me 3 multiplied by, what is my a here? My a is what? Y double prime minus what? Y prime over what? 6 exponential 3x multiplied by what? Exponential 3x plus what? b exponential what? X. Are we getting it? Are we sure? Alright, good. So from here, I hope you know that exponential 3x can cancel exponential 3x outside. Then 3 here 1. This one will give me what? 2. So what will I have left? I'll be left with y prime equals to y double prime minus what? Y prime over 2 plus what? b exponential what? X. Are we together? Okay, now I want to make my work, I want to elongate it and at the same time make it short. I'll do two things to it at the same time. Okay, so from here, let me multiply both sides by what? Let's multiply both sides by 2. So what will I have here? I will have 2y prime equals to what? Y double prime minus what? Y prime plus what? 2b exponential what? X. So what am I looking for? B. So take these ones to the other side. What will I have? 2y prime plus y prime minus what? Y double prime equals to what? 2b exponential what? X. Are we together? Then from here, all I have here, 3y prime minus y double prime equals to what? 2b exponential what? X. Then are we together? Then the next one that I will have here is to divide both sides by what? 2 exponential x. Then by dividing both sides, what will I have? 3y prime minus y double prime over what? 2 exponential x equals to what? Equals to b. Are we together? Alright, so from here, I have confidently gotten my what? I've gotten my a, and at the same time, I've gotten my what? I've gotten my b. Right? Okay, so the next thing I have to move on to is to substitute a and b inside my what? My general equation. It looks long, Abby, but at least it's interesting as you're solving it. Yes or no now? Yes. Aha. You're enjoying it. You're just lying. So let's go. So you have here to be y equals to what? A exponential 3x plus what? B exponential what? B exponential x on this part here. So from this part here, I have my a and I have my what? My b. So plug them in. You have y equals to, what is my a here? My a is y double prime minus y prime divided by 6 exponential 3x multiplied by exponential 3x plus, what is my b now? My b is what? 3y prime minus y double prime over what? 2 exponential what? X multiplied by what? Exponential x. So at the end of the day, you'll be having what? Y equals to what? Y double prime minus y prime over 6 plus what? 3y prime minus what? Y double prime over what? 2. So what's the LCM here? The LCM here is what? Is 6. So multiply everything by what? By 6. So you end up having 6y equals to y double prime minus y prime. Are we together? Plus what? 3 open bracket y prime minus y double prime. Yes or no? Right? So from here, if you open your bracket, so you have 6y equals to what? Y double prime minus y prime plus 3y prime minus 3y double prime. Yes or no? Right? Is there any problem? What's the problem? Okay, there should be a 3 here. Okay, good. Then this will make this one look like 9. Then, right? I think everything's balanced like this. Okay, good. Let's continue. So collecting items here, you have 6y equals to y double prime minus this should give me what? Minus 2y double prime, right? Then minus 9y plus 9y, I mean minus y prime plus 9y prime should give me what? Plus 8y what? Y prime. Then I can divide everything by what? By 2. Then what do I have here? I can have 3y equals to what? Minus y double prime plus what? 4y prime. Then if I decide to do a little movings, then by movings here, what do I have? I'll have y double prime minus 4y prime plus what? 3y equals to what? 0. So that's your what? Differential equations. Do you understand? Okay, question. Where is the exponential that is here? Okay, where is it? This part. Here. Here. Okay, good. So what happened here was that I had 6 here, I had 2 here, and I wanted to find the LCM. I think the best way to do that is by multiplying everything that is here by 6. So 6 times y will give me 6y. If I multiply everything here by 6, 6 will cancel this 6, then I'll be left with this. Then if I multiply everything here by 6, 2 in 6 will give me what? 3. That 3 will be left to open this bracket. That's how this is my 3 here. Shake grab. Then use 3 to open the bracket and you continue suit. Do you understand? Okay, good. So this is our what? Which question is this? How many questions is this? These are 4 problems that we have solved. Okay, let's continue solving the problems. So to continue to solve the problems, So what's the next problem I have? What's the next problem I have? Okay. Do you have someone that wrote the problem? Jeez. Y equals to... Okay, yeah, y equals to is the cube part now. Ax cubed plus bx squared plus what? Cx. Okay. Now, let's see what will happen if we have three variables. So how many times are we differentiating? 3 times. So let's start. Y prime here should give me what? 3ax squared plus what? Plus 2bx plus what? C. Right? Y double prime should give me what? 6ax Abi? Plus what? 2b. Left, right. Now the next thing that I have to do here is to do y cube prime here. Now give me 6a. Yes or no? And as soon as I've gotten 6a, so what is the first thing I have to do? Back to side. So I can say that here a is equals to what? Y cube prime divided by what? 6. Now I've got a. So the next step I have to do is what? Substitute that a back inside my this equation to get my b. Then I have what is that? So y double prime equals to what? 6ax plus what? Plus 2b. Yes or no? Then from here you have y double prime equals to what? 6 open brackets y triple prime over 6 multiplied by what? X plus what? 2b. So 6 cancels 6. So what do I have here? I have what? Y double prime equals to what? Or let me say you have x y triple prime, right? Plus 2b. Are we together, please? Yes. And since I've gotten this, so how do I 3ax squared plus 2bx. Move all of this one to the other side. Are we together, please? Yes. Aha, yeah. Let's be together. Don't leave me on the road, please. Follow me. So from here, what do I have? I have 2y prime minus 2x y double prime, right? Plus what? X squared y triple prime equals to what? 2c. Then here, I can now say that your c is now equals to what? 2y prime minus 2x y double prime plus what? X squared y triple prime. Everything divided by what? 2. Everything divided by 2. So I've gotten that like that. So I've gotten A, I've gotten B, and I've gotten what? I've gotten C. So what will be the next step? The next step that I will do there will go to what? Substitute A, B, C inside your what? General equations. Yes or no? Yes. Alright, good. One thing about mathematics is that the longer math becomes, the more interesting it is. Yeah. Especially if you know what you are doing visually. Yeah, so the longer it becomes, the more interesting it will become. So just you understand, just reflexing. Let's continue now. So what is my general equation here, which is what? Y equals to what? Ax cubed plus what? Bx squared plus what? Cx. Are we together? Yes. Therefore, yeah, so let's start. So I have y. So what is my a first? So I have y triple cube over 6 multiplied by what? X cubed. Are we together? Then
Plus, what is my b now? Y double prime minus x y triple prime, right? Over 2 multiplied by what? X squared. Then plus what? What is my c now? C is what? 2y prime minus 2x y double prime plus what? X squared y triple prime divided by what? 2. Everything multiplied by what? X. So let me make my work very, very easy. So what will I do to make my work very, very easy? Multiply everything by what? By 6. So multiplying everything by 6 should give me what? 6y equals to what? X cubed y triple prime, right? Plus what will I have here? 3x squared multiplying what? Y double prime minus what? Xy triple prime. Plus what do I have here? 3x multiplying what? 2y prime minus what? 2x y double prime plus what? X squared y triple prime. Are we together? Then from here, so what do I have? I have 6y equals to x cubed y triple prime plus what? 3x squared y double prime. Are we together? Minus what? 3x cubed y triple prime. Yes or no? Then plus what? 6x y prime. Then again minus 6x squared y double prime, right? Plus 3x cubed y triple prime. It's very long. I'm actually excited about it. Now let's look at it critically. You find out that the same thing. I can say that this one here cancels out this one. Yes or no? Okay, is there any other one that is the same thing again? No. So I can have 6y equals to what? X y triple prime. Are we together? And let's take it step by step. So here I have minus 6x squared y double prime, and here I have what? 3y squared y double prime. So minus 6 plus 3 should give me what? Minus 3x squared y double prime plus what? 6x y prime. So at the end of the day, so move everything to all the sides you have to move it. Then you have what? X cubed y triple prime minus 3x squared y double prime plus what? 6x y prime minus what? 6y equals to what? 0. So that is the answer. Do you understand? Do you understand? So I think the one I want to do now will be the last problem I want to solve before we go on and create more problems. Yes. We're in the weekend of creating problems. Don't worry, we'll create the problems and we'll solve them together. Is that okay? Alright, so let me leave this space to us while we solve. So the last question here, I hope you're done writing, because I'm waiting for us, actually. So the last question there should be, yeah, I think that one is very simple now. That one should not stress us. What's the last question? I think that's the one that we have, y is equals to mx minus 7 or plus 7.
Which one? Plus 7. Okay, good. So now here, as I've said, this time around, how many arbitrary constants do I have? How many arbitrary constants? I have only one arbitrary constant. So how many times am I differentiating? Differentiating once. So if I differentiate once, I have y prime here is equals to what? Is equals to m. Straight up. Let's say I've gotten my m, then what do I have to do next? Substitute this back inside this equation. Then what do I have? I have y equals to what? Y prime x plus what? 7. Sorry? 7. Then the next thing that will happen from here will be, I should now, let me rearrange it. So by rearranging here, what do I have? I have x y prime, right? Minus y plus 7 is equals to what? 0. So this will be my answer. Do you understand? Okay, good. So that will be that about that for forming differential equations. So the next step we want to be looking at now will be verifying. Yes, now next topic we'll be looking at, which will be verifying solutions. So I want to be verifying solutions. So to be verifying solutions, yeah, so this time around we want to check if whatever answer we are given will give us the question we have before. I'll get what I'm trying to say like that. Now the ones we did earlier on was that we moved from question to what? To answer. So now this time around, let us move from where? Answer back to what? To question. Are we together? Okay, so let's see. So we have two parts in it. The first part is the implicit solution, and the second part is the explicit solution. Now from the word explicit means is a kind of solution that the dependent variable and the independent variable can be written what in terms of each other. Like x can stand alone, y also can stand alone. But when I'm talking about explicit solution, implicit on the other hand, implicit will be that the function is written in such a way that x and y are always together no matter what you do. Are we together? Okay, what I mean is that, for example, if you look at this, 3x plus 4y equals to 8. For example, now let's assume that this is a solution. Now from this one here, I can either make x the substitute formula without any problem, or y the substitute formula here without any problem. Have you now? So let's make x here. If I want to make x stand alone here, what do I have? I have 8 minus 4y divided by 3. And also y in this case will give me what? 8 minus 3x divided by what? 4. So this kind of thing here is what? Is explicit. So now implicit on the other hand is when you have something like this, which will give me 3x squared minus 4y squared plus 2xy equals to 0. I hope you know that no matter how smart you are, there's no way you can separate x from y here. Happy now? So this, whatever this one is here, this will give you what? An example of what? This is an example of what? An implicit. I'll get on and say please. Okay, good. So this time around, I want to be verifying solutions, but the solutions I want to be verifying are explicit solutions. Explicit solutions. Explicit solutions. So let's generate more problems as usual. So let's create problems that will solve. Okay, so my first thing is that verify that verify that y equals to exponential. Okay, let's do e exponential 3x plus b exponential minus 3 y prime minus 4y prime
plus 3 equals to 0. Yeah. So let's look at something that looks like this. Okay. All right. So let's look at something that looks like this. I want to show that this thing here is the solution to this thing that is here. Now how do we look at that? How do we do that? Now first thing is that for anytime you're asked to verify, the thing you have to do is that make sure that you differentiate your solution in the number of required times it is required in the question, and you substitute. I get what I'm trying to say like that. If you ask to verify, are you getting it? So from here, what solutions do I have? I have y double prime minus what? 4y prime plus what? Plus 3 equals to 0. That means, what do I have here? I'm ended up differentiating this one here. I'm differentiating it twice. So my first differentiation, which is y prime here, should give me, if I differentiate this, what do I have? 3a exponential what? 3x plus what? b exponential x. Okay, good. Now, y double prime, I differentiated this one again. What would this one give me? So I have 9a exponential 3x plus what? b exponential what? X. So I have gotten my y double prime, I've gotten my y prime plus 3. So I have to substitute both of these solutions with my y. Okay, this should be 3y, sorry. Inside this place. Can we start now? Let's start. So where's my y double prime here? And I have 9a exponential what? 3x plus what? b exponential x. The next one here, minus 4. What is my y prime here? 3 exponential 3x plus b exponential x. Then the next one here, plus what? 3. What is my y here? My y is what? a exponential 3x plus what? b exponential x. So now let's now find out if by expansion of this I will have 0. I will have 9a exponential 3x plus b exponential what? X. I will take it up. Then what would this one give me? Minus 12a exponential 3x plus, minus 4b exponential x. I will take it up. Then plus what? 3a exponential 3x plus what? 3b exponential what? X. So let's collect like terms together, all a exponential 3x together. So from here I can have 9a exponential 3x plus 3a exponential 3x minus 12a exponential 3x. I will take it up. Then next one again, plus what? b exponential x plus 3b exponential x minus 4b exponential x. Adding this one together, what do I have? 12a exponential 3x minus what? 12a exponential 3x plus what? Plus 4b exponential x minus what? 4b exponential x. At the end of the day, what do you have here? 0 plus 0, which will give me what? 0. Since I have 0, then I have verified that this fine boy here is a solution to this differential equation. Do you understand? Yes, sir. Okay, good. So another problem. So now next one is that we are verifying that to the differential equation. Alright, so here I can have y double prime minus 2y prime minus 8y is equals to 0. So now I want to do this verification now. I want to show that if I differentiate this answer here, then at the end of the day, this is, if I work on this, I should have this at the end of the day. So can we try that? Let's try. So moving on to this part. So moving on to the second part here. So let's start. So as usual, the first thing I did here is the same thing I'm repeating here. So let's differentiate the first one first. So I have y prime here. So what will y prime give me? Y prime will give me minus 2a exponential minus 2x, then plus what? 4b exponential 4x.
Then differentiating again y double prime, which should give me this time around. So I have 4a exponential minus 2x. Then this time around plus what? 16b exponential what? 4x. So now let's substitute everything I have back inside this place. So what's my y double prime here? So I have 4a exponential minus 2x. Are we together? Plus 16b exponential 4x. Then what do I have here? Minus 2 open bracket. What is the y prime there? I have minus 2a exponential minus 2x plus what? 4b exponential 4x. Are we together? The next one is what? Minus 8. So what is my y there? A exponential minus 2x plus b exponential 4x. So opening your bracket here, so you have 4a exponential minus 2x plus 16b exponential 4x. What do I have here? So plus 4a exponential minus 2x minus 8b exponential 4x. Then what do I have here? Minus 8a exponential minus 2x plus, minus 8b exponential 4x. Then so from here, let's collect like terms together. All exponential 2x on one side. So what do I have? 4a exponential minus 2x plus 4a exponential minus 2x minus 8a exponential minus 2x plus 16b exponential 4x, then minus 8b exponential 4x minus 8b exponential 4x. Then at the end of the day, what do I have here? I have 8a exponential minus 2x minus 8a exponential minus 2x, then plus 16b exponential 4x minus 16b exponential what? 4x. At the end of the day, I have what? 0 plus 0, which is the same thing as what? 0. So therefore, this solution here is a what? It's an explicit solution to what? To our differential equations. Do you understand? Do you understand? Yes, sir. Okay, good. So now, another questions. Let's create more questions, eh? Have you now? Let's create more problems. Are we tired? No. I hope you're not tired of creating problems. Alright, so now we have looked at two calibers of question, and let's see. I want to change the differential equations. So I want to change the solution. Now what will happen now if this time around I have, let's verify. So verify that y equals to a sine 3x minus b cos 3x is a solution to, are we together? It's a solution to y prime prime plus 9y equals to what? 0. So I want to verify this. If you can recollect, I think we did something that is similar to this now. Abi? Okay. So let's look at it now in this time. So from here, so let's start. So what will be, so how many times am I differentiating here? I'm differentiating twice. So what is, so y double prime, wait, y prime first. So y prime here will give me what? A, no, not a, now this time it will be what? 3a cos 3x. The next one is what? Plus 3b sine 3x, you right? The next one is y double prime, which should give me minus 9, minus 9a cos 3x. Are we together? Sorry? Now this time it will be sine. Then plus 9b cos 3x. So let's verify this. So by verification of this one, what do I have? I have minus 9a sine 3x, are we together? Plus 9b cos 3x, are we together? Plus what? 9, open bracket. What is my y now? My y is what? A sine 3x minus what? B cos 3x, are we together? So let's verify this. What do I have here? I can have what? Minus 9a sine 3x plus 9b cos 3x plus what? 9a sine 3x. Minus 2x is a product rule. Yes or no? Yes or no? So now let's deal with this one separately first. So let me carry these two here. So let's say I have x exponential minus x. Let's say that this one is equals to y. Are we together? So let's deal with it separately. So by differentiating this y prime, if we follow product through, which is u dv plus what? V du. So what is my u here? This is u, this is what? This is v. Let's differentiate. So what is u here? You give me what? X open bracket. Differentiating, so what I have? Exponential, sorry? Minus exponential minus x plus what? Exponential minus x open bracket. What do I have here? 1. Yes or no? Then by opening this bracket, I can have minus x exponential minus x plus what? Exponential minus x. So that's my first derivative. Now what will be my second derivative? Y prime prime. So what would I have again? I have minus x open bracket minus exponential minus x plus exponential minus x open bracket minus 1 minus exponential, sorry, yes, exponential minus x. Do you get what I did? Okay, let's do it again. Then from here, product rule again, u and what? V. So what do I have here? I have minus x. If I differentiate this, what do I have? Minus exponential minus x. Are we together? Plus exponential minus x. If I differentiate this, what do I have here? Minus 1 plus, if I differentiate this, what do I have here? Minus exponential what? Minus x. I can say y double prime here is equals to x exponential what? Minus x minus exponential minus x. Are we together? Minus exponential minus x. Right? I can now have y double prime here is equals to what? X exponential minus x minus 2 exponential what? Minus x. So this is, let me clean this. This is my what? First solution. This is my what? Second solution. So let's now come back to where I came from. So which is, so let's now have, so y prime here. So if I differentiate this, y prime here will now give me a. So if I differentiate this, what did I have? Minus x exponential minus x plus exponential minus x. Are we together? Plus b. Are we now? Then let's differentiate again. So y double prime now will now give me a open bracket. Differentiating this one again, what did I have? X exponential minus x minus 2 exponential minus x. Are we together? I think that's all. So now let's now substitute everything I have. These two answers, these three answers, then put them back. Wait a minute. Okay, wait. Let's be calming down now. Okay, from this part, I think this part is correct. Okay, the question. Okay, it's minus 2x. I did minus x. Change this thing now. Have you now? Have you now? It has balanced like this. Let's continue. Don't stress me by cleaning the board again. Have you now? We can just leave this one to be like this. So let me change this one to what? To minus x. Equation balance, equation balance. Fire on. So from here, so what do I have here? So I can have, substituting, so I have a open bracket, what do I have here? X exponential what? Minus x. Are we down? Minus what? 2 exponential minus x, right? Then plus what? 2 open bracket, what do I have here? A open bracket what? Minus x exponential minus x plus exponential minus x. Are we together? Plus b. Okay, then the last one plus, what is my y? So I have a x exponential minus x plus what? Bx, right? Right? So now from here, what do I have? I can have ax exponential what? Minus x minus 2a exponential what? Minus x. Then minus 2a x exponential minus x. Are we now? Then plus what? 2 exponential what? Minus x. Are we together? Plus 2b. Where are we lost? Okay. Okay, yeah. So this will be an a here. Then plus what do I have here? Plus what? Ax exponential minus x plus what? Bx. Okay. So let's start cancelling. Do you have any cancelling? Okay, yes. Look as if we have. So I can have a exponential minus x and a exponential minus x should give me what? 2a x exponential what? Minus x minus 2a x exponential what? Minus x. Are we together? Minus 2a exponential minus x. Are we together? Plus what? 2a exponential what? Minus x. Okay, I think the last one is what? Plus, what is next one? I think I've picked this, I've picked this, I've picked this, I've picked this. Then plus 2b plus what? Bx. I think at the end of the day, everything here will what? Cancel out. Then I'll be left with what? 2b plus what? Bx, which is not equal to what? 0. So at the end of the day, I can now say that this answer here is not a solution to this differential equation. Do we understand now? Are we sure? Okay. So another subtopic that we are going to. So far so good. We have looked at. Okay. Then let me do the revision now. So now let's now look at family of curve. Family of curves. Yes, family of curves. Family of curves. Let's look at family of curves. So now, actually, before I enter this place here, if I come inside this place, there is one particular and important law you must know it. Very, very important. And the law is that you have to be able to state the existence and uniqueness theorem. You must be able to state it. You must be what? Able to what? To state it. The existence and what? Uniqueness what? Theorem. So, but this time around, I will give you that as an assignment to go and work personally by yourself. But let us now learn family of curves. Are we together? So the family of curves will be the first step we have to learn before we enter solutions to differential equations. It will be the first thing we have to learn first. Now, family of curves. Now, I want to call our attention back to integration. So if I call our attention back to integration, I want to know that if I integrate, for example, if I integrate 2x squared plus x minus 5. Okay, let's integrate this. Let's go back to our normal integration. So if I want to integrate this, so what will I have here at the end of the day? I will have what? 2x cubed divided by 3. Yes or no? Then plus what do I have here? I will have what? X squared divided by 2. At the end of the day, what do I have here? I will have what? Minus what? 5x. Now, you will find out that this type of integration here is not a definite integral, in the sense that I am not bounded in my area here. So I can say that this one at the end of the day we have what? We have c, arbitrary constant. Are we together? So I think, let me just bring this one down. So let me say that probably this one was y prime equals to this. So my y here should now give me 2 over 3 x cubed. Are we together? Plus 1 over 2 x squared minus what? 5x plus c. Now one thing I wanted to know is that this c that is here can pick any values from minus infinity to what? Positive infinity. Yes or no? And it will still not affect, although the effect it will have on my question will not be much. But I'm not saying that this c can pick within any of these values. And do you know that for this same type of equation, I can have different type of graphs if I plot it? Are you getting it? So all those type of graph formed from one type of equation is known as what? Family of what? Family of curves. Do you understand? Do you know that from here, if I want to plot a graph, if this one here was 1, the graph I will have when this one is 1 will be different from the graph I will have when this one is what? 15. There's a particular given. Let's sketch the family of curves for y dx equals to 2x, let me see, okay, let me put 3x squared minus let me give us a graph that we can easily sketch. Let's say we have 2x plus 5. Yes, I want to sketch the family of curve for this. This is, I think, might not be exactly word for word question, but this question came out in to get y in this scenario is by integrating both sides. Are we together? So now let's integrate both sides. So integrate both sides. So by integrating both 5, are we together? Or to make it look a little bit more professional, before I integrate this part, let me say, before I integrate this part, let me say cross multiply or multiply it by what? By dx. I want to make it look a little bit more professional, so I can have dy. I can have here to be dy equals to what? Integrating both sides plus 5. I put together dx. So now if I integrate dy, the integral and the d's cancel out to give me y equal that my own family of curve that I want to plot will be what? Y equals to what? X squared plus what? 5x minus what? Minus 13. So this is what? Quadratic equation. So, and I hope you know that this quadratic equation is what? Is the x squared is what? Is positive, is a positive value. So if I want to sketching this one here should give me something that looks like this. I might not be correct, but this is how the graph will look like. Do you understand? Do you understand? So this is an example of a sketching of your family curve. So you might decide that you don't want to go my way, and you want to what? Go your way. And your way is that you cannot plot anything you have to plot. But in case a question like this come out in the exam and they ask you to what? Sketch the family of curve. So the only thing I have to do is that you have to create a table of graph. I get in so that my graph can be what? More accurate. So let's say for example here, let me create a table of graph. So I can say that, let me say that my x is from the range of minus 1. No, then let me start from minus 2, minus 1, 0, 1, out, and 2. So from here, and my y. So let's start substituting each of these values. As I said, this is my choice. Are we together? This thing I'm doing here is what? My choice. So you can choose to do it another way. I get what I'm trying to say like that. So now from here, so when x is equals to minus 2, if I put it here, what will I have? I think I will have 4 minus 10 minus 13. So 4 minus 10 is minus 6. Minus 6 minus 13 should give me what? Minus 19. Then let's put minus 1 here. So what do I have? I'll have 1 minus 5 minus 13. So 1 minus 5 is what? Minus 4, right? So minus 4 minus 13 should give me what? Minus 17. So putting 0 here, what will I have? Minus 13. Okay, good. Then if I put 1 inside this place, what will I have? I'll have 1 plus 6, which is equals to what? Minus 7. I'll take that. Then putting 2 here, what will I have? I have 4 plus what? 10, which is 14. 14 minus 13 will give me what? 1. So with this one here, I hope you know how to plot the graph now. Then you draw your what's it called? Your x and y axis. At the end of the day, you have something that looks like what? That looks like this. Do you understand what I'm trying to say like that? So from here, I have successfully sketched the what? The family of curve. So if you want again, probably if you are spaced with time, you can choose again to create another entire value for y and x. And what do you have? What would that happen? That means you have another entire value for your what? For your c. And if you have another entire value for your c, you can create another entire table and plot another entire graph. I will get what I'm trying to say like that. So whatever I'm doing here is an example of what? Family of curve. Do we understand? Do we understand? Let's talk now. Do we understand? Aha, yes, we are human beings. So now, we are done with this part. So now, we have treated all the preliminary parts. Yes, ma'am. Okay, this is the graph. Thank you very much. So, this, I think I have the graph here. So if you want to master how to plot graph better, you can download Desmos graph plotting app. Desmos. 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 So you can go to your Play Store, download Desmos, and with Desmos you can plot this graph. And I think I have a copy here with me. So if you want to know how that graph will look like, you can plot it. And I hope you know that my graph might look the same, but it will be different in the sense that if my C is different here, do you know that if my C here was not negative starting, I cannot have negative in my answer like this? I get what I'm trying to say. And so this negative I have in my answer will mean that the kind of graph I will have might change. I get what I'm trying to say like that. So that is the effect of having what? Your C. Do you get me, please? Are you sure? Can we continue now? Alright, good. So this is one. Okay, so the next one we want to look at now, let's now look at solution to first order differential equations. How do we solve first order differential equation? Yes, ma'am. Yes, the y prime prime here. Yes. How do I get these two here? Okay, I think the workings that, oh jeez, I have, is it still on the board? No, I've rubbed it off. I think I did a differentiation of this one twice. And by the time I did the differentiation, I had this answer. So you can probably help me check on patients beside you. Or probably after, I will explain again. Alright. Okay. Any question again? Any question? Are we good to go? Yes, sir. Are you sure? Yes, sir. Alright, let's go. So let's now start. So now we are looking at solutions to differential equations. Now how to solve solutions to differential equations. Now another thing I want to let you know is that equations are meant to be solved, yes or no. So whenever you have equation, the end point of you having equation is that equation is what is solved, yes or no. Now, so now we want to look at different ways that we can solve what your differential equation. Yeah, I think we have a lot of ways, but let's look at it step by step. So let's look at how far we can get to before the end of the class. So now the first type that we have, let's look at, let me just list them. Now we start by direct integration. Now the second one that we'll have will be separation of variable. Separation of variable. And the next one that I will have here will be homogeneous. Are we together? Now next one that I will have here will be linear. Then we'll have Bernoulli. Then lastly I'll have exact. So this is everything we'll be looking at. So now I think for better understanding, I will make it look in such a way that probably we can have maybe about 7 examples per method. I think 7 examples should be enough now. That means if you see any example like that, you're able to what? You smash it. So now whenever we have differential equations, these are the ways that we can solve. And one problem that differential equation always have is that it takes constant practice before you can be able to know which method you are supposed to use for a particular question. I get what I'm trying to say like that. So the fact that it is a differential equation does not mean that it can be solved with all of the methods that I have there. Are you getting me, please? Okay, good. Now let's now start differential equations. I mean direct integration. And also to make the work a little bit more faster, probably you can get this PDF, practice it at your own, and probably I might even need it as questions because I think I've been creating questions here since morning. It's time for you to give me questions. But the way you can get questions is probably you can download this PDF, HK engineering maths. You can download it. Is on Google. You can download your normal and your average K-Stroud. You can download this one again, John Bird. Yeah, John Bird, higher engineering maths. So I think preferably the 5th edition. So now these are all the textbooks you can use. So this time around, I want you guys to give me the question, but I think I can still create prototypes in my head. Are we ready? Yes, sir. Okay, good. So probably if anyone has any of these questions, if you have HK DAS or you have K-Stroud or you have John Bird higher education, let me just, you have them, can we signify? You have any of these 3? Okay, good. So I think we can start picking questions from there. And also to add to it, buttress to the point, these textbooks are actually very, very important for you because at the end of the day, you can go home and go and practice questions. I remember when I was doing this course, I gave myself a task, and the task was that before I write exams, I want to solve 100 differential equations. 100. At the end of the day, I think I ended up solving more than 100. I didn't count, but I solved as many differential equations as I can solve. and it helped me in my exam because everything does look like revision. I didn't say it looks like play. It looks like revision. Do you understand what I'm trying to say? Okay, good. So now number 1, direct integration. So from direct integration, now question is, how do we recognize that we have to use direct integration? That is question number 1. How do we recognize it? Because if you don't recognize it, then you don't know what you are supposed to do to it, yes or no. And also I might advise, okay, I think majority of us that are doing 205 are also doing 201. Okay, that means after this class we'll do 201 and we'll continue again. I've been now. I'm here for you as long as you are here for me. Oh. Alright, so now this time around, because I want to say something, because in this case you will need more knowledge on integration. Integration will be your backbone. You will need a lot of knowledge on it. So I can help you, push you through, but at least at the end of the day, it shouldn't be I can't help you to the exam now, obviously, right? I've been now. Aha. So let's do it together. So direct integration. So direct integration questions are always written in this format. dy dx equals to f of x. This is the format. So now what does that dy dx equals to f of x means? It means that whatever differentiation question that you're asked to differentiate, everything will be in terms of one variable. Let's look at this. For example, I want to differentiate number 1, dy dx equals to 6x squared minus 5x is power 4. Now, the fastest and simplest way to solve this method, you find out that apart from dy dx, everything that I have here is what? A function of what? A function of x. I get what I'm trying to say like that. Now, the fastest way to do this is like, first of all, do what? Cross multiply, or multiply by what? By dx. Then what do I have here? dy is equals to what? 6x squared minus 5x to the power of 4 dx. Yes or no? And at the end of the day, what do? I integrate both sides. So by integrate sides, then here you can have integration of dy equals to integration of what? 6x squared minus 5x to the power of 4 dx. So if I integrate dy, I think I will end up having what? Y equals to. So if I integrate 6x squared, I think I will have 6x cubed divided by 3, right? Then minus what? 5x 5 divided by what? 5. Then plus what? Arbitrary constant of what? Of c. Are we together? Then so from here, what will I have? I will have what? Y equals to what? 2x cubed minus x to the power 5 plus what? Plus c. That's the final answer. So if you solve a differential equation, you end up getting a curve most of the time. I get what I'm trying to say like that. Do we get? Yeah. Okay, let's look at another example. So start ready to give me question 2. Now look at another example. Let's say that time around you have 3x dy dx equals to 2 minus 8x squared. Yeah. Let's look at this. Now, unlike the other ones that we have here, which clearly stated that this time around, what I had here was just to, multiply, collect like times together, and you can continue. And from here, so what do I have here? So first of all, it's what? Divide through by what? By 3x. So dividing through by 3x here, what will I have? I'll have dy dx equals to what? 2 over 3x minus what? 8x squared divided by what? 3x. Are we together? Then from here, then I can have dy dx equals to what? 2 over 3 multiplied by 1 over x. Are we together? Then minus 8x over what? Over 3. Are we together, please? Okay, good. Then from here, so I can multiply through by what? By dx. So I can say that my dy is equals to what? 2 over 3, 1 over x minus what? 8 over 3 x. Yes or no? Everything multiplied by what? dx. Are we together? Are we together, please? Then so from here, if you integrate both sides, by integrating both sides here, what will I have? So by integrating both sides here, I think I will end up having integral of what? Dy equals to, what will I have here? I mean, it should be integral of 2 over 3 multiplied by 1 over x, right? Minus 8 over 3 x and everything dx. Yes or no? Yes or no, please? Are we together? Okay, then so from here, if you integrate dy, what do I have? I have y equals to 3 integral of 1 over x dx. Yes or no? Then from here, minus, let me have it as 8 over 3 integral of what? Of x dx. Are we together? Then so from here, you can have what? Y equals to 2 over 3. So if I integrate 1 over x, what will I end up having? What will I end up having? Ln x minus 8 over 3. If I integrate x, I have what? X squared over what? Over 2. Plus what? C. So I can have y here is equals to what? 2 over 3 ln x minus what? 4 over 3 x squared plus what? Plus c. Do you understand, please? So I have solved this equation. Are you ready? Are we together? Okay, good. So another equation. I think we agreed that we solve 7 differential equations per method, then we move. So 7 times 6 should give us what? 42. I think if you can handle 42 questions, then I think you are half an hour. You are good to go. Then from here, what will happen? So for me, I can now have number 3. Okay. And let me have number 3 to be a little bit different. Let's have number 3 to be a little bit different. Okay. Let's have it as 3 sine theta dt, okay, dt, yes, dt d theta equals to 2 plus 3 cos theta. Okay. Now this time around, I can now have it at t of 0 equals to 1. So let's look at this differential equation question. And this time around, this one looks a little bit different from everything that I've been doing, in the sense that after everything here, what do I have here? After everything, what do I have here? I have a condition. Yes or no? I have a condition. And whenever you have a differential equation that has a condition, that differential equation goes by the name IVP. Are we together, please? Are we together, please? Let me repeat again. Whenever you have a differential equation that states a condition like this, the name of that differential equation is what? An IVP. And IVP is what? Initial value problem. Are we together? Okay, let's work with that. So from here, so don't forget, so what I have to do here, as usual, separate them. So let's separate. So I can have here to be 3 sine theta, or despite this, let's do like this, dt d theta equals to what? 2 over 3 sine theta, right? Then plus what? 3 cos theta over what? 3 sine what? Theta. Are we together? Divide both sides by what? 3 sine theta. Okay, good. Then from here, so I can have dt d theta here to give me 2 over 3 multiplied by 1 over what? Sine theta. Are we together? Plus, what do I have here? Cos theta over what? Sine theta. Yes or no? So now, to rewrite this one now in this term, I can call this one here to be dt d theta equals to 2 over 3. Then according to trigonometry, so in trigonometry, 1 over sine is what? 1 over sine is what? Sec. Have this to be what? Sec theta. Or is it sec? No. It's cosec. Cosec theta. Are we together? Are we together? Then the next one is plus. If I integrate this one, what do I have here? Tan theta. Is it tan? Cot theta. Are we together? So now let's now start by integrating. So now here I can now multiply 2. I can say that dt is equals to 2 over 3 cosec theta plus what? Cot theta, then multiplied by what? D theta. Yes or no? Okay, good. Then from here, then I can now have integrate both sides. Integrate both sides. So by integrating both sides here, I will end up having integration of what? Dt equals to what? Integration of what? 2 over 3 cosec theta plus what? Cot theta. Theta. Are we together? Okay, now, before I continue here, now, obviously now, what will be the integration of cosec theta and cot theta? Okay, so to make my work look more easier so that I can carry everyone along, I will play with the questions again. Okay, let's work with the questions. So personally here, so let me say I made this one here. Let's say I made this one here cos theta. Then if I continue, what will I have had here? I'll have cos theta here. Then this one here will have been what? Cos theta. Then this one here too will have been what? Cos theta. Then I think let's change all the variables from that side. I have to change because of integration of cosec theta. Then so from here I can now have dt d theta, which will now give me 2 over 3 sec. I mean now sec. You can have integration of what? Dt equals to what? Integration of what? 2 over 3 sec theta plus what? Plus 1 d theta. So if I integrate this one, I have t and 2 over 3. By experience, if we integrate sec theta, we have ln of sec theta minus tan theta. Are we together, please? Are we together? Okay, good. So I have this. So now initially I was supposed to stop here, the normal norms. I mean now, I was supposed to stop here, but you find out that in this place here, I have a condition, which is what? T of 0 is equals to what? 1. So that means, what this one means is that it means t is equals to 1 when theta is equals to what? 0. Are we together? Okay, so let's now substitute that in. So what might t be here? My t here will be what? 1 equals to what? 2 over 3 ln of sec 0 minus what? Tan 0. Are we together? Plus what? Plus 0 plus what? Plus c. Are we together? Then I think here I can now have 1 equals to what? 2 over 3 ln sec 0. Do you know that sec 0 is the same thing as 1? Do you know why? The reason is because sec is equals to what? 1 over what? Cos 2 over 3 ln of 1 plus what? Plus c. Are we together? Then from here I can now say that 1 is equals to what? 2 over 3, and ln of 1 is what? 0 plus c. So at the end of the day, you can have what? C is equals to what? 1. And if c is equals to 1, I can now say that my general solution, t, will now give me what? 2 over 3 ln of what? Sec theta minus tan theta. Are we together? Plus theta plus what? Plus 1. That will be my solution. Please, do you understand? Are we sure? Okay, can write that. Then, alright, so that's question number 3. Okay, do you have anyone with questions from the house? So anyone, feel free. Ma? Okay, we have a 4 exponential what? Minus x. Then cross multiplying, I have dy equals to what? 4 exponential minus x dx. Then if I integrate both sides, then by integrating both sides, what do I have? I have integration of what? Dy equals to what? Integration of what? 4 exponential minus x dx. So by experience, if I integrate dy, what will I have? Y equals to 4. If I integrate exponential minus x, what will I have? Minus exponential minus x. Are we together? Plus what? Plus c. Then at the end of the day, you have what? Y equals to what? Minus 4 exponential what? Minus x plus c. Then to make your answer look a little bit more, mathematical, so you can write this as what? Y is equals to what? 4, sorry, not to y equals to now. Y plus 4 exponential minus x together. Are we together? Are we together? Now we are talking. Now number 5. Anyone else? Question from the house? Okay, yeah, 1 over exponential x plus 2 equals to x minus 3 dy dx. Okay, I have it like this. Okay. Y equals to 1 and what? X equals to 0. So what type of problem is this question here? What type of question is this one here? What type of question is this one here? Initial value problem or what? Your IVP. Are we together? So from here, so let's find a way. Now this one looks a little bit disturbing. Yes or no? So now let's undisturb the disturbance. So now let me make everything. Let me swap sides. I hope you know that here I can have 3 dy dx. Bringing this one here and carrying this to the other side, I can have this one to be what? X minus 1 over exponential x. Are we together? Minus what? 2. Right? Then I can have 3 dy dx equals to what? X minus what? Exponential minus x minus what? 2. Are we together? So please, I think it is very, very important for you to master how to unravel. Sometimes you have to find a way to split your what? Your dy dx. So from here, you cannot have divide both sides by 3. So you have dy dx is equals to what? X over 3 minus what? Exponential minus x over 3 minus what? 2 over what? 2 over 3. Then from here, what do I do next? I think the next thing that I do here is what? Multiply both sides by what? Dx. Then by multiplying by dx, I have what? Dy equals to what? What do I have here? X over 3 minus what? Exponential minus x over 3 minus what? 2 over 3. Everything here is what? Dx. I will take that. Then from here, I can what? Integrate. I can integrate both sides. So by integrating both sides here, so what will I have if I integrate both sides? So by integrating both sides here, what will I have? So I'll have integral of what? Dy equals to integral of what? What would this be? X over 3 minus exponential minus x over 3 minus 2 over 3. Everything here is what? Dx. Yes or no? Then so from here, what do I have? I cannot have y equals to, what do I have here? Integration of what? 1 over 3x. Are we together? Then dx minus integration of 1 over 3 exponential minus x dx. Then what do I have here? Minus integration of what? 2 over 3 dx. Then from here, I can have y is equals to what? 1 over 3 integration of what? X dx minus 1, minus 1 over 3 exponential of minus x dx. Are we together? Minus integration of what? 2 over 3 dx. Then from here, I can have y equals to 1 over 3. If I integrate x here, what am I supposed to have here? I have x squared divided by 2 minus what will I have here? 1 over 3. If I integrate exponential minus x, what do I have? minus exponential minus x, are we together? Then minus 2 over 3x plus what? C. Then if I have all of this, what do I have? I can have y equals to x squared over 6 minus, plus exponential minus x over 3 minus 2 over 3x plus what? Plus c. So I have gotten the answer to my question, but not true yet, because at this point here, I still have a point which says that I must, after I've gotten this answer here, I must substitute this value here inside this question. Are we together? Now this question now tells me that I am supposed to put this one here, y equals to 1 when x is equals to what? 0. So what do I have here? I'll have 1 equals to what? 0 divided by 6 plus exponential minus 0 over 3 minus 2 over 3 multiplied by 0 plus what? C. And here what will I have? I'll have 1 equals to exponential 0. This one will give me 0. But I have to know that exponential minus 0 is same as exponential 0. And anything raised by 0 is what? 1. This one will give me what? 1 over 3 minus 0 plus C. Right? Are we together, please? Then from here, continuing, I would have, so if I continue here, all I have, I think I will have 1 minus 1 over 3 equals to C. Yes or no? Yes. So taking down to the other side, and I know that 1 minus 1 over 3 will give me what? 2 over 3 equals to what? C. So I've gotten my C. So I can now confidently substitute back where? Inside my general equation. So my final answer here will give me y equals to what? X squared divided by 6 plus exponential minus x divided by 3 minus 2 over 3x, I will take that, plus what? 2 over 3. Then to make my work look a little bit more, what I call it professional now, multiply everything by what? By 6. So what do I have here? I have 6y equals to what? X squared plus what? 2 exponential minus x minus 4x plus what? Plus 4. That will give us what? My final answer for this part. 2 questions to go. Okay. Okay, I have 1 over x squared plus 4 or plus 4. Okay, everything x squared plus 4. Okay, minus 2 x squared dy dx equals to what? 0. Is it x squared or x? Let's make it x. Equals to 0. Are we together? Are we together? Okay, good. So from here, take this one to the other side. Are we together? Then what do I have? I have 1 over what? X squared plus 4 equals to what? 2x dy dx. Right? Then what do I do? So I can cross multiply. Right? Now cross multiplying in the first round, what will I have? I think I will have dx divided by what? I mean, x squared plus 4 equals to what? 2x dy. Are we together now? By the first time, I just multiplying through. Then second time again, what do I have to do? I'll divide both sides by what? By x squared. Are we together? Okay, to make the work look a little bit more easier. Sorry? 1 over 2x. And let's make this 1 over what? 2x. Then making that 1 over 2x here, I think I'll have this on to both. 1 over what? 2x. Then what do I have to do here? I just multiply both sides by what? By 2x. Multiplying both sides by 2x, I have what? 2x dx over what? X squared plus 4 equals to what? Dy. Yes or no? Then what can I do here? I can integrate what? Both sides. Then by integrating both sides, what do I have? I have integral of dy equals to integral of what? 2x over what? X squared plus 4 dx. Are we together? Then from here, if I integrate dy, what will I have? I'll have y equals to. Now, there is a trick in differentiation that says that if you can differentiate your denominator and you have your numerator, the answer will be ln of your what? Denominator, right? So let's look at this. So if I differentiate x squared plus 4, I think I will end up having 2x. So then the answer to this one can I give me what? ln of what? X squared 4, then the arbitrary constant what? C. Do we get? Are we sure? Huh? Okay, don't get. If I differentiate x squared here, if I differentiate everything here, I will have what is on top here. And there's a law that says that if I differentiate everything here, and I have this, the answer will be ln of what is down here. So that's why I have ln of this one as my final answer. Do you understand? Are we sure? Okay, good. Now the last question on this section before we move. I welcome questions from the house. A minute, please. So, okay, good. The next one. Alright? Okay. A current. Okay, let's have something different. Okay, a current, yes. A current high. Sir? Okay, in an electric circuit with, okay, containing resistance R, okay, and inductance L in series, okay, with a constant voltage source E is given by the differential, or let me just make it short, by the d E minus L di over dt equals to Ri. Okay, sir? Okay, full stop. So we have to solve the equation. And what is this now? Find I in terms of E, L, and R, right? That's all. Wait, okay, given that t equals to 0 and I equals to 0. Okay, so looking at this equation now, look at it because of the word problem that is there. It looks big. Actually very simple. Now this time around, so let's look at it. So solution, let's write the differential equation out first. Solution. So what is the differential equation here? So I have E minus L open bracket di dt equals to what? Ri. Now in this case here, everything else apart from I here is a what? The constant. That's one thing I wanted to know. Everything apart from I is a what? The constant. Are we together? So from that, what will I now have? Let me make it look a little bit more interesting. Let me bring this one to the other side and take this one to the other side here. So I can have E minus Ri equals to what? L open bracket di dt. Are we together? Then to make my di dt standing, what do I have to do? Divide both sides by what? By L. So dividing both sides by L, I have what? E minus Ri divided by what? L equals to what? Di dt. Are we together? Then from here, so do you know that this one here can be split into two? So this one here can give me E over L minus what? Ri over what? L equals to what? Di dt. Are we together? Then okay, let's change the question and multiply everything by what? by dt. Okay, then multiplying everything here by dt, so I can have dt open bracket. What would this give me? E over L minus what? R over L I equals to what? Di, right? Okay. So from here, let me change. Let me swap the sides. So I can now have di is equals to what? Dt open bracket E over L plus what? Sorry, minus R over L I. So now, so this one here, so if I integrate both sides, so by integrating both sides, so what do I have here? I have integral of what? Di equals to integral of E over L minus R over Li in terms of what? In terms of t. So now looking at it now, you find out that there's nothing here that has t in it. And whenever, sorry, this not be t, it should be dt. And from what I have here, it means that I am directly integrating both of this side here with respect to what? To t. And everything here is a what? Is a constant. We just not have t. So at the end of the day, I can have that my I here in this time is going to give me what? E over Lt minus what? Ri over L what? T plus what? Plus c. Are we together? So I've gotten this one. So from here, what I asked to do, given that t is equals to 0 and I equals to 0, so I can have 0 is equals to what? E over L multiplied by 0, are we together? Minus Ri over L multiplied by 0 plus what? C. Then at the end of the day, I can come up with the answer that C is equals to what? 0 on this part. Abi now? And also I equals to 0, obviously. So now, so from here, coming up with that, so I can say that from here, I can say that the final answer I will have here will give me I equals to E over L open bracket T, sorry, yes, Abi, minus Ri over what? L open bracket T plus what? 0. Then by the time I factorize T here, I can have I is equals to T open bracket E minus Ri over what? L. Yes or no? So I think this should be the final answer. Right? Okay. Yeah, this is it. I have found. Okay, thank you for that. Yeah, thank you for that. So let's make I. So from here I can have, okay, let me say I have IL multiplying both sides by L, IL plus TE minus what? RIT. Yes or no? Okay, bringing this one to the other side, so I can have IL plus what? RIT equals to what? TE. Then from here, what's common here? I. Then what do I have here? L plus RT equals to what? TE. Then your I here will give me what? TE divided by what? L plus what? RT. So I finally gotten the answer written in terms of what? I and T. So I think I love the end of this question here, which is actually very, very interesting. So let me just introduce part 2 here, which is, what is that? Separation of what? Of variables. So let's introduce part 2. So introducing part 2, which is what? Separation of variable. Might not do a lot of examples on it. Separation of variables. Now, from separation of variables this time around, so in separation of variables, now the questions are most of the time written in this format. dy dx is equals to f of y multiplied by what? F of x. Now, this one means that the equation is written in such a way that it is easy for you to remove x from what? From y. Do you understand? The equation will be written in such a way that x and y can confidently stand what? Side by side without any problem to each other. Do you understand? Do you understand? Okay, what I mean is that the equation will be written in such a way that you will be able to separate y from what? From x. Okay, now let's look at this question. Now, let's say I want to solve this one here, which is what? Dy dx is equals to x over y. Let's look at this question, and I want to solve it. So for me to solve this question now, what do I have to do? So, first of all, make sure that all x are written on one side, and what? All y are written on what? On the other side. So what can I do here? It's easy for me to just what? Cross multiply. So by cross multiplying here, I can have what? Y dy equals to what? X dx. Then for me, what can I now do to both sides? I can do what? Integrate. So integrate both sides. Then by integrating both sides here, I think I will end up having integral y dy equals to integral x dx. Are we together? Then so from here, if I integrate y with respect to y, what do I have? I'll have y squared divided by 2 equals to what? X squared divided by 2. Now, a question. Since I integrated both of them indefinitely, I am supposed to add c to it now. But the question is, whenever I have differential equations like this, it is most advisable to add your c to your x. It is most advisable. There are some situations that you see some textbook that they will add their c to their y. And I want to let you know that adding c to either x or y can affect your answer by a lot. So to be on a safer side, listen that whenever you are integrating both sides, you are putting your c on the what? On the side of the c. Do you understand? Are we sure? Okay, good. Then from here, so let's now briefly take let's run back in time to where we started from. So we look at it as revision. So let's open to the first page from where we started. And I remember that we started from the definition of what? Differential equation. Yes or no? So we define differential equation as any equation that has two or more dependent variable, two or more independent variable, and two or more what? Derivative. Yes or no? And also we moved on to, we talked about the fact that we explained the types of differential equations that we have, which is what? We have the ordinary differential equations and the what? Partial differential equations. And I told you that because of, I don't want to run ahead of my time, I don't want to run ahead of my shadow, that we will still deal with what? Partial differential equations some other time. Are we together? Okay, so after that, we now moved on to explain characteristics of what? Differential equations, not ordinary differential equations. So we said that the first characteristic is what? Order. And we mentioned the fact that order is the what? Highest derivative in your what? Differential equations, where we gave examples and we were able to find their order. Yes or no? Now the second characteristic is what? Is degree. And we said that degree is either the power of the order or what? Power of the highest derivative. Are we together, please? Now the next one we talked about was what? We talked about linearity. So linearity is this, it's talking about whether the question is what? Linear, whether the question is what? Non-linear. Are we together, please? Now the next one we talked about was what? We talked about homogeneity. That is whether the question was what? Homogeneous, whether the question was not what? Homogeneous. I'll give an appliance like that. And I remember we gave some criteria. So when it is linear and non-linear, and also when it is what? Homogeneous and what? Non-homogeneous. Do you understand what I'm trying to say like that? Then after that, the next one we move on to describing was, we move on and we described we described forming differential equations. The forming differential equations, we moved on to what? Verifying equations, and at the end of the day we ended up with what? Solution of what? Curve. We talked about formula of curves too. So we've tried for today. Thank you very much. While we move on to the next class. Alright, so we're having MTS1 right now. So, good evening to us once again. For those of us that are interested in MTS 201, so alright, okay, so let's start. MTS 201. So now looking at the point of view, we have different branches of MTS 201. So MTS 201. So in MTS 201 we have different subcategories of it. So the first thing is that we're dealing with is that we'll first talk about functions of real value variables, then functions of real value variables. We'll continue and we'll talk about review to differentiation and integration. Then from review of differentiation and integration, we move on straight and we'll talk about your partial differential equations and linear approximation, linearizations and all of that. Okay, let's do like this. Let's list out the course outline for MTS 201. We arrange it in the order of learning and we move. Is that okay? Okay, let's start. So now, this is everything you'll be dealing with this semester. You'll be starting with real valued function of what? Of variables. Are we together? Now the next thing we'll be talking about now, we'll be talking about what? Talking about review. Yes. Review of what? Differentiation and integration. Then the next one we'll be looking at partial derivatives. Then the next one we'll be looking at linearization and linear approximation. Then the next thing we'll be looking at line integrals. Then from line integrals we examine multiple integrals. Then from multiple integrals, then the next one that we'll have will be general theorems. General theorems. So, okay. Alright, so as far as MTS 201 is concerned, this will be everything we'll be dealing with in MTS 201. It's everything we'll be dealing with. So we start with real valued function, but this time around, this class will not be in order of how it is written, but I will teach it in order of how it should come out in your exam. I get my pencil like that. So I'm not teaching it in order of how it is written. I'll teach it in order of how it should come out in your exam. So let's give a numbering to it. So this is how it will happen. So we have 1, we have 2, we have 3, 4, 5, 6, and this will be the last. Are we together? Are we together? Now let's briefly talk about, let's do this review. Let's run back in time to MTS 102 and let's look at what happens to our differentiation and our integration, and whether we like it or not. The backbone of this course is differentiation. Are we together? For those of us that are doing 2.5 that are seated here, the backbone of 2.5 is what? Integration. But the backbone of this one is what? Is integration. Are we together, please? So now let's now start. Are we ready? Okay, good. Let's start. Review of differentiation. Review of differentiation and integration. So let's just run back in time and let's recollect. Review of differentiation and what? And integration. Are we ready? Can we start? Okay, good. So let's start. Now, differentiation first. Now, differentiation. So we have a lot of techniques in differentiation. But before I talk about the techniques, let's quickly know how to differentiate some terms. All together. Now let's write out this table so that just as serve as a source of
remainder. Last, it will serve as a source of remainder here. I will have, you can write this to be y, and this other part I want to write here should be y prime. So let's join it together. So first thing first, if I differentiate exponential x, what will I have? Exponential x. If I differentiate sine x, I will have what? Cos x. Are we together? If I differentiate cos x, I will have what? Minus sine x. Then if I differentiate tan x, then I will have what? Sec squared x. Then if I differentiate cosec x, what will I have here? Minus cot x cosec x. Then if I differentiate sec x, then I'll have this to be sec x tan x. Then if I differentiate cot x, then by cot x I have minus cosec squared x. And from minus cosec squared x, if I differentiate sine inverse of x, I will have 1 divided by square root of 1 minus x squared. Cos inverse of x will give me minus 1 divided by square root of 1 minus what? X squared. And if I have tan inverse of x, at the end of the day, in tan inverse of x, I'll be having what? 1 over square root of x squared plus what? Plus 1. Okay, let's continue the list here. And this is still y, and this is still what? Y prime. Then let's say you want to differentiate sin x. You are meant to have cos x, and if you differentiate cos x, you are meant to have what? Sin x. Then by sin x, if you differentiate next one, which is a to the power of x, you are supposed to have a to the power of x ln a, and as many more as we can have. Okay, yeah, let me add this to the list. If you differentiate ln x, your answer will be 1 over what? 1 over x. Okay, if I also differentiate, okay, let's do that. Let's do that. So as far as we are concerned, this will be all, not all basically, but this will be everything we have on the tables. So all these tables that we have here are very, very what? Important tables. Very important, because we have to be a master of all these tables before we can continue. Are we together, please? Okay, good. So can we start now? Now we'll start taking the differentiations by what? Technique by what? By technique. Then after doing technique by technique, the next thing we'll do is what? We'll now have a cocktail. That is, we'll combine all the techniques together and we'll continue. Right? So let's start. So now, first technique I want to use is sum and difference rule. So sum and difference rule. So in sum and difference rule, where we'll start. So now sum and difference rule is stating that this is the law. So if you have y, which is a general function, and this y is equal to as many individual functions of x as you can have, adding or subtracting each other, I'll get one I'm trying to say like that. So now I have a general function of what? I have a general function of what? Y. Are we together? Which is a combination of individual function of x. Now if I want to differentiate them, then I can say that the y dx is the same thing as saying the u dx plus or minus the v dx. Are we together? Plus or minus what? The w what? Dx plus or minus as many other variables as you can have. But the best way for you to understand what you are doing is that just make sure that your sum and difference rule is working on the fact that everything you have here is an individual function of what? Of x. Are we together? So let's take examples. So let's say that you have number 1, y is equals to 2x squared minus 7 plus 8 tan x. Okay, let's have something like this. So let's pick it up gradually, step by step. So now, according to what this function says, according to the according to the rule I have on the board, the rule I have on the board says that whenever I have individual function of x, what do? I differentiate each of them what? Separately. I'll get one approach like that. So let's differentiate. So if I differentiate x squared separately, what do I have? 4x. Let's give response now. Now if I differentiate 7 separately, what do I have? 0. Now the other one, if I differentiate 8 tan x separately, what do I end up having? I have 8 sec squared what? Sec squared x. And also I must not tell you by now that you must be a master of what? Factorization.
So now, factorizing this answer, what will be common here? Can have y prime is equals to what? 4 open bracket x plus what? 2 sec squared what? Sec squared x. Are we together? Okay, this is the first part. Now, the second part we have to look at, which is number 2. Let's say that I have y equals to cos x minus 8 ln x plus sine inverse of x plus 20 raised to power x minus, let me get one more, minus cot x. Now, as I've said, what do you find out? What do you notice? You notice that here I have how many individual function of x that I have? I have cos x is an individual function of x, 8 ln x an individual function of x, and as many of them as I can have. Yes or no? So now let's continue. So if I will differentiate this, so y prime here, if I differentiate cos x, what do I have here? Minus sine x. Are we together? Minus, I have 8. Now if I differentiate ln x here, what will I have if I differentiate ln x? According to the table, 1 over what? X. Plus, if I differentiate sine inverse of x here, sine inverse of x should be giving me what? 1 divided by square root of what? 1 minus what? X squared. Plus here. Now, once you differentiate 20 raised to power x, now if you can find out, you find out that 20 raised to power x is the same thing as saying you want to differentiate a raised to power x, where a is any constant. So what will I have by differentiating 20 raised to power x? I think I will have 20 raised to power x ln 20. Then minus, now if I differentiate cot of x, so what's cot x here? I have minus cos x squared what? X. Then from here, if you open the bracket and rearrange in the order of letting plus come first and minus ends at the last. So what can I have here? Letting plus come first, I can have y prime. Let me start with this. Should give me 20 raised to power x ln of 20 plus this, which is 1 over square root of what? 1 minus what? X squared. Then the next one here plus what? Cosec squared x. Are we together? Then plus the next one here minus sine x. Then finally minus 8 over what? Minus 8 over x. Are we together? What I just did was differentiate everything one by one. Cos x is minus sine x, 8 ln x, 8 separate. If you differentiate ln x, you have 1 over x. Sine inverse of x, you have that answer. Okay, let me draw it like this so that this will not confuse. Okay, I think it's better like that. So 20 raised to power x, which is the same thing as you want to differentiate this answer here, and your cot x, which is the differentiation of what? This answer. Do you understand? Okay, good. So from here, I've differentiated it. So that is the what? The first rule of differentiation, which means that if you have individual function of x, the answer you will get will be what? The derivative of each of those functions. Are we together? Okay, good. So let's look at the next rule. Now the next rule is product rule. Now product rule is what happens if you have a general function of x, which is the combination of as many functions of x as we can have, multiplying what? Each other. Are we together? Are we together? So that is how you can recognize product rule. How do you recognize sum and difference rule? You find out that all the x are what? Are single. I get what I'm trying to say like that. But once you start entering product rule, the x leave single, start becoming probably double or triple or don't say fourple, quadruple. Are we together? Just let's start. So now, and the law states that whenever you have something like this, you have y prime, which is the same thing as u dv dx plus what? V du dx. So what this one means is that whenever you have those two functions combined together, you write one function, you differentiate the other function, plus write the other function and differentiate the first function. You get that? Okay, good. So let's start with that. So let's give examples. So this time around, we will do product rule of 2, product rule of 3, product rule of 4, product rule of 5. Now teach product rule of 6. There's one question that always repeats itself. There's a product rule of 6. So we treat that question here. Don't be scared. So now let's start. Number 1. Let's say I want to differentiate. Let's look at this now. I want to differentiate probably x squared ln x. I want to differentiate this. Now first thing that you notice that both of them are what? They are x, but they are what? Separate functions. And the separate functions are written in such a way that they are what? they are joined together. Yes or no? Yes or no? Then so from here, so the first thing you have to do is what? Name this u, name this what? Name this v. And so let's have the differentiation. So y prime in this case, don't forget the law, which is what? U dv dx plus what? V du dx. Are we together? What's your u here? You have x squared. Now dv dx means you want to differentiate ln x. So if you differentiate ln x according to the table here, what will I have here? 1 over x, that's nice. Then plus my v is what? Ln x. If you differentiate x squared, what do I have here? 2x. Then so I can say that y prime here is equals to x in x squared should give me what? X plus what do I have here? 2x ln x. Are we together? Then I shouldn't be able to tell you that this one here you can factorize it. So by factorizing this one, so y prime here can give me what? 1 or x open bracket what? 1 plus what? 2 ln x. Yes or no? So this will be your answer. Are we together, please? Are we together, please? Okay, good. Now let's look at another example. Number 2. Let's make it a little bit more complex. Let's say you want to differentiate y is equals to 2 sine x, and you are also multiplying it with 2 sine x dot 5 to the power of x. Okay, let's look at this in this case. So I want to multiply 2 sine x and what? 5 to the power of x. This thing is not nil. This thing is dot. I'm writing it together. So first thing is what? Ascertain your u and ascertain your what? Your v. Then follow this law. Then you can have y prime is equals to, here you have 2 sine x. Then if you multiply 2 sine x, then what will be your next one? Differentiate 5 to the power of x. And 5 to the power of x will follow what? This format. Yes or no? So if you differentiate 5 to the power of x, what will I have? I'll have 5 to the power of x ln 5. Yes or no? Plus your v 5 to the power of x. If you differentiate 2 sine x, what do I have here? 2 cos x. Yes or no? So from here, open your bracket.
We have some now.
Alright, so now this time around, let's have something a little bit different. So let's say that you have 1 equals to x squared sine x tan x. Yeah, this is 3. Now you have x squared sine x tan x. Now how do you differentiate this? Now there are some methods that might say that you write your u, you write your v, write your w, you differentiate them separately, then it's the kind of formula that combines all of that. Okay, that one is actually very, very correct. I didn't dispute that fact. But another way we can look at it, that it will conserve more time, is to share whatever functions you have here into 2. I will get what I'm trying to say like that. So if you have a 3 function question, you can share it into 2 by saying you can have 2u and 1v, or you can have 1u and what? And 2v. Are we together? So what if I have 4? I think the best way to share 4 is what? We share them 2u and what? 2v. What if I have 5? I can either share them as what? 3u, 2v, or what? 2u and 2x. Then from here, I can now have y prime here should give me so open your bracket here. You can have x squared sine x sec squared x, right? Okay, this one's supposed not to be cos. This one's supposed to be sine x. Then plus what do I have here? I can have tan x. If you open the bracket here, what do I have? I have x squared cos x plus what? 2x sine x. Yes or no? Then from here, what do I have? Then I can write my y prime to give me something like this, which is x squared sine x sec squared x plus what? What do I have here? X squared tan x cos what? Cos x plus what? 2x sine x tan x. Do you understand? So from here you can just what? Open the brackets. Are we together? Then so after this, so what is common in everything here? I think the common thing here is what? Y prime is equal to what? X sine x. Yes or no? Abi now? So in x sine x, so if I remove x from x, what do I have? I have x sine x here will go to give me sec squared x plus x here will give me what? X. Okay, I don't have a sign here. Okay, then let's be more manipulative. Then let me come and remove this one here from this part here. Then what will I have? I will have what? 2 tan x. Yes or no? Then plus this side, which is what? X squared tan x cos x. Do we understand? Do we understand? Let's talk now. Good. Nice. And the thing that I initially thought this one had sin x. That's why I removed sin x here generally. But I found out that this one does not have sin x. So the only thing I did was I factorized x sin x from this one here and this one here. I get what I'm trying to say. Okay, good. Now this is one example of a 3 variable. Let's do another example of a 3 variable and let's see how that one will look like. Now this time around, let's say we have y equals okay, let's say you have 2 raised power x ln x sin x. No, I'm not doing sine this time around. Let me work with exponential x. Good. So let's deal with this. So we want to differentiate 2 raised power of x ln x exponential x. Are we together? So the other time, what did I do? The other time I did 2u and 1v, and I did the first one. I did 2u and 1v. The second one I want to do this time around. I want to do 1u and what? And 2v's. So let's start. So this one will be my u. This one will be my what? V. Are we together, please? Then so from here I can have that y prime should give me, so your product, which is what? 2 raised power x. Now v is 2. So the fact that v is 2 means that I have to split v into what? Into 2 again, which will give me what? This is u and this is v. So what is my u here? ln of x. Now if you differentiate exponential x, so what do I have? Exponential x. Then what do I have here? I have x. Now if I differentiate ln x, what do I have here? 1 over x. Are we together? Then I'm done with uv, and plus next one, which will give me ln x exponential x. So if I differentiate 2 raised power x here, what will I end up having? I will have what? 2 raised power x ln 2. Yes or no? So now from here, let's open the bracket. So opening the bracket here will give me 2 raised power x exponential x ln x. Are we together? Then plus 2 power exponential x over x. Yes or no? Yes or no? Then from here I can now have plus what? 2 raised power x ln x exponential x ln what? Ln 2. Are we together? Then from here, so if I have this, the next thing I can have here is what? Is to factorize. What is common in the three of them? What is common? What does this one have? That this one have? That this one have? You'll find out that that's what? 2 raised power x exponential x. The one will I have left? I will have what? Ln x plus what? 1 over x plus what? Plus ln 2, right? I be now? No. I think I have ln x ln what? Ln 2. And please, the fact that you have ln x ln 2 does not mean that you can combine both of them together to give you what? Ln 2x. No. So leave the answer like this, or better still, to make it more mathematically tangible. So you can, since this one have power of x, so you can write it as 2e all raised power what? X will give you what? Ln x plus what? 1 over x plus what? Ln x ln 2. Are we together? So that will be my answer when I have it double. A triple. So let's do one more. That's triple. Then we'll move on to what? To 4. We'll do one example on 4. We'll do another example on 5. Then one more example on 6. Then we move. I hope you're not tired. You can't be tired now. Abba, we're just starting. Alright, now the second one, the third one. Okay. So now let's look at this time. Okay, let's look at it in this way. What if you have y equals to you have it as sine x? I think I've been using sine too much, Abby. I don't want to use sine again. Give me another thing to use. Okay, sine inverse of x, a little bit different. Then you're multiplying it with tan x. Wow. At the same time, you are multiplying it with sin x. Yeah, star sin x is the sine of an hyperbolic function, which is still the same thing as exponential x minus exponential minus x over 2. You don't have to know the answer. It's a long story. Let's continue our work. So now, how should we do this one? Should we do 2u and 1v, or 1u and 2v? Which one? Okay, let's work with 2u and 1v. So this is u and this is what? V. Are you ready to write? Let's start. So for me, I can say that y prime here should give me, so let's write my u dv, which is what? Sine inverse of x tan x. Are we together? Then if I differentiate sin x, what do I have? I have cos x. Are we together? Then plus the next one, which is what? Sin x. Now if I differentiate this one here, I can end up writing this one to be my what? U, and everything to be my what? My v. Yes or no? Then from here I can now have, so if I write my sine inverse of x, So if I differentiate tan x, what do I have here? Sec squared x plus, if I write tan x, then if I differentiate sine inverse of x, what do I have here? 1 over square root of 1 minus what? X squared. So from here, let's now open the bracket, so I can have y prime equals to sine inverse of x tan x cos what? Cos x. I wrote together. Then plus, from here we have sin x sine inverse of x sec squared x. Yes or no? Are we getting it, please? Then plus sin x tan x divided by what? Square root of what? 1 minus what? X squared. So do we have anything common here? It appears yes, but I have to be manipulative enough carrying one to the other side. So let me leave the answer like this, in this form. Let me leave it like this. You understand? Are we sure? Okay, now the next one. Now let's now move on to, we have done 3, so let's move on to 4. I'm still on product rule. So let's move on to 4. Now in the fourth one, let's come up with this idea. Let's say that now you have y equals to 2 raised to power x exponential x ln x sin x. Now this is beautiful. Now we have a 4 function, and I think the only way we can deal with a 4 function is by sharing it into what? 2 equal halves. Yes or no? Okay, so from here we have u and everything, in here we have what? V. So what will y prime here give me? So y prime here will give me what? So I have 2 raised to power x exponential x, right? Now to differentiate v, you find out that v is made up of how many? 2. That means that 2, I can split them to what? U, and this one will be what? Will be my v. Are we together? So now let's write. So my u here will be what? Ln x. So if I differentiate sin x, what do I have here? Cos x. Are we together? Plus what do I have here? Sin x. If I differentiate the next, what do I have here? 1 over x. Then I think I'm done with the first part. Then moving on to the second part, which will give me what? Plus, right, this, which is what? Ln x sin x. Now I'm differentiating this 2 raised to power x exponential x. So what would that give me? 2 raised to power x will be my u. If I differentiate exponential x, what do I have here? Exponential x. Plus the next one is what? Exponential x. If I differentiate 2 raised to power x, what do I have? 2 raised to power x ln 2. Are we together, please? Do we get it? So now let's open the bracket all through. So your y prime here should give you 2 raised to power x exponential x open bracket ln x cos x plus what? Sin x over x, right? Then plus what do I have here? Ln x sin x open bracket, what do I have here? 2 exponential x plus what? So 2 raised to power x here. So I have 2 raised to power x exponential x ln what? Ln 2. Yes or no? Then from here, if you open your bracket still, so you can now have, what is this now? Y here, y prime should now give me 2 raised to power x exponential x ln x cos x plus what? 2 raised to power x exponential x sin x over x plus what? 2 raised to power x exponential x ln x sin x, then plus what? 2 raised to power x exponential x ln 2 ln x sin x. Now it looks very, very long, Abi, now, but it's actually simple once you can get the hang of it. Are we together, please? Do you understand to that extent, please? Huh? Alright, good. So now from here, what is common in everything? I think the only thing that is common that I can see here is what? 2 raised to power x exponential x, right? Right? Okay, good. So from there I can have y prime equals to what? 2 raised to power x exponential x. This should give me what? Ln x cos x, right? Plus what? Sin x over x plus what? Ln x sin x, right? Plus what? Ln 2 ln x sin x, right? Okay, I think that's that about that. So I can call this one here my what? My final answer. Do you understand? Why am I bringing out this one here? Why can't I bring out ln x? Yes, ln x is not present here. You get? That's why I can't bring out ln x. Ln x is present. If I even want to compute it in another method, should I do it that way? Yes. Let me do it that way. So from here I can also have this to be 2 raised to the power x exponential x. Now open this brick bracket. You can now have sine x over x. I will take it down. Plus what is common in this place, and this place? Ln x. Then if I remove ln x, what would I have here? I have cos x plus what? Sin x plus what? Ln 2 sin x. Are we together? Then from here again, I can choose to remove what? Sin x, but it's not me and you that will do that one. Just joking, literally. But do you understand, please? Do you understand? Okay. So let's do another example. Let's do another example. Let's do another example. So the other example I want to do now, y is equals to, let's say you have now x squared exponential x ln x tan x. Okay, are you ready? Okay, so from here I can call everything here to be u, everything here is what? My v. Are we together? Okay, so from here I can say that my y prime will give me u first, which is x squared exponential x. So if I differentiate this, don't forget this one has how many variables here? 2 variables, u and v. So this is to give me ln of x open bracket. What would I have here? If I differentiate tan x, I have what? Sec squared x plus, write this one, tan x. If I differentiate ln x, what do I have here? 1 over x. Are we together? Then you can close the bracket. Then plus next one here should be this, which is what? Ln x tan x open bracket. What do I have here? I have x squared. I have this one to be exponential x plus the next one will be what? Exponential x, and this one is what? 2x. Are we together? Then from here I can now have y prime equals to what? X squared exponential x open bracket ln x sec squared x plus what? Tan x over x. Are we together? Plus what? Ln x tan x open bracket here will give me what? X squared exponential x plus what? Exponential x ln what? Sorry? Exponential x, or let me write it as 2x exponential x, better still. Do you understand, please? Then from here, write again, which is y prime to give you what? X squared exponential x ln x sec squared x. I will get that. Plus I hope you know that if x squared exponential x multiply this one, x and x squared can cancel out, which will give me what? X exponential x tan x plus this one is what? X squared exponential x tan x plus what? 2x exponential x ln x tan x. Please, are we following? Are we sure? Okay, good. Then from here, y prime. So if I will factorize, so I can say that everything has x and everything has what? Exponential x, right? Then if I remove x exponential x, what do I have? I have x ln x sec squared x plus, what do I have here? Tan x. I will take it down. Plus what? X ln x tan x plus what? 2 ln x tan x. So this will have been my what? My final answer. Do you understand? Okay, good. So now this is 4. Let's do one example on 5. Let's do one example on 5. So let's do one example of 5. So this will be my my daddy's question. I want to solve my daddy's question. I don't know if you saw it in your exam, but I think I did. Y equals to 9x cubed exponential x ln x sine x 1 2 3 4 cos x. Yes, this is my daddy's question. Your father had paid for it. That is one of his question. Yeah. Yeah, it's CBT. I saw this question in my own too. Then, by God's grace. So now, let's start with this. Are we together? Let's start with this now. Don't be scared now. Let's start with it. So for me, now, it's either in your discretion to make it 3-2 or what? Or 2-3. You can also try to make it what? You can also try to make it what? 4-1. But it's not me that will do 4-1. So let's do what? 3-2. Are we together? So let's do 3-2. So doing 3-2 here, I can say that everything here is what? U. Everything here is what? Is V. Then starting, I can say that y prime is equals to what? 9x cube exponential x ln x. Are we together? Now let's differentiate sin x cos x. So how do I differentiate that? I can call everything here to be what? To be u, and everything here to be what? To be v. So I can say that I have sin x. If I differentiate cos x, what do I have here? Minus sin x. Then plus what do I have here? Cos x. Then if I differentiate this one, what do I have here? Cos x. Okay, good. Now I've differentiated the double. So that, let's now proceed further to differentiate the what? The triple. Okay. Okay. Now to differentiate the triple now, in this time around, how do I differentiate the triple? So it will be at your own discretion to now pick it 2-1 or 1-2. Yeah, you can use UVW too. You're actually correct. But the disadvantage between that formula is that, number one, it's long. Number two, since you're in exam hall, there's a tendency that you forget because you're under tension. Because if you know that, although this one might look a little bit long, but it gives you your answer faster than the other one. I get what I'm trying to say like that. So that's why it is best or advisable to know this method. Are we together? So let's start. So I'm picking it, how many? 2-1. So everything here again will be my u, and everything here will be my what? V. So let's start. So all I have here, I will have sin x cos x. I will assure you that probably if you are done, just asterisk this question in your notes and go and know the answer. Then from here, so let's start u and v as usual. So I want to do u and v as usual, so I can start. So I have 9x cube exponential x as my u, right? Then if I differentiate v, which is what? Ln x, I have what? 1 over x plus, let me move down here. Then what will be my v here? Ln x. Then now, the next one I will also have again, I will have a double. So I can split it into what? Into 2. So I can have what? 9x cube exponential x, because if you differentiate exponential x, you still have what? Exponential x plus what? Exponential x. If you differentiate 9x cube, what do you have? 27x squared. So I think at the end of the day, I am done differentiating. So then let's now start to open the bracket. So from here, I can now have what is this? And have y prime equals to, so let's open the bracket here. The 9x cube exponential x ln x. Open bracket here, what do I have here? Minus sine squared x plus what? Cos squared x, right? Okay, good. Plus the next one here is what? Sine x cos x. Now multiplying, what do I have here? X and x cube will cancel to give you what? 9x squared exponential x plus, now another ln x. Are we together? Open this bracket. Then what do I have here? 9x cube exponential x plus what? 27x squared exponential what? X. And okay, and here you have it. So one more bracket to open. They are confused. Oh yeah. Okay. Okay, I'm coming. Give me a minute to clean this part. That's how you see it in your CBT, sir. Yes. And by God's grace, it will be written in such a way that you have no other option than to do it, to know it, or for you to cram the answer down to know it. Because they will write everything in such a way that everything will be identical. They can just change probably. We have not got to the answer yet. So let's go to the answer. Okay, now where are we confused? It's copy and paste now. So this part here. Okay, this part here, now that I've done u dv plus v. What I want to do now is what? Du. But du here has how many? 3. So I want to pick it in what? In 2-1. So I pick this one to be u. Then if I differentiate the next, I have what? 1 over x, then plus. Then the next one here, everything Linux here is what? So this Linux here is your v. That's why I brought it out. Then differentiate everything here, which is your u. But that your u also is how many again? Is 2. So that's why I can now split it out like this. You get? Then so from here, so what will I have? Are we ready to open? So let's open the bracket. So y prime equals to, so I can have 9x cubed exponential x ln x cos squared x minus 9x cubed exponential x ln x sine squared x. Are we together? Then plus what? 9x squared exponential x sine x cos x. Then plus this one and this one. Open this one again. So now I'll give you, 9x cubed exponential x ln x sine x cos what? Cos x. Then plus the last one, this one and this one, which will give you 27x squared exponential x ln x. Then multiply by this, which is what? Sine x cos x. Alright, I'll give you a minute to digest it, then we continue. No. 9x squared exponential x, right? Abi now. So this one have 9x squared exponential x, 9x squared exponential x, 9x squared exponential x, 9x squared exponential x, and what? 9x squared exponential what? Exponential x. So writing it out, your final answer will be y prime equals to what? 9x squared, all together, exponential x. So if I remove this from here, what do I have? I have x ln x. Then from here I can factor this one out. Let me use this curly bracket instead. Then if I factor this one out, if I factor ln out here, what do I have? Cos squared x minus sine squared x. Are we together? Then continuing plus, what do I have here? I have sine x cos x. I think it's common for the remaining time here. Are we now? So let me factor out that one again. Then if I remove it, don't forget that I've removed 9x exponential x here. So if I remove sine x from here, what will I have? I will have what? Ln x. Are we together? Plus what? Plus 3. I will have x ln x, sorry. Plus 3 ln x. So that's the final answer. I think I had someone last semester tell me that they had 2 or 3 of this in their 201. Yeah, different questions. Yes, exam. Yeah. So now, the only thing is that they might now want to play with you very well. I know that I'm using the word play. So they might now want to play with you and they'll give you 5 and they will now change the variable of the questions. This is the shortest cut you can have. If you can have a shortcut, I will have taught you. No worry about that. But this is the shortest cut you can have. Are we together? Are we together? Okay, now the last question we do a product two before we move. Are we ready? Last question is also a common question. It's a common piece in 201. I don't know. Probably some of you might have come across it before and just speak. So let's do the solution of that answer you saw and you picked. Are we ready? Okay, now what will happen if you actually differentiate this? Are we ready? Y equals to, let's start, x plus 1, x plus 2, x plus 3, x plus 4, x plus 5, x plus 6. Now I want to differentiate this. So now to differentiate this, now this time unlike the other one I did which was 32, this This one here, they are sharing it what? How many times? Equally. 3, 3. So this is a what? A 6 function. You can expect it. So at the same time, just don't forget that asterisk this solution in your note. And also asterisk this solution to your notes. You can if you want to. You can, but at the same time, it should still give you the same number of stress that you're running from. So now let's split. Are we ready?
Yeah, let's go.
Let's split. I saw this question too. I could not do this, but I did this. I remember I didn't have time to do this because this took a lot of my time. Yeah, so let's start. So as usual, this is your what? U. This is your what? V. Yeah, we'll take it small. So now some people might want to say that they have to expand this one. If you expand, I love you so much from the depth of my heart. But the time you will waste expanding will be equal for me to do twice this same length of expansion. Because first of all, you have to expand 2, 2, 2, which will give you 1, 1, 1. Then that will be a 3 multiplied by a 3 multiplied by a 3. You can now have 3 multiplied by 3, which should give you about 7 times. Then 7 times multiplied by 3, which should give you about what? 11 times. And from that 11 times again, you now what? Have to start differentiating each of them. How many times? 1 by 1. Then by differentiation, you now have to probably start to collect like terms, factorize. Don't worry, let's look at our method. Are we together? So from here, so what's my u here? Which is what? X plus 1. This is what? X plus 2 and what? X plus 3. Now I want to differentiate v. Then how do I differentiate v? I split it into what? Into 2. 2, 1. Let me do 2, 1. So this is u. This 2 is u. This is my v. So I can have x plus 4, x plus 5. Now if I differentiate this, what do I have here? 1. Yes or no? Then plus, write this one, x plus 6. Then if I differentiate this one here, this will be 2. So I pick this one and I differentiate this. So I have x plus 4. If I differentiate x plus 5, what do I have? 1. Plus, write this, x plus 5. If I differentiate x plus 4, what do I have here? 1. Are we together? I think I am, okay. Okay, don't let this my bracket confuse me. Then I think I'm done with u dv. Then plus next one, v du. So what do I have here? X plus 4, x plus 5, and what? X plus 6. So let's write. So I want to differentiate everything I see here. So I pick it to 2, 1, which is what? X plus 1 and what? X plus 2. If I differentiate the next one, I have what? 1. Then plus what? X plus 3, right? So if I differentiate the next one here, what do I have here? I have x plus 1 multiplied by what? 1. Multiplied by what? X plus 2, and that will give me what? 1. So let's open the brackets. So I can have y prime here should give me, what is this? X plus 1, x plus 2, x plus 3, right? Okay, still with this type of brackets. If you expand this, what do I have here? X plus 4, x plus what? Plus 5. Are we together? Plus, are you following me, please? Then plus, the next one is what? X plus 6. Then if you have everything here, if you open the bracket with 1, what do you have? You have what? X plus 4 plus what? X plus 5. Yes or no? Then the next one, okay, close it up this bracket. So you have x plus 4, x plus 5, x plus what? 6. Then from here, what do I have? I have x plus 1, x plus 2, then plus what do I have here? X plus 3. I have x plus 1 plus what? X plus 2. Second bracket is long. Yeah? This part here. Okay, this part here, okay. Plus, my mind have written plus, my hand just writes times. So, the next brackets that we can have here, so what can I have here? I have y prime should give me x plus 1, x plus 2, x plus 3. Okay, I think we are reducing it step by step, so I can have here to be x plus 4, this is x plus 5, then plus what? X plus 6. And if I simplify this bracket, what do I have here? 2x plus 9. Okay, good. Then this part. Then the next part here is what? X plus 4, x plus 5, x plus 6. And the next part here I have x plus 1, x plus 2, plus x plus 3. Simplifying this bracket, what do I have here? 2x plus what? 3. Okay, we are tightening it up, we are wrapping it up. Then from here, I will, okay, so y prime here should now give me x plus 1, x plus 2, x plus 3. Now open this bracket. I think I will be fast with opening it. So let's see. For me, I can have what? X squared plus 9x plus 20 plus what? 2x squared plus, yeah, let's go. 2 times 9 is, I have 9 plus 12, right? 9 plus 12 is what? 21x. Abi now? Then plus what? That would be 54. Yes or no? Now the next one here, plus, I'm almost done. X plus 4, x plus 5, x plus 6. Then everything else should give me what? X squared plus 2x. No, is it 2x? 3x plus 2. But what I have here? 2x squared plus 3x plus 6x should give me what? 9x plus what? 9. So the last step, which will be my final answer, but if you want, you can expand it, and the last one here, y prime, will now give me x plus 1, x plus 2, x plus 3. Then here, let's collect. So this will give me what? 3x squared plus 30x plus 74, then plus the other part here, which is what? X plus 4, x plus 5, x plus 6, and everything here should give me what? 3x squared plus 12x plus 11. Thank you very much. I'm done with the answer. I didn't do it in my time then. I did not do this particular question because it was obviously longer. This one alone took my time because I did this one perfectly, like I did it, and I remembered I got my answer in this one. So what they did to me then was that they did not, this is what they did. They left my answer, they didn't even leave my answer in this simplified state. They left my answer in this state, and they were now changing the terms. Not that if it were to be like this, you know that it's even easy. You have simplified it, then you can. My answer was left in this term. So it had to take you, I have to check probably 3 or 4 terms with your own, letter by letter, before you can pick it, and a CBT. And I remember that I did 20 questions, 20 minutes then. It was a bloody year for me. But let's continue. Are we together, please? Alright, good. So the next technique we'll be looking at after this one will be your quotient rule. Can I clean this part? Okay. I'm waiting for you while you're writing. Let's be quick with our writings. So by God's grace, we'll be able to finish review of, let's look back in time. Let's leave the past. I want us to leave the past in this session. Because next session that we'll meet, I want us to finish it. If it's possible that we can round off 201 before next week, it should be a blessing to you guys. Happy now? Yeah. And 205 also. So I'm waiting for us while we write. Okay. I want to write fast. Okay. So the next one we'll be looking at quotient rule. Then from quotient rule, we'll be looking at chain rule. But in that chain rule, this time around, I'll be teaching the shortcuts in chain rule. I'll teach the shortcut in chain rule. And after that, we'll now have probably 5 questions where we combine all the rules together. Yeah. Then after that, we can now look at, we have a lot of things to look at. A lot. So let's start taking it. Let's start taking it what? Step by step. Are we together? Don't be tired now. Are you tired? No. So let's continue. Alright, are we done with this part? Yes. Okay. So from this part here, So now let's look at quotient rule. Now quotient rule is this. Now for quotient, this is what you have in quotient rule. For quotient rule, you have something like this, which is you have y, which is more or less like a function, u of x divided by what? V of x. And whenever you have something like this, it's having something as this, which is y prime, which is the same thing as v du dx minus u dv dx divided by v squared. So that's the formula. My secondary school teacher taught me very well to master it. So we call this one, let me tell you so that you can remember in exam hall. You call this one top, like what is on top, and call this one bottom, all together. So if you want to say this thing together now, it should be written as, should we start? It should be bottom the top minus top the bottom over bottom square. Why are you laughing now? Do you understand it? So you can write it that way. It will make it stick better in your head than this VDU whatever that you're adding. So now let's take examples. Now what will happen if we want to differentiate this? Okay, now we have y is equals to 2x squared minus 8x plus 9 divided by 4x plus 7. So now here, another thing I can do again is that I can be more manipulative. Another way I can avoid quotient rule is to turn it back to product rule. And that product rule, I will have to use function of a function to differentiate it. But I have not taught you function of a function, and I have not taught you the trick. So let's go hardcore. Are we together? So from here, let's now start. So I can say that here, my y prime is equals to, what do I have here? V du. So this is my v, and this is my what? U. Are we together? So v du. So what's my v here? You have 4x plus what? 7. Now let's differentiate everything here. What do I have here? I have 4x minus what? 8. Yes. Happy now? Then minus what's my u here? Which is what? 2x squared minus 8x plus 9 divide, multiplying, differentiate this one will give me what? 4. Then everything here divided by v squared, which is what? 4x plus 7 all squared. So at your leisure, I would advise you don't expand your denominator. Just an advice. Don't expand. So let's expand your numerator. Then your numerator, what do I have? I will have 16x squared. Then minus 32x plus 28x. What is this now? Minus 56. Now if you use minus 4 to open this bracket, what will I have? Minus 8x squared plus what? Plus what? 32x minus what? 36 divided by 4x plus 7 all squared. Then here y here will now give me, so let's call it like terms together. 16 minus 8x squared should give me what? 8x squared. Are we together? Okay, now the next one I'm doing here, minus 32x, we cancel, plus 32x. Then I'll be left with what? Plus what? 28x. Then the next one, so minus 56 minus 36. That will give me minus 92 divided by what? 4x plus this one here and here cancel out, plus 7 all squared. So now let's check what will happen if I divide. What will happen if I divide this one here? Can 4 divide 92? Yes. So let's move 4 from everything. So removing 4 from here, what do I have here? I have 2x squared, then plus what? 7x, right? Sorry, minus. Now 4 divided by 9 will give me what? 2 remainder what? 1. 4 in 12 is what? 23. Then everything here divided by what? 4x plus 7 all squared. Are we together? So this will be what you have if you differentiate that. So another way I could have avoided this is to use my product rule. So if I will use product rule, I will invert this one, then I can now have 2x squared minus 8x plus 9 in one bracket multiplying what? 4x plus 7 is by what? minus 1. Then I can now do the magic that I want to perform there. But I'm not interested in doing that now because I've not taught you. Let's take it step by step. So let's do another example. Let's see, what if you will want to differentiate y in this case to give you a exponential x plus exponential minus x divided by exponential x minus exponential minus x. Now, I want to differentiate this. So what will happen if I differentiate this part here? By differentiating this, first thing first that you have to know is that you have to find out your u and you have to find out your what? Your v, right? Okay, good. So from here, your y prime here should give me, now what is my v? My v is what? Exponential x minus what? Exponential minus x. Now let's differentiate. So if I differentiate this one here, what will I have? I will have what? Exponential x minus exponential minus x. Yes or no? Yes or no? Yes. Okay, good. Then subtracting, what do I have here? I have exponential x plus what? Exponential minus x multiplying the differentiation of this. So if I differentiate this, what do I have? Exponential x plus what? Exponential what? Minus x divided by exponential x minus what? Exponential minus x all squared. Then y prime in this case can give me, everything here is the same thing. Then y prime in this case can give me what? Exponential x minus exponential minus x all squared minus what? Exponential x plus what? Exponential minus x all squared. Are we together? Then everything here divided by what? Exponential x minus what? Exponential minus x all squared. Then from here, so what can I do to this part here? I'll do what? Difference of what? Of 2 squared. I do want to expand. No. Abba. I'm not expanding, no, even if you want to expand. You can expand in your notes. So from here, let's say okay, so let's apply difference of 2 squared. And what is difference of 2 squared? Difference of 2 squared is saying when you have a squared minus b squared. I mean now, a squared minus b squared will give you what? A plus b multiplied what? A minus b. So let's apply that here. So I can have this one here, y prime to give me, what is this one here? This will give me what? Exponential x minus exponential minus x, right? Plus this one, which is what? Exponential x plus what? Exponential minus x multiplying exponential x minus exponential what? Minus x minus exponential x minus what? Sorry, is it minus? Plus exponential what? Minus x. Then everything here divided by what? Exponential x minus exponential minus x all squared. Then y prime here should now give me, so by expanding this, what will I have? So this one here and this one here will cancel out. I can have 2 exponential what? X, right? Then what will I have here? I'll have exponential x minus exponential minus x minus exponential x, right? I'll be now minus exponential minus x. Then divided by what? Exponential x minus what? Exponential minus x all squared. Then y prime in this case here will now give me 2 exponential x open bracket minus 2 exponential minus x, right? Because exponential x will cancel what? Exponential x. Then everything here I have it divided by what? Exponential x minus what? Exponential minus x all squared. Are we together, please? Yes. Huh? Yes. Okay, where we lost? What I did here was difference of 2 squared. That is a squared minus b squared, which is the same thing as a plus b and what? A minus b. So make this one your a, make this one your b, substitute in this formula, and this is what you will have. Are you getting? Alright, so from here, if I expand, I can have y prime equals to, this will give me what? Minus 4. Okay, good. Now exponential x multiplied by exponential minus x will give me what? Exponential 0. Do you know? No, you don't know. Let me tell you. So exponential x multiplied by exponential minus x. Now according to the law of indices, if you have a to the power of x multiplied by a to the power of y, you have what? A to the power of what? Sorry? A to the power of what? X plus y. So applying that same law here, you have e to the power of what? X plus what? Minus x, which should give me what? E x minus x to be what? E raised by what? 0. So do you know now? Now you know. So for me, you can now have this to be what? Exponential x minus what? Exponential minus x, everything squared. So at the end of the day, your final answer here will be what? y prime equals to what? Minus 4 divided by what? Exponential x minus exponential minus x all squared. So we are done with quotient rule. And the next type of rule we'll be looking at chain rule. But this time around we'll be dealing with shortcuts. So we love that, right? Can I clean this part? Don't love shortcuts. You need shortcuts now in exams. If it were written, you will have to show the steps. Yeah, if there was, but there isn't. Okay, so now let's start. So the next one we'll be looking at now, we'll be looking at chain rule. Chain rule. Now chain rule, as I promised, we are doing the shortcuts how many times? All through. Should we start? Okay, now let's look at the first caliber of shortcuts that we have. Now let me call that algebra. Okay, algebraic. Algebra. Now this time I want to differentiate this, which is y equals to 2x plus 9, number 1, raised to power 41. Yes, I want to differentiate this. So this time around, it should be madness for me. Sorry to use that word. To say I want to expand this to the power of 41. I can bet you that you can stay on that expansion from now till, if you are fast, you know how to collect like terms together without making mistakes. You are still spending 2 hours on this and you're not done expanding. So now, this time around, let's do the shortcut. Now, what will be the shortcut? Listen. Now, the power on top of your algebra, or whatever you have in your bracket, write it in front, which is what? 41, multiplied by, differentiate everything you have in your bracket, which is what? 2. Are we together? Then multiplied by, write the same question again, 2x plus 9, and subtract 1 from your power here. So 41 minus 1 will give you what? 40. So simplify all of this one out, and at the end of the year, what? Y prime equals to what? 82, open bracket, what? 2x plus 9 to the power of what? 40. So this is what? The final answer. I think it has saved you a lot of stress than expanding. Okay, let's look at the second one. Now, what will happen if you have y equals to square root of 6x squared plus 4x minus 5? I want to differentiate this. So, first thing I have to do is what? Is to rewrite the question. So, writing this question here, I can have y equals to 6x squared plus 4x minus 5, everything to the power of what? Half. Then let's start the differentiation. So I can have y prime to give me half, come to the front, multiplied by, now open another bracket. So if I differentiate everything I have here, what do I have? 12x plus what? 4. Then write the same question back, which is what? 6x squared plus what? 4x minus 5. And subtract 1 from your power. So half minus 1 to give me what? Minus half. Then from here you have y prime here to give me what? 1 over 2 multiplied by, what is common here? What is common here? 4. Then what do I have here? 3x plus what? Plus 1. Then everything here is the same thing as writing 1 over square root of what? 6x plus 4x minus what? 5. Then I can have this one to be what? Y prime equals to 2, open bracket, 3x plus 1 divided by 6x squared plus what? 4x minus what? 5. Do you understand? Do you get it? Okay, you don't. Let me understand. Okay, let me make it more explanatory. Make this one here over 1 and cut. So 2 here 1, 2 in 4 years what? Is 2. Then we left it 2 open bracket, 3x plus 1 multiplied by what? By 1. Are we together? Are we together? Okay, good. Then divided by this. That will be our final answer. So one more example and we move. So now we have this one to be y equals to, now let's say you have 1 over 6x plus 9 raised to power 14. I want to differentiate something like this. And how do you do it? First thing first I have to do is what? Rewrite the question. So I can have this one to be y to the power of what? 6x minus 9 raised to the power of what? Negative 14. Then from here you can have y prime equals to negative 14 open bracket. Sorry, before you do the bracket, Differentiate this one, what do I have here? Multiplied by 6, multiplied by what do I have here? 6 minus 9 to the power of what? Minus 15. Yes or no? Because it should be minus 14 minus 1. At the end of the day, you have what? Y prime equals to what? What is this? Minus 80. Are you sure? I trust you. 84. Then 6x minus 9. What? Negative 15. Then this one here, you can bring it down. Then you will have, at the end of the day, y prime equals to minus 84 divided by what? 6x minus 9 to the power of what? 15. Are we together? Are we together?
Yes, sir.
Alright, so that will be the first trick you will learn. Let's go to the next trick you are learning. Alright, so next one you are learning, so let's deal with exponentials now. So now, let's deal with exponentials. To deal with exponentials, so what will happen if you want to differentiate? Let's make it simple. Y equals to exponential 2x. Number second one, y is equals to exponential 1 over 4x raised to the power 5 minus okay, let me make this one 4. 2x plus 8, and the last one you want to do, you want to differentiate y is equals to sine, no, I'm not signing now, exponential sine x, or 2 sine x. Okay, I want to differentiate this. Now, there's a simple trick that follows, what's it called now? This part, and the trick is that your y prime for number 1 will be, now, whatever is on top of your exponential, you differentiate it. And after you're done with that, you keep your answer in the front. So if I differentiate, so what is on top of my exponential here? 2x. So if I differentiate 2x, what do I have? 2. Then after you're done, write your question back. Exponential 2x. By God's grace, I'm done. Now, the second one here, y prime. Differentiate what is on top of your exponential. So what do I have? I have 4 over 4 x raised to the power 3, right? Minus 2, then everything here is what? Exponential 1 over 4 x to the power of 4 minus 2x plus what? 8. Then your y prime in this case here can give you what? X cubed minus 2 exponential 1 over 4 x to the power of 4 minus 2x plus what? 8. So that will be the last one. Then here, number 3. 3 here cannot be y equals, now y prime. So if I differentiate 2 sine x, what will I have? 2 cos x, then write your question back, exponential what? 2 sine x. That'll be whole. That's the trick that you use in differentiating what? Exponential. Alright, so the next one, let's talk about lane. Now lane function. I open that lane, let me just write it, lane functions. So lane functions. I open that lane is a type of logarithm. Yes or no? I don't know. A type of logarithm, and that the name of that logarithm is that you call it a natural logarithm or you call it Napierian logarithm. You don't need to know the meaning. Let's just continue. So now I want to differentiate this one here. Number 1, which is y is equals to lane 4x. Now the second one, you want to differentiate y is equals to okay, let's say you want to differentiate y is equals to lane 2x squared minus 9, and the third one you want to differentiate y equals to, you have your lane sec x. Abi? Okay, let's deal with these 3. Now how do we deal with these 3 differentiations? Now it's a very simple thing to deal with these 3 differentiations, and the best way is that, first of all, your y prime is this. So anytime you have y and you are dealing with lane, let me just teach you the trick. First thing you have to do is what? Draw a straight line. Are we together? Then by drawing a straight line, whatever is in front of your lane, write it in your denominator, which is what? 4x. Then if you differentiate 4x, what will you have? We have 4, put it on your numerator. Do you get it? Now let me come again. Lane is, whenever you have anything lane, do what? Draw a line. Whatever is in front of your ln, write it in your denominator. Are we together? Then differentiate your denominator and put your answer in your what? Your numerator. Are we together? Then so from here, I can say that your y prime here should give you 1 divided by what? X. That's my answer here. Now the second one, repeating the same thing. Y prime here should give you ln. So what do I do first? Draw a line. Then what do I have here? I have 2x squared minus 9. Then if you differentiate 2x squared minus 9, what will I have here? 4x. Yes or no? Is there anything I can do to it again? No. So I'm leaving my answer like this. I don't want to say 2x to cancel. You tell me your math teacher if you do that. Y prime. Now this time I want to differentiate ln sec x. If I want to differentiate ln sec x, what will I have? I will first of all draw a sign, which is what? Sec x. I will together. Then if I differentiate sec x, what will I have? I will have what? Sec x tan x. Yes or no? Then at the end of the day, you find out that sec x tan x is the same thing. Then your final answer here, y prime will give you what? Tan x. Are we together? Okay, so that is that about that for ln functions. The last type of trick you have to learn will be, yes ma'am. Okay, like let's say, okay, let me make question number 4. Let's say you have y equals to 5 ln cos x minus sin x. Have you now? So now, whenever you have this, so it starts like the simple way as you will be doing it. First thing, write your 5 outside. 5. Then your ln, do what? Draw a line. Then from here, what do I have? You have cos x minus what? Sin x. Then if I differentiate cos x, what do I have here? Minus sin x minus what? Cos x. Are we together? So this minus can affect this one. Then I can have what? Y prime is equals to minus 5, open bracket, what? Sin x plus what? Cos x divided by what? Plus cos x minus what? Sin x. That 5, you just leave it separate. Do you get? Okay. So the next one we have. So now let's look at trigonometrical functions. Let's look at the trick behind it. Trig functions. Trig functions. So now let's speak it step by step. Let's say that I want to differentiate y equals to sine 3x. The next one I want to differentiate y equals to tan 5x squared plus 8. Then the last one I want to differentiate is number 3, which is equals to y equals to, give me, then let me say cos this time around, cos let me say 1 plus 2x minus x squared. Alright, so I want to differentiate this 3. Now how do we differentiate this 3? Now trig function have two forms. Okay, so let's talk about first one. And the first thing I have to do here, so your y prime in this case will be this. So y prime, next thing you'll be dealing here is that you start from what is in front of that, your trig. Are we together? So if I differentiate 3x here, what will I have? I'll have 3. The next thing I have to is what? Is to differentiate sin x. So if I differentiate sin x, what will I have here? Cos. Abi? Then the next one, whatever came with your question here, write it back, which is what? 3x. Are we together? Okay, now I think that's that about that. Number 2, y prime. So let's start. What is in front of that bracket here? I have what to be 10x. Yes or no? Yes, it's 5x squared. So after I've differentiated 10x, next thing I have to do is what? Differentiate tan. So if I differentiate tan, what do I have here? Sec squared. Are we together? Then whatever came with your question, you're writing it back, which is what? 5x squared plus what? 8. That's my final answer. Are we getting it? Okay. So number 3 here is you have y prime. So let's start. Let's differentiate what is inside here. So what do I have? I have 2 minus what? 2x. Are we together? Differentiate cos, what do I have here? Minus sine. Then write this one back, which is what? 1 plus what? 2x minus what? X squared. So I hope you know that if I use this minus to open this bracket, I will have y prime to give me what? 2x minus 2 sine, open bracket, 1 plus what? 2x minus x squared. Are we together? Then if I factor out 2 here, so I have 2 open bracket x minus 1 sine, what is this? 1 plus what? 2x minus what? X squared. Right? Are we together? Okay, good. So yes, I am using this minus here to open the bracket. That'll be my answer. So I hope you understand that part. Huh? Yes, okay, so let's look at another part now, which is now what will happen if I have something like this, which is y equals to sine squared x. Yeah, I want to differentiate y equals to sine squared x. Now that I differentiate y equals to sine squared x, the simple stuff. Should we start? So now y equals sine squared x. Please note that sine squared x is not the same thing as sine 2x. Are we together? That's the first thing I have to note, that sine squared x is not the same thing as what? Sine 2x. And sine squared x here is the same thing as saying sine x times what? Sine x, which is definitely not the same thing as saying sine x plus x. Are we together? And this part here is not, this one here can be written as what? Sine x all squared, which is not the same thing as this. Abi now? And this one also is not the same thing as saying sine x plus what? Sine x. They are completely different things. So please note their differences. Are we together? So note their differences. So from here, so I can say that since I have something like this, which is sine squared x, then from here I can say that my y is also equals to sine x all squared. Yes or no? Then from here, so let's now, this time I want to combine two tricks together. I want to combine the normal algebra trick, which will be whenever I have a power, carry the power on top, write it in front, differentiate the middle, and write your question and subtract it from the power. Yes or no? We can still remember that law. So let's try that thing here. So I can have y prime here to give you what? 2. Differentiate this one. What do I have here? Cos, abi now? Cos x. Then at the same time, write your question back. Sine x. 2 minus 1 is what? 1. The final answer is y prime, which is same thing as what? 2 cos x sine x, which is my final answer. Do you understand? Are you sure? Okay, I said that law we use for our algebra, that you have power on top, write it in front, differentiate the middle, then write the question, subtract from the power. That's what I did here. These two came to the front, differentiate sine x, cos x, write your question and subtract from the power. Would you give us this? Do you get? Are you sure? Okay, good. So now another form. Now what will now happen if I now have to differentiate y equals to cos raised to power 4? Yes, you can. Yeah, by God's grace, you can. So let me just put this one as 3x. Yeah, you can put this one as also y prime equals to sine 2x. Yeah, you can leave it like this too if you want. So now for let's look at this one this time around. You want to differentiate cos raised to power 4 3x. Now first thing that we have to do is what? Let's find a way to what? Rewrite the equation, right? Abi now. So writing this equation here, I can have y equals to what? Cos 3x raised to power what? 4. Right? Then from here to write that, so I can have this one here. So I can have y equals to 4 here, write it in front, 4. But now cos 3x is unlike this one I had sin 3x here. So for this cos 3x, what are we sure?
Yes, sir.
Alright, good. So that would be the end for all the tricks. Oh, everything is one. Okay, let me say sine. Let me come back again. 1 minus 2x, sorry, plus x minus x squared. Then here will give me sine 1 plus 2x minus x squared. And the sine 1 plus 2x minus what? X squared. Sorry, I wrote that one. So the next one we want to look at now. So let's look at another technique of differentiation. Are we ready?
Yes, sir.
How far now?
Yes, sir.
I will continue.
Yes, sir.
Let's move. Now we've looked at chain rules, right? Now the next type of rule we want to look at now. Let's look at parametric differentiation. Parametric differentiation. We want to look at parametric differentiation. So now, how do we know parametric differentiation? Now, parametric differentiation is gotten from a parametric equation. Now, and the parametric equation is the kind of equation whereby your dependent variable and independent variable are written in terms of another variable respectively. Do you get what I said? Now, parametric differentiation coming again means that it comes from a parametric equation, and a parametric equation is any equation in which your dependent variable and your independent variable are written in terms of the same separate variables. Now, this is an example of a parametric differentiation. For example, you have y equals to 2t and x equals to 1 minus t. Now, both here I have y and t at the same time. Are we together? So now this time around, I want to do it in this form. Now, here I want to look for y prime. Y prime is equals to dy dx. But on this part, you notice that x and t are written in terms of each other. You can probably make the formula, substitute sign one, get that one, but that won't stress you. So use this formula instead. Use dy multiplied by dt multiplied by dt over dx. So this will be your formula for your for your dy dx. And note that dt dx is the same thing as saying 1 over dx dt. Are we together? Yeah. Okay. This is, whenever you are dealing with parametric differentiation, this is the formula you will use. Dy dx, and dy dx is written as dy dt multiplied by dt dx. Dt cancel dx to give me dy dx. And this your dt dx is the same thing as saying 1 over dx dt now. Right? That's the inverse. Now from this part, so let's apply that law to this one here. So now if I want to say what would be my dy dt here? My dy dt will be 2. Now my dx dt here will be minus 1. Yes or no? Then what will now, so if my dx dt is equals to minus 1, I hope you know that also my dt dx to be minus 1. Yes or no? Yes or no? Abi now, because it should be 1 over minus 1. And 1 over minus 1 is still the same as minus 1. Then so what will be my dy dx? Now dy dx here will be dy dt times dt dx. So what is my dy dt here? 2 multiplied by minus 1. And your final answer here is minus 2. Do you understand? Okay, now let's look at another example. Don't copy. You're not writing notes. So let's look at another example. So now let's look at this example now. So let's look at another example. Now another example, let's say that you have this time around y is equals to x sine t and x is equals to 2x cos t, and they ask to find dy dx when t, so dy dx is unknown, but you have t equals to, let me put t as what, as 0. Well, with t as 0, okay, let's try. So now, as I said, first thing first, so this one should be x, it should be t. So first thing first that I have to do is that, let's find what, dy dt, yes or no? Now dy dt, if you look at this, that you see that you have two separate functions of t, which is what, it's x, I mean, it shouldn't be x now, it should be what, t. You have t sine t. So t is one function of t, and what's the other one, sine t. So what do I have to do here? Write your t first, differentiate sine t, which is what, cos t, plus what do I have here, sine t. Then if I differentiate t, I have what, 1. Then the x dt here will give me what, 2t minus what, sine t, then plus what, cos t, open bracket 2. Then if I open this bracket, what do I have here? I have dy dt equals to what, t cos t plus what, sine t, and the x dt here will give me what, minus 2t sine t plus what, 2 cos t. Are we together? So now from here, so if I have dx dt, no, I hope you know that in my formula I can't use what, dx dt. The only thing I can use is what, dt dx. So now let's now find dt dx here. So I can say that dt dx here will give me what, 1 over 2, sorry, or let's say that 1 over 2 cos t minus 2t sine t. Then what will be my formula for dy dx here? So dy dx here will now be what, dy dt times what, dt dx, which will give me, what I have here, t cos t plus sine t. I will divide, then multiply by what, 1 over 2 cos t minus 2t sine t. Then your final answer here, dy dx is what, t cos t plus what, sine t divided by what, 2 cos t minus 2t sine t. Now I will have left my answer like this, but I have a condition here. What is the condition? I have t equals to what, 0. So if I put t equals to 0 here, what will I have? Then I will be having dy dx, which is the same thing as 0 cos 0 plus sine 0 divided by 2 cos 0 minus 2 times 0 sine 0. And I hope you know that everything should give me what, 0. That will be my answer here. Do you know why it's 0? Because first of all, 0 multiplied by cos 0 is what, 0. Sine 0 is what, 0. 0 plus 0 is what, 0. And divided by 0 is what? 0 plus 0 is what? Let's continue our work. Now, do you understand, please? Now, okay. So that's the bonus question now. Now, what will happen if you want to find the second derivative of a function? Now, what will happen if you want to find the second derivative to a function? So okay, then let me jump back. Okay, let's do it. Let's do it. Okay, so let's do it. So now I want to find, I'm still on parametric differentiation, but now you want to find second derivative. So now second derivative now is what you want to find. So second derivative is given as this formula. So the formula of second derivative is the square y dx squared, which is equals to d dt dy dx d dt y dx dt over dx. Yes, okay. So this will be the formula. So we want to find second order derivative. This is the formula. d dt dy dx, then multiply by what? dt dx. Now what does d dt dy dx means? It means that after I've gotten my dy dx in terms of t, I will now differentiate it again in terms of t. and I'll multiply the answer by dt dx. Okay, it looks complex, abstract. Let's take an example. So let's say that you want to differentiate this one now. You have y equals to 2t squared plus 4t minus 2, and you want to differentiate x equals to t raised to power 5 plus 9. I want to differentiate this. Now, how do we start our differentiation? First thing first. So let's go to dy dt. So the y dt here will give me what? 4t plus 4. Then the x dt will give me what? 5t raised to power 4. Then I will together. Now the next thing that we're looking for now is that we want to find the value of, so what will be dt dx? Now dt dx here. So what will be dt dx? Dt dx will be 1 over this, Abi. So that will give me what? 1 over, that will be 5t raised to power what? 4. Are we together? Are we together? Okay. So then from here, then I can say that my dy dx is what? Dy dt multiplied by what? Dt dx. Are we together? Then from here, so what is my dy dt here? Dy dt here is what? 4t plus 4 multiplied by, what is my dt dx? 1 over 5t raised to power 4. Are we together? Then from here, you can now have everything to be 4t plus 4 divided by what? 5t raised to power what? 4. So what I've just done is what? Is dy dx. So let's now find a way to find out what? The square y dx squared. Are we together? Okay. Alright, so this time around, so let's write this answer in a more simplified form, and you can have this as, I can say that my dy dt, in this case, is the same thing as writing 4t over what? 5t raised to power 4, right? Plus 4 over what? 5t raised to power what? 4, right? Dy dx here, dy dx. Then dy dx here, so I hope so this will give me 4 over 5 t raised to power minus 3 plus 4 over 5 t raised to power what? Minus 4. Yes or no? Right? Abi now? Okay, good. So from here, so let's now look at the square y dx squared. So the squared y dx squared will give me what? D dt of what? Dy dx multiplied by what? Dt dx. So what this one means is that you will differentiate this answer again, then multiply your answer by what? Dt dx. So let's differentiate this one again. So what will I have? That will give us minus 3 times 4 over 5 t raised to power minus 4 plus 4 over 5 times minus 4 t raised to power what? Minus 5. Then everything. So what is my dt dx here? Dt dx is what? 1 over 5 t raised to power what? 4. Then if I open this bracket, what do I have? I have minus 12 over 5 t raised to power what? Minus 4 minus 16 over 5 t raised to power what? Minus 5. Now multiplied by 1 over 5 t raised to power minus 4. Yes or no? So I hope you know that if I open this bracket, what will I be having? I'll be having minus 12 over 25 t raised to power minus 8 minus 16 over what? 25 t raised to power what? Minus 9. This is my answer. Or the most important thing I wanted to observe, or the most important thing I wanted to know is what? I wanted to what? Master that formula. Do you understand? Do you understand? That brings us to the end of parametric differentiation. The last form of differentiation we'll look at. Are you tired now? You can't be tired. Now the last type that we're looking at this time around, let's look at implicit differentiation. Yes, implicit, yeah, differentiation. you cannot separate y from x. I think I talked about it with an MTS 205. Yes or no? So that's what we have. So another thing I want us to check more is, are we done writing? I'm waiting for us. I want to carry everybody along. We're not done writing? Okay. Get out of the game. I'm waiting. So if we are done, just tell me and we'll start.
Yes, sir.
Okay. So here we start. So starting with this time around. So we have, let's see if we want to differentiate y. Now this time I want to work with x squared plus 3y squared minus 8x, and at the same time I'll teach you the what? Shortcut method. So we'll do both at the same time. Short method, you don't need the normal method. You have to know the normal method because you still need the knowledge. There you go, you have to know it. So now, this is an implicit function. Do you know why it's implicit? First thing first is that, number one, it's written in such a way that x and y cannot be separated from each other. Number one, you have to know. And number two is that the highest power of x is also the same as the what? Highest power of what? Y. That's why it's implicit. Now, whenever you are differentiating implicitly, you are always differentiating with respect to what? To what? To x. So I can start by saying differentiate with what? Respect to what? X. And whenever I want to differentiate with respect to x this time around, now this is what will happen. Each time I want to differentiate y, it is showing me that I am differentiating what? Implicitly. Do you understand? Okay, good. So let's differentiate. So if I differentiate x squared here, what do I have here? 2x. Plus, if I differentiate this 3y squared, what do I have here? 6y dy dx. Now here, another part I want to differentiate is what? I have minus here, but I want to differentiate what? 8xy, right? So to differentiate 8xy, what will happen if I want to differentiate 8xy? Then I'll use product too, so I have 8xy. Then this one here will give me your u, this will give me your v. Then you have 8x. If you differentiate to y, what do I have? 1 dy dx. Are we together? Plus, and that's y. If I differentiate 8x, what do I have here? 8. Then my final answer here will give me what? 8x dy dx. Are we together? Plus what? 8y. So this one here can now be the same thing as saying you have 8x dy dx plus what? 8y equals to what? And if you differentiate 17, what do I have here? 0. Are we together? So from here, by differentiating in this case, this time around, so if I want to differentiate here, so I can open the bracket, which is 2x plus 6y dy dx minus what? 8x dy dx, right? Minus what? 8y equals to what? 0. So this time around, it should be easier for you to what? Collect your what? Your like terms. Are we together? So now, collecting your like terms here, what do I have? Let me say I can have 6y dy dx minus what? 8x dy dx. Then let me take these two to the other side. Then I can have what? 8y minus what? 2x. Yes or no? This is what will happen. I had this here, I had this here. I took this and this to the other side, and I have this. Are we together? Can I continue? Yes, sir. Alright, so from here, what is common here? I have dy dx. Then I have here to be what? 6y minus 8x equals to what do I have here? I have 8y minus what? 2x. Divide both sides by 6y minus 8x. Dy dx is equals to what? 8y minus what? 2x divided by what? 6y minus what? 8x. Are we together? Then what is common from here? The only thing that is common here is what? Is 2, right? Then if I factor out 2, what do I have here? 4y minus what? 4y minus x. Then here will give me 2, which will give me what? 3y minus what? 4x. So your dy dx on this case should now give you 4y minus x divided by what? 3y minus what? 4x. So that will be my final answer. Do we grab? Okay, this is the normal stuff, but we can also have a shortcut method to it. Alright, so now look at this time. Now let's do the shortcut method. Shortcut method is this, so you can say that dy dx is equals to minus f of y over f of x. So what this one means is that, what f of y means is that you are strictly differentiating only what? Only y. Any other thing apart from y is a what? Is a constant. That's what f of y means. And f of x means you are what? Strictly differentiating what? Only x. Any other thing apart from x is a what? Constant. So let's do that if you have the same answer. I have minus, open brackets. Okay, good. So I can't differentiate x squared because x squared is a what? Constant. So if I differentiate 3y squared, what do I have here? 6y. Are we together? Now this next one I will differentiate. If I differentiate, what will I have here? Minus what? 8x. Right? Divided by, so let's differentiate it with respect to x. What do I have? I have 2x. Okay. Then what do I have? Minus what? 8y. Then removing the answer here. Okay, I'm looking at, look as if I've inverted, the formula. It should be minus f of x over f of y. Then it should be 2x minus what? 8y. Then the other, what will be in the denominator? 6y minus what? 8x. Okay, good. It's balanced like this. So if I open the bracket, what do I have? I have 8y minus what? 2x divided by what? 6y minus what? 8x. Yes or no? Yes. Then from here, I can have dy dx here, which is giving me what? If I remove 2, I have what? 4y minus x divided by what? We have 2 open brackets. What do I have here? 3y minus what? 4x. Then this one here should give me what? 4y minus what? X divided by what? 3y minus what? 4x, which is the same thing as what I have down here. So this technique here can save you a lot of stress whenever you are dealing with it in CBT. It should be stressful if you now start to show your workings. I hope you are familiar with how the question paper will look like now. Your working sheet in CBT. Yeah, very short. So it means that you don't have enough time for you to work, for you to calculate and work. Do you understand that? Okay. So now, let's look at what if we had 8x squared where? Now, it will have to be the same thing. Although you have just complicated the matter as well. Okay, let's make it complex as you want. You created another problem, and as usual, we do what? We solve the problem. I've been sitting down all through now. I still saying ha. I'm here for you now. If you are, as long as you are here for me. So we're here for each other. Have you now? Okay. So now we have another question. The man said, "What if I touch the question and I put square part?" So and now, if you want to touch the question, I'll add my own touchings to the question. Is that okay? So that will give it 2 touches. Now, what will happen if I add 2x squared, touching it, minus 4y raised to the power 3 plus let me say 6x squared x cubed y equals to 8x y raised to the power 2. Yeah, you touched the question and I did it also at the same time. You say we should touch the question now. So now another thing I want to tell you is this. Now I want to use the shortcut method. Now for me to use the shortcut method, this is what will happen. The only thing that will happen from to use shortcut method is that try as much as possible to bring everything to your left hand side and have everything equated to 0 on that part. Now, so let's do that. So what do I have here? I have 2x squared minus 4y cubed plus 16x cubed y minus what? 8xy squared equals to what? 0. Are we together? Then from here, then what will I have now? Then what I can have, so let's now do, so dy dx here equals to what? Minus f of x divided by what? F of what? F of y, right? So let's start. So I have here minus. Now f of x means you're only touching what? You're only touching what? X. So let's differentiate x. What do I have here? 4x. I can differentiate this. Coming back here, what do I have? Plus what? 48x squared y. Coming here, what do I have here? Minus 8y squared divided by, so f of y now, starting from here, which is what? Minus 12y squared. Coming back here again, plus what? 16x cubed. And what do I have here? Minus 16xy. Then if you use the minus to open your numerator, what will you have? You can have 8y squared, right? Minus 48x squared y minus what? 4x divided by 16x cubed minus what? 16xy minus what? 12y squared. Then from here, then what do I have? So I think what's common in everything? 4. So if I remove 4, then what do I have here? 2y squared minus what? 12x squared y minus what? X, right? Divided by, what do I have here? 4, open bracket, 4x cubed minus what? 4xy minus your dy dx here is equals to what? 2y squared minus 12x squared y minus x divided by what? 4x cubed minus what? 4xy minus what? 3y squared. So this will be your final answer. I think I touched your question and I added my touch to it, and that makes it interesting, isn't it? Isn't it? Yes, let's continue now. All right. So now we've dealt with all parts of differentiation. Now let's now start taking the applications. Now let's now start applying what we know. Are we together? Yes. Let's start. So okay. Are we done with that part?
Yes, sir.
Okay. So hope I'm not burning you guys off. Okay. Alright, application. This time around, we want to apply everything we've known so far. So application of differentiation. Application of differentiation. Now the first application of differentiation is when we are dealing with gradients, equations of normal and tangent. Alright, so this will be the first application we'll be looking at. We have a gradient, and how do we apply it to gradient, equation of normal, and what? And tangent. Okay, let me call our attention to something, and the first thing I want to call our attention to is that the first thing you have to do here is that the whole concept of calculus came in from estimating what a curve will look like. I get my branch like that. The whole essence of calculus came in by, okay, I have a problem, I want to sketch a graph, and the graph is a curve. So how will I get a point on a curve, or how will I get the gradient at a particular point on a curve? So that idea, that problem created this solution. I get my presentation. That's why it's good for you to create problem. You create problem, then you what? Find a solution to it before you die. Very, very important. So now let's look at this. So now, number one, this is what will happen. I will give many curves here. Work the example. Work the example. So I'll give many curves here. I won't make it many, probably make it about 3 curves. And these three curves that I have here, for these three curves, we'll find the gradient to the curve, we'll find equation of the normal to the curve, and equation of what? Tangents to that same curve. All together. That means I'll write 3 questions on the board. For each 3 questions, how many answers will I be having? I have 3 answers per question, right? Okay, good. Let's start. Number 1, y equals to 2x squared minus 6x plus 8 at point 1, 2. The number 2 should be y equals to 4x minus 9 all squared at x equals to 3. And number 3, we have x squared plus y squared equals to 20 at x equals to 1 and y equals to 2. Let me use 2 and let me use 1 here. Alright, so want to look at this type of question? Already? Okay, so this question, as I said, for each of the question you'll find the gradient. For the question we'll find what? Equation of normal, and find what? Equation of what? Tangent. Can we continue? Alright, good. So the first thing we're doing first, solution. So now, number 1, anytime they ask you to find, listen, anytime they ask you to find gradients or equation of normal, equation of tangent, the first thing you are supposed to do, or you are meant to do, is to differentiate that function first, y prime. So if I differentiate that y prime here, what do I have here? I have 4x minus what? Minus 6. Are we together? Now, this thing here has a name, and it is called gradient function. Are we together? So that thing there is called gradient function. And if that part here is called gradient function, then the next thing after I have differentiated is that you are now left to find your gradient m. I hope you know in physics, gradient is m now. So gradient is the same as your slope, yes or no? Okay, good. Now your slope is this. Now it's giving us dy dx at x equals to 1. That is the essence of this point that you have here. Then after you have differentiated your curve, then the next thing you have to do is what? Impute the value of x you have from this your point inside your what? Derivative. I get what I'm trying to say like that. Now so from here, what will I have? I will have 4 open bracket what? 1 minus 6. And your m here is the same thing as what? Minus 2, which is my what? Gradient. That's my gradient. So the next one I want to look for now will now be my EQN. Let me make it short. Or EQT. Now what is EQT? EQT is the same thing as saying what? Equation of what? Tangent. Now the formula of EQT is written as y minus y1 equals m open bracket x minus what? x1. So that's the equation of your tangent. Then from here, so let's start. So I have y minus, now where's my y1? So that point that you are giving here, this is your x1, this is your what? y1. So what do I have here? I have y minus what? 2 equals to, what's my m here? Minus 2 open bracket. What do I have here? X minus what? What is my x1 there? 1. Yes or no? Okay, then from here, if you open the brackets, you can have y minus 2 equals to what? Minus 2x plus what? Plus 2. Write it in a general form, which is y equals to minus 2x plus 4. Yes or no? Yes or no? So you can leave the answer like this, or you can decide to factorize 2 out and have y equals to minus x plus what? Plus 2. Still the same thing. And actually it's the best you write it in this way, because with this way it is corresponding to your normal equation of a line. And what's your equation of a line? Y equals to what? Mx plus what? C. And you can see it actually corresponds to what you have. What's your m in this case here? Minus 2, which is the same as what you have there. Do you understand? Okay, good. So I've gotten my EQT. So let's go for the next one, which is what? EQN. Which is what? Equation of normal. And how do you get your equation of normal? It's the same formula. So but this time around we have y minus y1 equals to minus 1 over m x minus what? x1. So let's follow the same process, and here you have what? Y minus what? What's your y1 here? Y minus what is that? Y minus 2 equals to minus 1 over, what's your m here? minus 2. What do I have here? I have x minus, what's your x1 here? 1. So I have here to be y minus 2 equals to 1 over 2 open bracket what? X minus 1. Yes or no? Yes or no? Then if you open this bracket here with 2, you have 2y minus 4 equals to what? X minus 1. Then take this one to the other side, then you can have what? 2y equals to x plus 3. Yes or no? Then at the same time here, your y in this case cannot be what? 1 over 2x plus what? Plus 3. No, not only 3. Plus 3 over what? 3 over 2. That's your what? Equation of what? That's your equation of normal. Do you understand? Okay, good. Now let's look at the next question. Now let's look at the next question. So number 2 here, what do we have? I have curve which is equals to what? 4x minus 9 all squared. And they only gave me, this time around, they didn't give me 2 points like I have in the other equations. This time around, how many points was I given? I was given how many points? Just 1 point. I was get up. Now if I was given 1 point, I can say that x here is equals to what? 1. Now if I expand this one here, it's still the same as saying y equals to 16x squared plus, this is 72x minus, what is that? Sorry, not minus, plus what? Plus 81 by expansion. Then from here, what did I do first? Let me differentiate. So y prime here should give me what? 32x minus what? 72. Now the next thing I have to do is what? So now let me find my gradient. So my gradient here will be what? 32 open bracket. What do I have here? 1 minus what? 72. And at the end of the day I have what? Minus 40. Right? Yes or no? Okay, good. Now let's now look for your EQT. Now EQT is given as what? Y minus y1 equals to what? mx minus what? x1. Yes, sir? Okay, 3. Okay. 1, thank you. Now you understand it, Jerry. You understand? Alright, good. So from here now, you find out that here I have my x, I have my m, I have my x1, but I don't have a y1. What do we do? The next thing I have to do here, since I don't have a y1, is to make sure that I get a y1. And how can I get a y1? The only way I can get a y1 is by substituting the value of my 1 inside my original equation. I go to an answer like that. So that's the only way I can get y1. So I can say that y equals to what? 16 to the power of 1 squared minus 72, 1 plus what? 81. So what will y give me here? So y will give me 16 minus 72 should give me minus, 16 minus 72. I sorrow now. Minus 56 plus 81. 25. That's beautiful. 25. Then I have 25 in this time around. So I've got my y1. So put that answer back inside this space. Then what do I have? I have y minus, what's your y1 here? Y minus 25 equals to minus 40 x minus what? Minus 1. And for me I have y minus what? 25 equals to what? Minus 40x plus what? 40. Take this one to the other side, you can have y is equals to what? Minus 40x plus 40 plus 25 will give me what? 65. So that's my answer. Are we together? Where are we lost? Okay, so we are together. So now, last question, which is what type of function is number 3? Example of what? Is it implicit or explicit? Number 3, let's differentiate. And I said that dy dx in this case, dy dx, let's use the shortcut, which is minus f of x over what? F of y. Are we together? So now, so if I differentiate this one, what do I have here? Minus 2x over what? Over 2y. Yes or no? By differentiating. Right? Okay, good. Then at this same time, my answer here is what? Minus x over what? Over y. So my m in this case now, you will notice that unlike the other two examples that I had, that I was giving x directly. So by differentiating this one, I have both x and y in my what? In my answer. So that means I'll be substituting these two answers back to this place. Like I said, that my m here is equals to what? Minus x, sorry, minus what? Minus 2 divided by what? 1. Are we together? Then so from here I can say that my m is the same thing as what? Minus 2. Right? Okay, then from here, so I can say I've gotten my m and I know my x1 and my y1. So let's go and find my EQT. So what is my EQT here? That's equation of tangent, which is the same thing as saying, what do I have there? I have y minus what? Y1 equals to what? M x minus what? X1. So for me I have what? Y minus, what's my y1 there? 1 equals to minus 2. What is my x1 there? X minus what? 2. And for me I have y minus 1 equals to minus 2x plus what? Plus what? Plus 4. And at the end of the day I have what? Y is equals to minus 2x plus what? Plus 5. This is what? Equation of what? Tangent. So now the next one here is your equation of what? Of normal, which is what? Y minus y1, which is minus 1 over m x minus what? X1. So I have y minus 1 equals to minus 1 over minus 2 x minus what? 2. And for me I have y minus 1 equals to minus 1, sorry, not minus this time around, 1 over 2 x minus 2. Multiplying everything by 2, so you have 2y minus 2 equals to what? X minus 2. Then take this one to the other side. Then you have 2y is equals to what? X. Yes or no? Yes or no? Then my answer here is what? Y equals to what? X divided by what? By 2. So my equation of normal is what? Y equals to what? X divided by 2. And my equation of tangent is the same thing as what? Y equals to what? Minus 2x plus what? Plus 5. So we have dealt with this first part. So let's go to another interesting part again. That would be so now the next part we're going to be dealing with now will be, yes, so minima and maxima, or what some people call as curve sketching. Curve sketching. That's what I want to look at now. Minima, maxima, what you know as curve sketching. I'll take that. Alright, so this time around, we want to determine whether a curve is, whether it should be a U-shaped curve or whether it should be a V-shaped curve. We want to sketch curve here. At the same time, I want to learn how to find maximum points. I want to learn how to find minimum points too at the same time. Are we together? Yeah. Okay, good. So from here, let's have 3 type of function. The first type, let's have y equals to 6x squared minus 3x then plus 8. And the second one, let's have y equals to, okay, x cubed minus okay, let me see, 3x squared plus 6x plus 3x squared plus plus 3x minus 9. So let's look at this now. I want to solve this. Are we ready? Okay. So from here, let's start. Solution. Now, number 1, which is y equals to what? 6x squared minus 3x plus what? 8. Are we together? Then so from here, first step, whenever I want to deal with maxima or minima, and the first step that we have to do here is that you differentiate first. So y prime in this case should give me 12x minus what? Minus 3. That's your first step. Now, next step, let y prime equals to what? 0. So now, what's my y prime here? So that means I have 12x minus 3 equals to what? 0. And on this part, if I solve for x, I can have that x is equals to what? 1 over 4. Yes or no? By solving for x. Now that's the second part. The next part you have to do after you have solved for x is that put x equals to 1 over 4 in what? In y. Are we together? So what would that be? So that will give me y equals to what? 6 open bracket 1 over 4 squared minus 3 open bracket 1 over 4 plus what? 8. So from this part now, so let's solve that. So I can have this one to give me y is equals to 6 multiplied by 1 over 16, right? Minus 3 over 4, right? Plus what? 8. So y here should give me, if I divide through by 2, that should give me 3 over 8, right? Minus 3 over 4 plus what? 8. So what will y give me here? Oh yeah. You want to do calculator? Let me see. I have 8 here, then I have 3 minus 6 plus 64. Then y here should give me 67 minus 6, which is what? 61 over 8. Yes or no? Right? 61 over 8. Good. Now please note that y equals to 61 over 8. X equals to what? 1 over 4. These two here has a name, and it is called your turning point, or your stationary point. Are we together? It's called your turning point, or what? Or stationary point. Are we getting it? Now if I want to determine the nature of this point, whether it's a minimum or what, or a maximum, so that's the next thing we do. The next thing we have to do here is y double prime. So what is y double prime? So y double prime means you are differentiating your answer again with respect to what? With x. So if I differentiate 12x minus 3, what will be my answer here? 12. Out together. They will now have a condition here, and the condition is that if y double prime is greater than 0, you have minimum points, and if y double prime is less than 0, you have what? Maximum what? Maximum point. Then from the look of things here, you find out that what is my y double prime here? My y double prime here is what? Is 12, and 12 is what? Greater than what? 0. So that means the nature of this point here is a what? Minimum what? Minimum point. Are we together? Okay, so from your minimum point, then your minimum value, please note all these things. Your minimum value is the value of your y in your minimum point. What did I say? Your minimum value is what? The value of your y in your what? Minimum point. So what is your value of your y here? 61 over what? Over 8. So these are the 3 viable questions that they are likely to ask you for each curve they give. So you can have one question and they ask you to find the turning point or stationary point. Still that same curve, they can ask you to find what? Whether it is a minimum point or what? Or maximum point. And still the same curve, they can ask you to find what? Either the minimum value or what?
maximum value. Yes. Yeah, the critical point will not be dealing with when you're having with a single variable of x. Do that when you have double variables. We'll deal with that later. Not now. Do you get? Do you understand? I wish. Okay. So now the next one I want to do now. So let's look at this. So now, as usual, I said that for us to work with this, what do we have to do first? What do we have to do first? Differentiate. So now, if I differentiate this y prime, what would this give me? It would give me 3x squared plus 6x plus what? Plus 3. Yes or no? The next step is what? Let y prime equals to what? 0. Then this one is what? 3x squared plus what? 6x plus 3 equals to what? 0. Then if you divide everything by 3, what will I have? X squared plus what? 2x plus 1 equals to what? 0. And this is a what? A quadratic equation that you will have to solve. Yes or no? Then if you solve this quadratic equation, you find out that your answer is what? X plus 1 all squared equals to what? 0. Yes or no? Then this one here can either give you x equals to what? Minus 1 twice. But let's see if that's what? Minus 1. Are we getting it? Then see if I've gotten my answer for x. What's the next step? Put, okay, let me write that here. Put here to be, put x equals to minus 1 in what? In y. So what is my y? So I have y equals to what? Minus 1 raised to power 3 plus 3 minus 1 all squared plus 3 raised to power what? Minus 1 and minus 9. And I have y equals to minus 1 plus 3 minus 3 minus 9. That y is equals to what? Minus 10. Yes or no? So at y equals to minus 10 and x equals to what? Minus 1. What is the name of this point? Is either your what? Your starting point or your what? Your stationary point. I'll get in. Now from that point now, let's move on to find what? Let's determine the nature. Then from the next point here now, so we've determined, okay, let's determine the nature. How do we determine the nature? The way we determine the nature is by finding y double prime, and y double prime here is the same thing as differentiating your answer again. So if I differentiate the answer again, what will I have? I will have 6x, right, plus 6. Now, but one thing you find out here that you have 6x plus 6. Now, you see that here, I had x here. But unlike the one I did here, what did I have? I have this. Okay, let me include this. If y double prime is equals to 0, we have point of inflection. Yeah, we have point of inflection. Okay, so as usual. So now, since you have x here, and you have gotten the value of your x here to be what? Minus 1. Then substitute that minus 1 inside this place. Then what do I have here? Y double prime equals to what? Minus 6 plus 6, which will give me what? 0. Then I can say that this point here will give you what? Point of what? Of inflection. This is the third condition. That's the third condition. Do you understand? You understand? Okay, good. So this is that about minima maxima. Okay. The next part here, let's talk about rate of change. Let's talk about rate of change. Now rate of change. Now rate of change. Are we ready? So in rate of change, so we can say, okay, let's take down this question. Are you ready?
Yes, sir.
Okay. The rate of change of the area of a circle is x centimeter squared per second. What did I say? The rate of change of the area of a circle. That's right. That's right. That's right. The rate of change of what? The area of a circle is what? X centimeter squared per what? Per second. Full stop. If the rate of change, or if the area, if the area of the circle is expressed as pi r squared, obviously. If the area of the circle is expressed as pi r squared, when your r is 15 centimeter and increasing at the rate of, and increasing at the rate of 2 centimeter per second, find x. Okay. The good news about it is that I got the question from my head, and if I'll call that same question again, I'll change it. So I hope everybody got the question. Okay, good. So now in this time around, rate of change personally does not have a stable, let me call it, does not have a stable formulas like the rest of them we have. And that's when we're dealing with minima, we had a stable formula, this will happen, then we have this, I'll get one apparently like that. But this time around, it doesn't have. You get. Now, how do we deal with this? Now, rate of change, first thing that we have to deal with that, just know that rate of change, if you are dealing with area of circle, we can say that the A dt now is the rate of change of that area with respect to what? To time. Alright. Okay, what question will be given to for us to use y equals to m minus whatever I would have said, I just said now. Sorry. Now the thing is that now they will just give you a normal curve like the one I did earlier on, and they will tell you what to do to that question. They'll give you a normal something like this, and they will specify what you are supposed to do to this what? To this curve. Do you understand? So they will tell you. She get what I'm trying to say. Good. So as I was saying, the A dt is the rate of change of your area with respect to what? To time. And the formula of the A dt is given as the A dr multiplied by the r dt. And I think by the time everything will cancel out, you still have the same thing as what? The A dt. I'll go some potential like that. As I said, it doesn't really has a what? A stable formula. So I think I probably will do about 2 examples or 3 examples so that we can get a grasp of it. All together. So from here, what is the area of a circle that we're given? Area of a circle is given as what? Pi r squared, right? So pi r squared. So let's differentiate this respect to r. So the A dr here is equals to what? 2 pi r. What formula is 2 pi r? 2 pi r is the same thing as what? Circumference of a circle. Alright, then from now, if you observe the question said something, and what the question said is that radius is increasing at a particular rate. Don't forget, so your dr dt is the rate at which your radius is either increasing or what? Decreasing. Do we understand? Okay, good. So now, so from here, the r dt, note, what did the question say? It is what? Increasing. So if your radius is increasing here, it said it's increasing. So at this increase, what is it increasing at? 2 centimeter per second. Yes or no? Now, okay. So if my dA dr is this, now let's. So your dA dt, which is the rate at which the area is changing, is given as. So where's my dA dt? Plus 2 centimeter per what? Per second. Now at the end of the day, if you multiply everything, what will you have here? Plus what? 60 pi centimeter squared per what? Per second.
So now whenever you see plus, so that means that the area of the circle is increasing at what? At this rate. Do you understand? Then if peradventure when we're done we had minus here, it means that the area of the circle is what? Decreasing at what? At this rate. Do you get what I'm trying to say like that? Okay, good. Let's look at another example. So looking at another example. So, are you ready? Okay. Find the rate of change of the volume of a sphere. Find the rate of change of the volume of a sphere. Find the rate of change of a volume of a sphere. Find the rate of change of the volume of a sphere. Are we together? The rate of change of a volume of a sphere. If the radius is decreasing at, if the radius is decreasing at, are we there? If the radius is decreasing at, is, are we there? Okay, when the radius is 5 centimeter. When the radius is what? 5 centimeter. Okay, let's deal with that question. So the next thing here, let's deal with this. Are we together? So let's deal with this. So the first thing that you have to understand first is that you have to understand whatever, you have to understand your question very well first. I guess I'm trying to say like that. Now what is the question talking about here? The question is talking about what? Volume of the what? Sphere. Now let's test. Now what is the volume of the sphere? What is the formula? Yeah, V is equals to what? V is equals to what? 4 over 3 pi r cube. Are we together? Okay then, so with this, let us find the rate at which the volume is what? Is changing. So it's either increasing or what? Or decreasing. So I can say that with this, I can have dv dt is what I'm looking for. So if I'm looking for dv dt, the formula of dv dt is the same as what? dv dr multiplied by what? dr dt. Are we together? Okay, good. So now from here, let's differentiate. Let's find dv dr. So dv dr means I want to differentiate that. So what do I have? I have 4 over 3 multiplied by 3 multiplied by what? Pi r squared. And the end of this will give me what? 4 pi r squared. Are we together? Okay. Now the next one we have is to find the r dt. Now the r dt is what? What is the r dt? Read that sentence that contains the r dt. What is it? 20 millimeter per second. I know it's 20 millimeter per second. Is it increasing or what? Decreasing? It is decreasing. So since it is decreasing, that will give us minus what? 20 millimeter per second. Sorry, there's a conversion problem that we have to do here. Now what was my area? What was my r given as? My r is given as 5 centimeter. So if r is 5 centimeter, so obviously I have to change this one back to what? To centimeter. And how many millimeter make 1 centimeter? 10. So if I divide this one by 10, what do I have here? Minus 2 centimeter per second, right? Then so from here, so if I put 5 inside this formula, what do I have? I have that my dv dr is to, what would I have here? 4 pi, open bracket, what do I have here? 5 squared. Then what would this give me? This will give me what? 1 pi centimeter squared. Yes or no? Okay, good. So from here, let's now plug everything back here. So I can have dv dt equals to what? What is dv dr here? 100 pi centimeter squared multiplied by minus 2 centimeter per square. So what do I have here? I have minus 200 pi centimeter cube per second. So is this volume increasing or decreasing? It's decreasing. So please, I want us to note that. Do you understand? Do you understand? Do Do you understand? So now the next thing that I want to check on now, let's pick another example. Now another example I want to look at. Are you ready? Should I call that question? Okay, let me call one. Let me call one more. Are you there? Okay. Find the rate at which shape should we use now? Okay, yes. Find the rate at which the surface area of an hemisphere find the rate at which the surface area of an hemisphere find the rate at which the surface area of an hemisphere is what? Increasing or decreasing when the radius is out there. When the radius is, what should we give it now? When the radius is increasing at the rate of when the radius is increasing at the rate of let me give it a number, increasing at the rate of 1.5 centimeter per second. 1.5 centimeter per second. 1.5 centimeter per second. Are we there? 1.5 centimeter per second, and the radius is 1.5 centimeter per second, and the radius is decreasing. And radius is what? Decreasing at the rate of 2 meter per second. At the rate of what? 2 meter per second. Are we ready? Okay, good. Now, the question is that first thing you have to look for. So, this is where you have to start. There's a particular topic you were taught in secondary school, and that topic is mensuration. I think till date, some people don't know how to pronounce that thing. It's not menstruation, mensuration. That's how I'm going actually. So now in that part, they taught you how to deal with plane shapes and what, and solid shapes. Yes or no? I'll point that in plane shapes you can't have volumes. The only thing you can have in plane shape is what? Area and what? Perimeter. Yes or no? But in solid shape, what can you have in solid shape? You can have volume, you can have curved surface area, you can have what? Total surface area. Yes or no? Okay, good now. So now they talked about this shape, hemisphere. Now, so what I asked you to find? Rate of change of volume of an hemisphere. Abi? Now question is, what is the formula of the volume of an hemisphere? Alright. Yeah, they asked you to find, was it the rate of change of volume asked you to find the surface area? Okay, now before we can know that, we have to know what is the surface area of a sphere. So what is the surface area of an hemisphere? You have forgotten. Now the thing is that before you can know the answer, you have to know that surface area of a sphere is what? 4 pi r squared. And an hemisphere is half of a sphere. So the answer is what? They have A here to be what? 2 pi r squared. Are we together? Are we together? Okay. Then from there, now they asked to find the ADT, right? So now what is the ADT? Formula of the ADT here, we should give me what? dA dr multiplied by what? dr dt. Now let's start taking it. Okay. So we start taking step by step. So what is the ADR? What is the ADR? Now the ADR is, we want to differentiate this one, which will give me what? 4 pi r. Now what is the RDT here? I didn't give you Kiniko. What is the RDT? Call question for me, please. 1 point what? Yes, 1.5 centimeter per second. Now what was your radius here? Radius was what? 2 meter. And meter and centimeter are not correlating. So what do we have to do? Convert. So if I convert meter to centimeter, what do I have here? That's I have 200 what? Centimeter. Now what will be my dA dt? The A dt here. So dA dt here will give you, what do I have now? So we have 4 times pi times 200 centimeter multiplied by, now is my radius increasing or decreasing? Increasing. So that will be times plus 1.5 centimeter per what? Per seconds. Then at the end of the day, so I have the increasing or decreasing, please? Increasing. Increasing. Yes, decreasing. Then so from here, 4 times 200 will give me what? 800 multiplied by 1.5. Why don't I trust you? Minus 1200 pi centimeter squared per what? Per seconds. Okay, so this will be your what? Your final answer. So that means that area is what? Is reducing. I'll get on a pencil like that. Okay. So, alright. So the other parts of application of differentiation is when you're talking about, when you're applying it in dynamics. That is when you have to differentiate your area, differentiate your displacement to give you your velocity, differentiate your velocity to give you what? Acceleration, differentiate your, okay, you can't differentiate acceleration. I get on a pencil like that. So that part is under dynamics. So I want to quickly enter integration in the remaining time we have left before we leave. I want to enter integration. How much do you have left? It's about 18 minutes and some seconds. So let's look at integration. Let's look at integration. Past question. Okay, the question was increasing. It was increasing. See, fine boys and fine girls, let's settle the matter. If it is increasing your note, change it to what? Decreasing. Is that okay? Yes. So that integration, I just want to enter it briefly, because you need the idea. Let's just enter briefly. The next probably 15 minutes. Look at it. Are you ready? So now integration. Now I want to integrate. Now integration. Now we have two types of integration, and most of the time, most people say that integration is the opposite of what? They are absolutely right. I get an answer like that. They're absolutely right. So integration is the same thing as differentiation. Are we together? So now we have two types of integration. So the first type, we have definite, indefinite, and we have what? Definite. Are we together? So those are the type of integrals that we have, definite and what? And indefinite. So with that one now I would love to give you a table so that you can master the table. I get what I'm trying to say like that. So now if I have y prime, so if I integrate y prime, I will have what? Y. So let's start. So if I have exponential x here, I have exponential x here, 1 over x here, I have x here, you have sine x here, you have minus cos x, and you have cos x, which is what? Minus sine x, sine x, and you have tan, not tan now, sec squared x, which will give you tan x, then you have minus cosec squared x, which should give you what? Cot x. Are we together? Are we together? Okay, then the next one is minus cot x cosec x, and this will give you what? Cosec x. Then if you have 1 over square root of 1 minus x squared, this one will give you sine inverse of what? X. Then the next one here, if you have minus 1 over square root of what? 1 minus x squared, this will give you what? Cos inverse of what? X. And there are lots of things we can have. 1 over 1 plus what? X squared, which will give us the same thing as what I have here to be tan inverse of what? Tan inverse of what? Of x, right? Now the next part we want to look at now. The next part we want to look at. The next part I want to look at, let's say now you have a to the power of x ln x. And by the time you work with this, the answer you have here is what? A raised to what? X. Are we together? Now the thing is, now the question is, how do you recognize definite integrals and indefinite integrals? So now this is the best way for you to recognize it. You can recognize them. The indefinite integral is always written as this: f prime of x dx. And at the end of the day, the answer you have here will give you f of x plus c. But a definite integral, on the other hand, will give you integral b and a f prime of x dx, which is the same thing as saying f of b minus what? F of what? F of a. So this will be what you will have when you have a definite integrals and when you have what? An indefinite integrals. Are we together? Alright. Then from the next thing that we have in here, let's look at techniques of integration. Look at it one by one, but it will be very probably 1 or 2 examples. And we're very fast about it. Are we ready? Okay, good. So let me come to this other part here. Okay, so let me clean this. It has used our board enough. I be now. So let's start. Now the first technique is this. Now technique number 1 is, if you want to, so this time around I'll just be playing around definite and indefinite integrals at the same time. So now if you want to integrate, for example, you want to integrate 2x squared, or let me just give you the general formula. Number 1, if you want to integrate let's start with x to the power of n dx. At the end of the day, you'll be having something like x to the power of n plus 1 divided by n plus 1 plus c. And if you are also integrating a x to the power of n dx, you will be having, what is that? A x to the power of what? N plus 1 over what? N plus 1 plus c, right? Okay, good. Now, this is the first basic rule we have in integration. So since that's the first basic rule we have in integration, now the next thing, so let's now start. So let's say, example, I want to integrate, now I want to integrate 2x squared minus 8x plus 5. Are we together? Now I want to integrate everything here, dx. So how do we start? So, and I hope you know that there's an arithmetic of integration, which means that integration can be shared. Yes, that means this integration can take each and every one of them separately. Now let's just generate our answer here straight up. So what if I integrate this following this law? What will I have? I have 2x cubed raised to the power 3, right? Minus 8x squared raised to the power what? 2 plus what? 5x plus what? C. Don't forget, as long as it is an indefinite integral, what will you have at the back there? You have plus c. Are we together? Okay, now, so I think if you break this one down, what will you have? You have 2x cubed divided by 3 minus what? 4x squared plus what? 5x plus what? Plus c. Do you get? Okay, now let's look at one definite integral using this basic formula. Are we together? So now looking using the definite formula, so here I can have, let's say that you want to integrate a, not a now. Don't let's use a. Let's say I want to integrate 1 and 0. Are we together? So we want to integrate 1 and 0 of 2x squared minus 4x is power 5 divided by 2x
dx. You want to integrate this. And please let me tell you a law. This is another law I want to quickly share with you. And the law is this: if you have an integral of a and b of f of x, f prime of x dx, where a is what less than what b, are we together? This one here is the same thing as minus integral b a f of what of x dx. Please, you can note this somewhere in your what in your book. Sure, you understand? Whenever you have an integral, a definite integral, that the upper bound is what is bigger. I mean that the upper bound is what smaller than the lower bound. Is equal to minus f prime of x. Are we together? Of what upper bound and what lower bound. Are we together now? Yes. Now, so from here, now let's break this one down. I hope you know that this one here, the same thing as dealing with what 1 and 0. And this one, if I divide everything, this should be 2x squared divided by 2x minus what 4x to the power of 5 divided by what 2x dx. Yes or no? Yes. And then I can have the definite integral 1 and 0 of what x minus what 2x to the power of what of 4 dx. Are we together? Then from here, if you integrate x, what will I have? You'll have what x squared over 2. Are we together? Minus what 2x is power 5 over what 5. Now, instead for this one here, instead for you to have a plus c this time around, but this time you won't have what? You have plus c. What you will have here will be what? 1 and 0. That means you put your upper bound of 1 inside this equation, and at the same time you put your what? Lower bound of 0 inside the same equation, and you subtract each of them from each other. Are we ready? Yes. So let's look at that. So for me, I can have what? 1 squared divided by 2 minus 2 open bracket 1 to the power of 5 over 5. Are we together? Then everything is minus. I hope you know that if I put 0 inside this space, everything there will perish. Okay, good. Let everything there perish. And at the end of the day, what will I be having? I think you know that I will have 1 over 2 minus what? 2 over 5. And please don't go and do the same thing I said that 2 cancel 2. 2 cannot cancel 2, obviously. Then everything is what? Is 10. And what do I add there? 5 minus what? Minus 4. Put the same thing as what? 1 over what? 1 over 10. Are we together? Are we together? Okay. Another type. Okay, probably. Let me not rush it then. Let me not rush it then. Alright. So let's put a peg to it here and let's quickly summarize. Let's go back to the past. We are still in the past, but let's still go back to the past of the past. You understand what I'm trying to say like that? So now, the first thing we started with this time around was, we started with what? Differentiation. Yes or no? Yes. And I remember we told us what differentiation was, right? Yes. And I told us that differentiation was breaking down of functions. And I remember that the last time we checked, we had a table for differentiation, yes or no? Yes. So I think it's very, very important, mandatory, compulsory, necessary. Give another English again. Essential. To what? Know that table. You have to memorize it. You see, I brought it from my head. You too can also bring it from your what? From your head. Are you getting what I'm trying to say like that? And after that, we now looked at the different techniques of what? Of differentiation. We started with what? Started with sum and difference rule. And how do you recognize sum and difference rule? Sum and difference rule is a type of differentiation that you have when each function of x are standing what? Separately. I don't have two functions of x standing together. That's when you use your what? Sum and difference rule. Are we together? Now the next type, which is what? Your product rule. Now product rule is when you have two or more functions of x combining together. Yes or no? So now the next one that we have, is what? Chain rule. Now we didn't do chain rule. The next one we did was what? We did quotient rule. And how do we recognize quotient rule? Now quotient rule is what? Is the one that has to do with what? With division. And as it's the one that has to do with division, I think the formula is what? V du. Okay, no. Bottom the top minus what? Top the bottom over what? Bottom square, which is what? V du minus what? U dv over what? V squared. Are we together? Then the next one we looked at is that what is it now? Look at chain rule. Now after that chain rule that we looked at, then we look at some formula, some shortcuts of chain rule. I'll get what I'm trying to say like that. Then after that, we now started looking at what?
we looked at parametric. After all of those formula in chain rule, we look at what? Parametric differentiation. And how do you recognize a parametric differentiation? You recognize a parametric differentiation by saying that the sort of differentiation that your y has its own separate variable and x has its own what? Separate variable. Are we together? Then all of those one combined together will give us what? A parametric differentiation. And I remember I gave us the formula for the second derivative of a parametric differentiation, which is what? D square y dx squared equals to what? D dt of what? Dy dx multiplied by dt over what? Dx. Yes or no? Then after that we moved on to what? Implicit differentiation. And what is an implicit differentiation? In implicit differentiation there, so we have it that it is a kind of differentiation that your x and y are written in such a way that x and y cannot be what? Separated from what? Each other. Are we together? So then from there, now the next one we looked at again, we looked at the shortcut of implicit differentiation, which was what? Minus f of x over what? F of y. So what is minus f of x? Minus f of x is differentiating that function with respect to what? Only x. And f of y is differentiating with what? Only what? Only y. I hope we are recollecting like that. Okay, now the next one we looked at again was what? We now started dealing with what? Application of what? Differentiation. So then the first application we looked at was what? Now we looked at what? Gradient, right? Now we look at gradient. So in that gradient, how do we deal with the gradient? We said that whenever we have a function, the first thing you have to do is what? Differentiate that function first. Yes. Then after you have differentiated the function, that point that they give you, you equate that point. Abi now, equate into it to give you what? Gradient. And from there you can now have the formula of that one to give you what? Y minus y1 equals to what? M of bracket x minus x1, which is the formula for your what? Equation of what? Tangent. And also for the equation of your normal, still using the same process, we'll give you what? Y minus y1 equals to what? M open bracket what? X minus what? x1. Do you get what I'm trying to say like that? Then after we've dealt with the equation of tangent, which one do we look at again? We look at one minima and what? Maxima. And what is in that minima and maxima? Minima and maxima is when we'll be given a particular type of function to either determine its turning point or its what? Maximum or minimum point, or the maximum or what? Minimum what? Value. And I told us that whenever we have any of those functions, what are we supposed to do? We are supposed to what? Differentiate. Now after we have differentiated that function, we equate our answers to what? To 0. Then you can follow through with the process, and we are done, right? Then the last part, I think the last part that we talked about was what? Was rate of change, which we did. We're dealing with areas and formulas and all of this kind of stuff. Yes or no? Okay, now before we now, I told you that the last part is when we're talking about what? Mechanics. That's when you have to differentiate your displacement to give you your velocity, differentiate velocity to give you what? Acceleration and all of this kind of stuff. We did talk about that. So now we now move briefly, swiftly into what? Integration, although we were not able to finish. And I think we did justice by writing out your table, and we did the first part of the integration there. So I think with these few words of mine, I can say that we have come to the end of MTS1 class. So the next set of people should be coming forward now, which will be, now let's deal with this course now, MTS315. So if you are around, just please move forward. So MTS315 is also the same thing as dealing with MTS 209 and MTS 25. So if probably the first time I started you were not around, so you can sit down and enjoy the class with me. So you can just move forward, please. Move forward, move forward, move forward quickly. Alright, so MTS 315, same thing as MTS 25. Well, let's look at it. Are we ready? So we can call any of our friends that we feel should be here that is not here quickly. We'll not be waiting for anyone. Okay. Alright. Please, we can move to the front. We can move to the front. We can move to the front, please. If you have for MTS 315, let's move to the front. So now MTS 315, right? So now in MTS 315 is similar, very very similar. Is similar to MTS 205. Like it's like almost the same syllabus, but the only difference is that at the end of 315 there were just a few additions to it. So that is where you'll be talking about your Bessel equations and your Bessel functions, talking about your Legendre, you'll be talking about your hypergeometric. They didn't teach them in the last section, so probably you guys might be lucky enough because there's a lot of time here, so there might be a tendency that they will teach you. Are we together? So let's now start with the basic things we've learned. So thank God, I hope we are with our manuals. I hope we are with our manuals. Okay, I think I'm seeing one manual in my front here. This 315 manual. Okay, good. That's very good. So I would love to use it, but not now. You just be calling questions for me from it. Are we together? So let's start. So differential equations. So DE. Are we ready? So DE. Okay, I would say. So now differential equation. So let's define what a differential equation is. Let's define it. So let's write. So let's take the definition step by step, word by word. Let's get to know what a differential equation is. Are we together? So now a differential equation. Can we start now? Okay, good. Now a differential equation, probably if you want to write and you're listening, will be any differential equation, or not even a differential equation, like will be an equation that has one or more dependent variable. That's one keyword that you have to know. That's one or more dependent variable. Now another one is that it has what? One or more what? Independent variable. That's another one. Hope I'm not too fast. Am I too fast? Please, let's talk now. We are more than 2, we are more than 3, so let's talk. So as we've said, so I said that is any type of equation that has one or more dependent variable. Number one, it has one or more what? Dependent variable. First one was independent variable. Second one was what? Dependent variable. And the last one that it has is what? Is derivatives. It has one or more types of what? Of derivatives. So those are the 4 kinds of what? Those are the three things that makes up a differential equation. Let's come over it once again. A differential equation has what? One or more. It has what? One or more dependent variable, and at the same time it has what? One or more what? Derivative. So now let's talk about let's understand the concept of dependent variables and independent variables. Let's understand that concept. So before we can understand what independent variable and dependent variable is, we have to first of all understand the concept of what? Variable itself. I will get on a pencil like that. So now let's say that for example you have 2x minus 8. No, I'm using 8. I don't use 81. Let me use 2x plus minus 7 equals to y. Now in mathematics, are we together? In mathematics, anytime we see letter is the same thing as what? Variable. I'll go to my primary. Whereas in English, letter is the same thing as your what? Your normal alphabet. Yes or no? So in English, we have how many alphabets? We have 26 alphabets. But in mathematics, we don't have any alphabets. Alphabets are the same thing as what? As variable, because either x and y can appear anywhere else and have different kind of meaning. Yes or no? Good. So now, I hope you know that is the first concept of what? Variables. Variables are things that can change. Letters, variables. Let's continue. So now from here, now let's now understand the concept of independent and dependent. Now, if you look at this formula that you have on the board, I hope you know that it is very, very much impossible. Assuming I don't want to make x the surface of the formula, it is impossible for me to write y. It's impossible for me to know y without knowing x. Assuming I don't want to make x the subject of the formula, that means I cannot know y without what? Knowing x. I get what I'm trying to say like that. And for me to know x, I don't necessarily need to what? Know y. Yes or no? So that means I can say that y cannot exist on its own. Yes or no? But x of its own features can what? Can exist. I guess what I'm trying to say that. So in that concept, I can say that this x here is your what? Is an independent variable. Independent. And this your y here is your what? Dependent. Are we together? Okay, good. So now we've sorted that out. So now, so any differential equation that has x and y combined together with your what? Derivative. You know what derivative is now? Your derivative is your what? Normal what? dy what? Dx. The derivative is your normal dy dx. So whenever you have any differential equation that has this, you have x and that's y, then all of them cook up together to give you what? A differential equation. I guess what I'm trying to say like that. So now when I was teaching MTS 205, I streamlined them to the fact that x is only your dependent variable and y is only your what? Independent variable. But sir, you guys are seniors, so don't let me streamline you. Let me free you guys. So this is how you recognize a dependent variable and an independent variable from your derivative. Whatever that is on top of your numerator with the d here is an independent, and whatever that is below here is what? No, whatever on top is dependent, and whatever that is below is what? Independent. I get what I'm trying to say like that. So that means there might be some cases where you can have the u decay. In the u decay, I can say that u is what? Depending on what? K. I get what I'm trying to say like that. So while I streamline 205, I am not streamlining you guys. Do we understand? Are we sure? Okay, good. So now we've talked about that. So now let's now move on to types of DE. That's type of differential equations. I want to write types of differential equations. So we have two types of differential equations. Types of differential equations, we have two types. So I might not be following your manual, but I'm following your manual in the spirit. I'm teaching you in the order in which you're supposed to know the course, not like the way. Okay, let me close the chapter there. So now there are two types of differential equations. Now the first type is your ordinary differential equation, which is what we'll call, let me clean this part and let me make it a little bit more interesting. So I have first kind is ODE. That is your ordinary differential equation. That's the first kind. And the second kind here is what? PDE. That's the second time. That's the second kind of what? Differential equation that we'll be looking at. So please note. Now, how do we recognize an ODE from a PD? First thing that you will notice is that an ODE has one dependent variable. That's first thing. One independent variable and one kind of derivative. Let me put it. Kind of derivative. Are we together? So that's the first thing. So that's the first way you can recognize an ODE. What will an ODE have? One dependent. It will have what? One kind of what? Independent, and also it will have what? One kind of what? Derivative. Now let's take a look at this. For example, if I have 2x squared dt dx minus 4t plus 20 equals to what? 0. Now this thing I've written on the board here is a typical example of what? Of an ordinary differential equation. Why? Let's start talking about it. Now how many kind of dependent variable do I have here? 1. So what is my dependent variable here? My dependent is what? Is t. So I have only t as my dependent, no other kind of independent variable present. Now how many independent variable do I have here? X. That is what? 1. I don't have any other kind of independent variable present. And the last time is what? How many kind of derivatives do I have? 1, which is what? Dt dx. So as long as these three conditions are satisfied, you can be sure that you have written what? An ordinary differential equation. Do you understand? Okay, good. Now a PD on the other hand will not have only one. PD we have greater than one independent. Then we have greater than one derivative. And most of the time, let me put it as greater than 1 or equal to 1 dependent variable. So this is everything that you will get from forming what? a PDE. So while a dependent variable is having 1, 1, 1, a partial differential equation is having what? More than 1. But this kind here, there are some differential equations that your dependent variable are just exactly one kind. So let's give an example of a PDE. So this is an example of a PDE. Okay, let me come back here. Example of a PDE is this thing here: 2 partial square u over partial y squared minus 4 partial square u partial x partial y plus 2 21 partial square u over partial y squared equals to 0. So this is an example of a partial differential equation. Now, first thing that you even notice here is that the way it is written is completely different from the way this one here is written. You have that symbol that looks like an incomplete R sound. Have you now? Oh, okay, they call it schwa sound. Okay, good. Now that if you are writing phonetics, this thing here, I hate phonetics then. It beats me on top of it, but I still don't know it. Now this thing is your R sound, and if you clean this other part that looks like E, what would you have here? You have this thing, they call it schwa sound. I think it's the sound that is in teacher. Abi, I still know phonetics more, but that's not where I'm going. So you know that you find out that a partial differential equation has that kind here. I get what I'm trying to say like that. That's number one. But so let's now start looking at it in this light. Now the thing is that how many independent variables do I have here? I have 2. I have what? Okay, sorry, this one should be x. Sorry, I have 2, which is what? X and what? And y. Those are the 2 kinds of independent variables that I have here. Now you notice that how many type of derivative that I have here? I have 3 kinds. This is one kind of derivative. This is another kind. This is what? Another kind. So these 3 here makes it what? A PDE. And this time around, I said I put greater than or equal to 1 variable. In this sense, how many dependent variables do I have here? 1, which is what? Only what? U. So these are the 3 conditions that makes this one here a PDE. Do you understand what I'm trying to say like that? Okay, good. Then from that, so let's now go on to characteristics. Characteristics. Now this characteristics, so for the main time now, we'll only be limiting ourselves to ordinary differential equations for the main time now. Probably in the course of this program, I will touch PDE and work about what characteristics, will trash it out. I get what I'm trying to say like that. So now, in this characteristics, so let's start by saying characteristics of what? ODE. Now, number 1, first characteristic of ODE is order. Order. That's the first characteristics, which is what? Is order. And what is order? Order is your what? Highest derivative present in your differential equation. That's the highest derivative present in your what? Your differential equation. Are we together? Highest derivative present in your what? Differential equation. So now from this your order now. So let me give you a kind of format that you will use to decipher which order, like which derivative is greater than the other derivative. So like, let me start from this part here. If I have the 5y over dx5, this one here obviously is greater than the 4y over what? dx4, which is obviously greater than the cube y over what? dx cube, which is obviously greater than what? The square y over what? dx square, which is what? Greater than what? dy dx. So this is just like a typical example of what you can have as an order. So if any of this, if more than one of these appears in a differential equation, the greatest out of all of this here will give you what? Will give you order. Do you get what I'm trying to say like that? Alright. Now, don't worry, I'll be using the example in your manuals because I think they pattern your question after your manual. Don't worry, so I'll be using it pattern. So I won't use my brain a lot. So let me have the manual like that. Thank you. Okay. Alright, okay. I think we have one here. Next us to classify. Okay. Before we classify this, let's take the definitions one by one. So now let's have an example. Now imagine we have number 1, we have the cube y dx cube plus 4 y squared dy dx minus 2x d square y dx squared equals to 0. Now, we have this as a differential equation. And first thing you want to notice here is that we want to try to write out is what? Its order. Now, how many differentiations? I have only one kind of differentiation, but in different powers. Yes or no? Now, what would be the order of this one here? I have squared, I have 1, I have what? 3. So if you follow this order, which one is the greatest here? 3. So because of that 3, then this one becomes a what? A third order. Are we getting it? Ordinary differential equation. Do you understand? Okay, good. Now, can I clean this part? Alright. So, alright, then now let's look at another example. Now this example now, let's look at it. Let's say we have 2 dy dx minus, okay, let me put this one minus 4 d square y dx squared plus 8 equals to 0. Now let's look at this. Now let's get the order first. So what will be the order? Now the order will be a second order. Now please, you might be tempted to assume that this one here and this one here is the same thing. But sorry to burst the bubbles, they are completely two different things. Let me state that here. The y dx all squared is not the same thing as the square y dx squared. What this one means is that you have dy dx multiplied by what? Dy dx, and this one is what? D dx of what? Dy dx. Please, I'm always stating this because there's no one that is above mistake, but there's some mistake that are too precious to make. I get what I'm trying to say like that. So let us know this for the sake of making mistakes. So please, this don't say because this one here is squared, and that's why it's the second order. It is a second order because this is the what? Highest derivative. I will get on a pencil like that. This one will now give us a what? A second order. Are we getting it? Ordinary differential equation. Do we get that? So that's the first naming category that we have. And the second naming category that we have is this. Is degree. Okay, let me use this one as I, so that it will be different from our numberings, and I. Now degree. And what is the degree? Now the degree of any differential equation has two definitions. Either you call it the power of your order, or you call it the power of your highest derivative. And either ways, you are still saying the same thing, but in what? In different ways. I guess what I'm trying to say like that. So if you call it power, if you call it the power of your order, or you call it what? Power of your highest derivative, you are still saying what? The same. Do you understand? Okay, good. So now with this, let's go back to these ones and let's find the degree. So now, what is the highest derivative here? This is the highest derivative here, right? Now what is the power of it? Everything here is just about what? 1. Abi now? So now with this one here is a what? Third order, first what? Degree. Are we getting what I'm trying to say? Okay, good. Now this one here also, what is your order? Please, whenever you are picking your degree, you are not concerned with the rest of your derivative that you have there. The only thing that concerns you the most is your what? Is your order. That's why you are attacking. So this is your order. So what is the power of this order here? Power of this order here is what? Is 1. So this is now second order, first what? First degree. Are we together? Yes, sir. Okay. Now let's have more examples on that. Let's say that we want to differentiate something that looks like this. Number 3. So let's say we want to have 2 dy dx all squared minus 4y equals to 20. Now let's look at this. Now first thing that we have to determine here, or we have to ascertain here, is that what is the order? What is the order here? This is what? A first order. Out together. Because this is the only highest hidden derivative that we have there, which is what? The highest. So this is the first order. At the same time, what will this type of order give us here? So what is the degree here? This is the power. Which is what? A second what? A second degree. Are we getting what I'm trying to do here? Okay. Now another thing that I want you to know is that in order and degree, there is no room for having rational powers. You know what I mean by yes, rational powers. You know what I mean by rational powers? I mean that you cannot have anything that has to do with the root. Probably 1 over 3, 4 over 3, 7 over 2, whatever it is that you can have. Whenever I have a situation like that, you have to find a way to what? Unrationalize the power. So let's come up with a question. Let's say that you have 4 equals to you have square root of 2x squared, the square y, the x squared, everything raised to power 1 over 2 equals to 4x dy dx. Now we have something like this. Now you notice that what do I have here? Not only do I have one fractional power, but I have how many fractional power? 2 fractionals. Now the first thing I have to do is what? Find a way to what? Unfractionize the power. I'm just going to say like that. Now to do so, what do I have to do first of all? I have to what? Square both sides. So by squaring both sides, what do I have? I have 2x squared open bracket what? The square y, the x squared raised to power half. And if I square everything here, what will I have? I will have what? 16x squared open bracket what? Sorry, I have the y, the x all squared. Yes or no? Then from here, I still have a fractional power, which is still what? Disturbing me. But for me to remove that half, what do I have to do again? Square both sides, right? So now by squaring both sides here, what will I have here? I will have 4x to the power of 4, open bracket what? The square y, the x squared, then everything is equal to, then everything squared here will give me what? 256x to the power of what? 4, open bracket what? The y, the x, everything here raised to power what? Raised to power 4. So now with this now, you see that I have moved from here to what? To this part here. Now with this part here, it is easy for you to what? Not only determine the order, but you can also easily determine the what? The degree. Now what is this order? This is a what? This is a second order. What's the degree? A what? First degree. Please do not be deceived by this 4 here. You don't have anything doing with what? With this 4 that is here. I just want to say like that. You don't have any business with this. Your degree is only concerned with your what? With your order. I just want to say like that. Okay, now the next one I want to look at now. Let's look at the third characteristics. Characteristics. And third characteristics now. This time around, we look at this number 3, linearity. Linearity. So this linearity. So we want to check. There are some conditions that make some differential equation non-linear. But let's write the conditions out. So a differential equation is said to be linear if all the following conditions holds. Are we together? Okay. That's the first thing. So now condition number 1. Alright. Okay. There must be no power of your dependent variable. You know what I mean by there must be no power of your dependent variable? That means your y, the highest power that your y can ever have is what? Y is power what? 1. You must not have a y squared, you must not have a y cube, you must not have a y raised power, anything except from what? 1. That's condition number 1. Now condition number 2 is that y and your derivative must not multiply each other. That's another condition. Y and your derivative must not multiply each other. That is, y and the y dx must not what? Must not exist at all. I just want to say like that. Are we getting it, please? Okay, now that's condition number 2. Condition number 3 is that your derivative must not have any power. Are we there? So how many examples have we called like that? How many conditions have we called? 3 conditions. So what's the first condition? First condition is that y, the parent variable must not have more than what? 1 power. Second condition is that what? The dependent variable and y must what? Stay separate from each other. And the third one is that what? Then your derivative must not have what? Any power. That is, your dy dx whatsoever must only be what? The power of what? 1. Now, okay, how many differential equations do we have on the board? Okay, we have 4. Now, with these 4 differential equations that we have, so can we now classify them as whether linear or non-linear? So let's go at number 1. Is number 1 linear or non-linear? Based on those examples, now it should be what? Non-linear. You know why it is non-linear? The reason why it is non-linear is because y has a power that is more than 1, and at the same time, y is what? Multiplying your what? Derivative. So that number 1 alone is violating 2 laws, and that laws makes this one what? Non-linear. Are we getting it? Now look at number 2. Is number 2 linear or what? Non-linear. Number 2 is what? Non-linear. Now this one number 2 is non-linear is because your dy dx here is what? Is squared. This one is what? Linear. Are we together? Now number 3, linear or non-linear? Number 3 is also non-linear. Now why is it non-linear? Your derivative here has a power. Otherwise non-linear. And the last that we have, I think everything we have on the board here is what? Is non-linear. Have you now? So now let's now create a linear equation. Let's find the one. Let's create one linear equation. Let's say that I have number 5, which is okay, let's call 2y. Okay, 2y is equals to x cubed the square y the x squared minus 4 the y dx. Now let's look at this equation. From this equation, what are we supposed to get first? We are supposed to get what? The order. So let's start. What is the order here? The second order. What is the degree there? The first degree. Now, based on all our laws, is this linear or non-linear? This is what? Absolutely linear. The reason because y is linear is because number 1, y existed here, but the power of y is no more than 1. Settled. And number 2 again, y is not multiplying derivative. Settled. And number 3 is that the derivatives that I have there were not what? Multiplying themselves. They didn't have any power.
That is why this one is what? Linear. Do you understand? Do we understand? Let's talk now. Do we understand? Good. Now that's linearity. Alright. So now the last category, which is IV, is homogeneity. Now homogeneity. Now homogeneous now, unlike others, it doesn't really has a particular definition. But this is how you know when something is homogeneous or what? Non-homogeneous. Let's take this order, for example. Let's say that we have a the 5y the x5 plus b the 4y the x4 plus c the cube y the x cube plus e the square y the x squared plus f the y the x plus what? G equals to what? 0. Now this is very long, but I want you to pay attention to this. Now in this thing that we have on the board here, now this is the order of what you must have in homogeneity. You can have it like that. This is the order of what you must have in homogeneity. Now homogeneity is this. After you have this order, yes, I'll sound to finish my explanation. After you have this order, the next term after the order must be what? Must be 0. Sorry, this one is gy. I think that's what you want to tell me. Okay, yeah, that's gy. And after this order, starting from the highest derivative to the lowest point, which is what? Y. After your y, if what happens after is what? 0, then because of that, it will become what? Homogeneous.
I get what I'm trying to say like that. This is an order starting from 5, move on to 4, move on to 3, 2, 1, 0. Then if after y, which is the lowest, the next thing that exists after y is what? 0. Then it becomes what? Homogeneous. If after y, or after the lowest term of this one here, and the next term that we have there is not 0, then it becomes what? Non-homogeneous. Okay, let's explain in this light. Now let's look at this now. So from here, example, I have what? Add cube here. If I will arrange, I can bring square to the other side, then bring dy dx next. And after dy dx, the next thing I had was what? Was 0. So because of this 0 that it had here, this one becomes what? Homogeneous. Are we together? Are we together? Okay, good. Now, the second one here, if you look at it, you find out that after the order, if I want to arrange it, the order will be from the square y dx squared. Then from the square y dx squared, the next one you have was what? Dy dx. And after dy dx, not only do you not have any y, but the next time after that was what? 8. So if you take 8 to the other side, it gives you what? Negative 8. Yes or no? So because of this 8 here, this one becomes what? Non-homogeneous. Now, okay, let's look at this one here. Number 3, is it homogeneous or non-homogeneous? Obviously, non-homogeneous because of what? This 20. This is what? Non-homogeneous. Then, the last part here, is it homogeneous or non-homogeneous? It's homogeneous because after I arrange it, this is the square y, the y squared. Taking this one to the other side, all I have left there, 0. This one here will be what? Homogeneous. Are we getting it? Good. Then finally, this one here, is it homogeneous or non-homogeneous? Definitely what? Homogeneous. So with this, I think we have fully named our what? Differential equation. For you to name a differential equation, just recapping, you must start from your order, and from order you go to your what? Degree. Then from degree you go to your what? Linearity. Then from linearity you go to what? Homogeneity. Those are the 4 names that your differential equation must have. I'll go to what I'm trying to say like that. So I've completely named all the differential equations that we have here on the board. So let's go and do the exercises that you have in your manual. Let's name them together. I think that's good, right? Okay, good. So in case you have your friends, probably at midnight we'll be having MTS 301. So you're welcome. Call your friends. It should be a lovely one. 301, then after we'll be having MTS 309. So I'm saying this so that probably if you have someone that you know that needs the course, you can just pull a call through or pull a text through. 2 of them will be happening this midnight from 1 a.m. Do you get that? Okay, so let's continue. I love our numbers like this, so we can do better. Now. Alright, good. So now, let's start. Your manual gave us this thing, so we'll be naming it together. So the first naming that we have here, we had number 1, which is what? 3 the square x dt squared, then plus 4 the x dt plus what? 9x equals to what? 2 cos t. Okay, good. Let's start. So I want to name this. So what is the order first? This should be what? A second order, right? Now what will be the degree? First degree. Okay, good. Linear or non-linear? This is what? Linear. Because all the rules are satisfied. Homogeneous or non-homogeneous? I have 9x and I have what? 2t. So because of that it becomes what? Non-homogeneous. Non-homogeneous, ODE. Okay. Number 2. We have dy dx, which is equals to y open bracket 2 minus 3x all over x open bracket 1 minus what? 3y. Okay, good. So from here, so first of all, I think it's easy. What is the order here? is a first order. It's also what? A first degree. Now, let's see. Now, is it linear or non-linear? Huh? It is also non-linear because at the end of the day, if you cross multiply, I will have a y multiplying your what? Your derivative. So it is what? It is non-linear. Now also, will it be homogeneous or non-homogeneous? Are you sure? Are you sure? No. It should be non-homogeneous because by cross multiplication I will have x left here. Should we cross multiply? And let's see. So let's cross multiply. So if I cross multiply, what do I have? I have x minus 3xy. Okay, yes, it's homogeneous. It's homogeneous. Yeah, that's me. I wanted to be sure what you know. So it's also what? It's also what? Homogeneous. Homogeneous. Let's stop at this one. Homo to be ODE. Now let's look at this question. You had this question number 3, which is y open big bracket of 1 plus dy dx close bracket squared, and this thing is equal to c. So what is this? Let's start with the order. What will be the order? First order, right? And say what? Second degree. Linear or non-linear? Non-linear. And at the end of the day, homogeneous or non-homogeneous? Non-homogeneous. ODE. Do you understand? Okay, let's see. Do you have any example? Okay, we have a lot of examples here. I think it should be good if we name all of them. So once and for all, then you know. Okay, this time around, you have this number 5. You have 8 d4y dx4 equals to x1 minus x. Now, this is what we have next. So from here, what is it? This is what? Fourth order. Then it's what? First degree. Then here it is what? It's linear or non-linear? Linear, non-linear? Linear. And homogeneous or non-homogeneous? Obviously what? Non-homogeneous. Right? ODE. Okay, let's look at this. Number 6. Let's look at the square y, the x squared, which is the same thing as minus 0.1, 1 minus y squared, 1 minus y squared, dy dx plus 9y equals to 0. So what's the order here? It's a what? Second order. Then it's a what? First degree. Now, is it linear or non-linear? Non-linear. Because at the end of the day, we have y squared and also y squared multiplying your what? Derivative. So this is what? Non-linear. Are we together? And is it homogeneous or non-homogeneous? Homogeneous or non-homogeneous? Homogeneous or non-homogeneous? It is approximately homogeneous. You know why? Because everything here is multiplying each other. Then I have 0.1 still multiplying your dy dx. So it's homogeneous ODE. Are you getting that? Okay. Let's have some namings here. Okay. 2 more to go. So now let's look at this. We have, what number is that? Number 6. So let's look at number 7. So in this number 7 here, you have the square y, the x squared, everything squared, plus the y, the x cube, plus 3y equals to what? X squared. So let's go. What's the order? Second order. Now, second degree. Then Linear, non-linear? Non-linear. Derivative must not have any power. Homogeneous or non-homogeneous? Non-homogeneous. Are we getting that? That this is what? ODE. Then the last one we have is this. Number 8. Now let's have the cube y, the x cube, plus what? 2, the square y, the x squared, all squared, plus what? The y dx equals to cos x. Let's go. So what's the order here? The third order, right? Now what is the degree? First degree. Nice. Linear or non-linear? Non-linear. And what? Non-homogeneous. Are we together? Okay, good. So don't forget, it's what? An ordinary differential what? Equation. You can always add that to it. Alright, so the next subtopic we'll be looking at is how to form differential equations. Yes, how to form differential equations. So I want to learn that. I want to learn formation of differential equation. So how to form differential equation. So can I clean the? Okay, sorry. So now, so what to form? So next one here is formation of differential equations. Now formation of differential equation. So the thing they have to note here is that, if you are forming a differential equation, there will obviously be, they'll give you one equation. There will be one kind of equation that you'll be given. And that one kind of equation that you'll be given will consist of arbitrary constants. Are you getting it? It will consist of what? Arbitrary constant other than your y and x. And I hope you know that in this case, I can say that y is a what? Dependent variable and x is what? An independent variable, right? Okay, so for me, formation of the differential equation, you have an equation to give you one equation, and that equation will contain arbitrary constants. Are we together? So now, that arbitrary constant that equation will contain has its own meaning. I guess what I'm trying to say like that. That's its own meaning. Now the first meaning that it has is that number of arbitrary constants you have will tell you how many times you differentiate your equation. Do you understand that? That is meaning number one. And the second meaning is that the number of arbitrary constants that you have at the end of the day will what? Will tell you the order of the differential equations to be formed. Do you understand that? Are we sure? Okay, good. So let's start with that. So let's have some examples, and let's say number 1. Then okay, let me write what is in your manual. Y equals to ax squared plus bx. Number 2, let me add this. Y is equals to a over x plus what? Bx. Now the next one here is that number 3, you have y equals to a sine x plus b cos x. And another one that you have here is that you have number 4, which is y equals to a exponential minus 4x plus b exponential minus 6x. Then let me balance the equation, and let me put 1 to make it 5. Let's have here y equals to ax cubed plus bx squared plus what? Cx. So let's look at all these 5 examples that we have here on the board. And from these 5 examples that we have on the board, we want to determine how to form their corresponding what? Differential equation. Are we together? Okay, now let's start. Number 1. So what do I have here? I have y equals to what? Ax squared plus what? Plus bx. You have ax squared plus bx. And I told you that the number of, what do you have there? Number of arbitrary constant tells you how many times you will differentiate, number one, and tells you how many times, what order your differential equation will be. Yes or no? So now from that, how many times will I differentiate? I'll differentiate twice because I have how many arbitrary constant? Two arbitrary constant, which is what? A and what? And B. Let's start. So my y prime on this case here should be 2ax, are we together? Plus what? Plus b. You can call this equation 1. And your y double prime is what? 2a. I think that's all, right? And so from here, it is easy for you to make a the solvent of the formula, right? So now from here, if a will be the solvent of the formula, what will I have? I have y double prime divided by what? 2. And from a here, you can substitute this answer inside this place to get your b. Then y prime here should give you 2, open bracket, y double prime over 2 multiplied by what? X plus what? Plus b. Then your 2 will cancel out. Then you have y prime is equals to what? X y double prime plus what? Plus b. Then your b in this case is also the same thing as saying y prime minus what? X y double prime, right? So you have gotten a, you have gotten b. And the next thing for you to do is what? Put a and b back inside what? Equation 1. So what will your equation 1 be now? So it should become y equals to, what is your a now? Y double prime over 2 multiplied by x squared plus b, not b now, y prime minus what? X y double prime, everything multiplied by x. And from here you can have y equals to x squared y double prime over 2 plus what? Xy prime minus what? X squared y double prime. Now because of this that I have here, I can decide to what? Multiply everything by what? By 2. Then multiplying everything by 2 here, you'll have what? 2y equals to what? X squared y double prime plus xy prime minus what? Not 2y here, a 2 here. You have 2x squared y double prime. Then if you to do it in the normal sense, you can have 2y equals to 2xy prime, right? Minus what? X squared y double prime. Do you know why? Because this one here and this one here are the same thing, right? And I have 1 here, so 1 minus 2 give me what? Minus 1. So you can bring everything here to the other side, and you now have what? X squared y double prime minus what? 2xy prime plus what? 2y equals to what? 0. Now from here, I have brought me what? A differential equation. And what is the order of this differential equation? Is it what? Second order differential equation. What is the degree? The first degree differential equation. Is it linear or non-linear? It's absolutely linear. Then is it homogeneous or non-homogeneous? It's what? Homogeneous. Do you understand that? Okay, good. Now that's the first part. Now the second part we're looking at is about 2, which is what? Y equals to what? A divided by what? X plus what? Bx. Right? Are we together? And so from here, it should be a very beautiful thing for me to rewrite this question here. So by rewriting this, I can have the same thing as y equals to what? Ax to the power of what? Negative 1 plus what? Plus bx. So how many times am I differentiating here? Twice. Now y prime should give me what? Minus ax minus 2 plus b, right? Equation 1. Then differentiating again, y double prime here should give me what is this? 2ax to the power what? Minus 3. Then from here, if you write it, it's still the same thing as saying y double prime equals to what? 2a over what? X cube, right? Then cross multiply, you have what? X cube y double prime equals to what? 2a. Then if you divide both sides by what? By 2. What do I have? I have that a is equals to what? X cube y double prime divided by what? By 2. Are we together? Then so from here I can say that you can put a in what? Equation 1. So what's your equation 1 here? Y prime equals to minus a. Now don't forget that this one here is still the same thing as writing multiplied by 1 over what? X squared plus what? Plus b, right? Then I can have y prime a equals to minus open bracket. What do I have here? X cube y double prime over 2. Then multiplied by what? 1 over what?
x squared plus what I have here, y prime equals to what? Minus x y double prime over 2 plus what? Plus b. Yes or no? X squared is here, I have x cube inside. So x squared cancels to x cube will give me what? X multiplied by what? Your y prime prime. Do you get that? Then from here, if I said I want to what is it now? If I said I want to multiply everything by 2, at the end of the day I'll still come back to divide everything by what? By 2 again, right? Let me just take everything here to the other side. And what will I have? I'll have what? B is equals to what? Y prime plus what? X y prime divided by what? 2. So I've gotten my A, and at the same time I've gotten my what? I've gotten my B. So I can substitute A and B inside where? Equation what? Equation 1. Are we together? So substituting that, what will I have? I will have Y. Write that equation 1 in such a way that it will favor you. So you can write that one as what? A open bracket 1 over X plus what? Plus BX. Are we together? Then to from here, then like I said that Y equals to, what is my A here? What? X cube y double prime over 2 multiplied by what? 1 over x plus what is my b here? Y prime plus what? Xy double prime over 2 multiplied by what? X. Are we together? Are we together? Then so from here, x and x cube can cancel out to give you what? Y equals to what? X squared y double prime over 2 plus, if you multiply 2 by x here, what do I have here? X y prime plus what? X squared y double prime over what? Over 2. Yes or no? By 2. Then 2y equals to what? X squared y double x y prime, then plus what this one gives me? Not x way, 2 here, then plus what? X squared y prime prime. Then here, what will I have? I will have what? 2y equals to 2x squared y double prime plus what? 2x y prime. Are we together? Then from here, what is common here? 2 is common. So if you factorize 2 and write your equation, you will end up having x squared y double prime plus what? 2x y prime, not 2 now, plus xy prime. Are we together? Then minus what? Y equals to what? 0. Do you understand that, please? Okay, good. Let's write that. Alright, so now let's go to question number 3. Are you ready? Ready? Okay. All eye up. Let's start. Ready, set, go. Okay, good. Now, number 3 here, you have what is that? You have y equals to what? A sine x plus what? B cos what? Cos x. Are we together? Then from this part here, so if I have y prime, what do I have here? A cos x, right? Minus what? B sine x. Yes or no? Then from differentiating again, you can have what? Y double prime, which is what? Minus A sine x minus what? B cos x. Now you notice that from here, if I factor out here, if I factor out minus, so if I remove minus, what do I have? I have A sine x plus what? B cos x. And if you find out A sine x plus B cos x is the same thing as your what? As your y. Prime. Are we together? Everything here and everything here is the same thing. But everything here is the same thing as your what? As your y. So in that scenario, I can write this one as saying that y prime equals to what? Minus y. Then taking down to the other side, you can now finally have y prime plus y equals to what? 0. So this is what? The differential equation. Do you understand? Now let's look at number 4. And number 4 is a little bit long, but let's
Let's work with it. So number one, for here we have y is equals to a exponential what minus 4x then plus what b exponential what minus 6x. Now unlike the ones we've been doing before, let's differentiate. So if I differentiate here, y prime here will give me what minus 4a exponential minus 4x. Then this will give me what minus 6b exponential what minus 6x. Yes or no? Then so from here, this is equation what equation 1. Then equation 2 again, what will I have? I can have y prime prime, which is equals to what 16a exponential what minus 4x plus what 36b exponential what minus what 6x, and everything is what equation 2. So now if you will observe that unlike the other differential equations that we have been doing, in which probably towards the end is either a has left or b has left, but we find out that here in equation 1 and equation 2 a and b are what readily present. Yes or no? Now in this time around, you know what you are going to do? So you are going to solve both of them simultaneously. Are we together? So like the same way you solve the simultaneous equation, the same way you are solving this one. But the only difference is that to make your work faster, you can use elimination method. Now let's choose now. Which one do I want to eliminate? Let's eliminate a. Are we together? So to eliminate a, that means I must multiply equation 1 by what? By 4. Right? So that both the coefficient of a here and a here can be what? Can be the same thing. So writing that down, so what do I have here? I can say that equation 1 multiplied by 4. So what would that give me? So I have minus 16a exponential minus 4x. Are we together? Then minus 4 times this will give me what? Minus 24. What is that now? B exponential minus 6x. Then don't forget 4 is still coming back here. So if I multiply that one by 4, what do I have here? I have 4y prime. Yes or no? Yes or no? Then let's say equation 2 multiplied by 1. So equation 2 multiplied by 1 will give me what? 16a exponential what? Minus 4x. Are we together? Plus what? 36b exponential what? Minus 6x. Then equals to what do I have there? Y double prime. Are we together? Then from here, I think the only way we can eliminate is by what? Is by adding both sides. So if I add both sides here, this one and this one what? Will leave. Now this one, by adding here, I have what? 36 minus 24 should give me 12b exponential what? Minus 6x equals to 4y prime plus what? Y double prime. Yes or no? Then from here, what do you have? You differentiate both sides by what? By 12 exponential what? Minus 6x, right? Then what do I have here? I'll have b is equal to y prime plus what? Y prime prime divided by what? 12 exponential what? Minus 6x. How we get on I'm doing, please? Then you can call this one here equation what? So don't call it any equation. I've gotten b. Now from here that you have gotten b, the next thing you have to do is what? Is to use it to find what? To find a. So which is the easiest place for me to put it in? I can put it anywhere. Let me just say that substitute the value of b in which of the equations are we doing? Which one should we work with? 1 or 2? 1 or 2? Equation 1. Now what's equation 1? Equation 1 is what? Y prime equals to what? Minus 4a exponential what? Minus 4x. Then minus 6 exponential minus 6x. Now what is my b? My b is what? 4y prime plus what? Y prime prime over what? 12 exponential what? Minus 6x. Are we together? Then this one here will cancel this one here. Then 6 here 1. This one is what? 2. Then what will I have left? I would have y prime is equals to what? Minus 4a exponential what? Minus 4x. Then minus what? Open bracket 4y prime plus what? Y prime over what? Over 2. Yes or no? Then this one is not squared though. This is 2. Then so from here, how do I do it? let me say that I multiply everything by 2 first. Then multiplying everything by 2, what do I have? I have 2y prime equals to what? Minus 8a exponential what? Minus 4x. Are we together? Minus what? 4y plus what? Y double prime. Yes or no? Don't forget what I'm looking for. I'm looking for a. Then for you to look for a, bring this one to the other side, take this one here. And you can have what? 8a exponential minus 4x is equals to what? Minus 4y plus what? Y prime prime. Are we together? Minus what? 2y prime. Then for me to get a here, I can say that what? A is equals to minus 4y plus what? Y prime prime minus what? 2y prime divided by what? 8 exponential minus what? 4x. Yes, sir? Sir? Okay. Before y as prime. Thank you. Okay. That is prime. So you have gotten A, and at the same time you have gotten what? I've gotten B. Okay. I think I've primed the prime here. Okay. How did this one appear? Add together? No. Okay, probably by opening the bracket here with minus 2, you can add it together. But let's just leave it like, let me leave it like this. Let me leave it like this. So leaving it like this, so the next thing I can just have here is that. So let's now continue again. Now the next one here is what? Substitute A and B inside where? Inside your original equation. Are we ready? So let's start. So what's your A now? So you have y equals to, what's your A now? You have minus 4y prime minus y prime prime minus 2y prime over 8 exponential minus 4x. Are we together? Multiplied by what? Exponential minus 4x. Then the next one there again plus, what is your B? 4y prime plus y prime prime over 12 exponential what? Minus 6x multiplying what? Exponential minus 6x. Cancel out, cancel out, cancel out, cancel out. Then you have y equals to minus 6y prime minus y prime prime over what? 8. Then plus what is this? 4y prime plus what? Y prime prime over what? 12. What is the LCM of 8 and 12? What is the LCM of 8 and 12? 24. Abi? So multiply everything by what? 24. You have what? 24y equals to what is here? Minus 4, right? Abi now? Or them say 4 straight up. No, is it 4? It should be 3. You have minus 6y minus y prime prime. Then plus what? 2 open bracket what? 4y prime plus what? Y prime prime. Open your bracket here. What do I have? 24y equals to what? Minus 18y minus 3y prime prime plus what? 8y prime plus what? 2y double prime. So let's collect this one as a prime. Let's collect both sides together. So you have 24y equals to minus 18y prime minus 8y prime will give me what? Minus 10y prime. Now minus 3y prime prime plus 2y prime prime should give me what? Minus y prime prime. Then take everything here to the other side and you end up having what? Y prime prime plus 10y prime plus 24y is equals to what? 0. Do you understand? Do you understand? Now it looks very very long, right? Sorry, I think that's what your textbook did, and if I'm correct with it, then let me talk. Let's continue. So number 4 on the other part 2 will still be longer. So let's prepare it. But the thing is that once you can understand the concept, you'll be able to move fast, even despite the fact that it is what? It is long. Have you now? Okay, good. Now I think by now we have understand the concept of what we want to do. Yes or no? So now for me to solve number 5, what do I have to know? I have to find the value of A, I have to find the value of B, I have to find the value of C, and substitute them back inside what? This equation. Then we can get our what? Differential equation. Now, if I will ask you, what order of differential equation will I have here? I will have a what? I will have a third order. Can you guess whether it should be linear or non-linear? Can you guess? By God's grace, it should be linear. By God's grace, it should be homogeneous. And the degree will also be 1. Should we prove? Let's prove. So now, so from here, y prime here. What is y prime here? So by differentiating, what do I have? I have 3ax squared plus what? 2bx plus what? C. Equation what? 1. Then y double prime is what? 6ax plus 2b. Equation what? 2. Then y triple prime is equals to what? 6a. Then from here, a is equals to what? Y triple prime over what? Over 6. So put a in equation what? In equation 2. So what is equation 2? Y double prime is equals to what? 6 open bracket what? Y triple prime over what? 6 multiplied by what? X plus what? 2b. Multiplying out, so you have y double prime is equals to what? X y double prime plus what? 2b, right? Then take this one to the other side and divide by 2. So you have y double prime minus what? Xy triple prime divided by 2 is equals to what? B. I've gotten b. The next one is what? Put a and b in what? Equation what? Equation 1. So what would I have in equation 1? I can now have y prime is equals to what? 3. What's your a here? Y triple prime over 6 multiplied by what? X squared plus what? 2 open bracket y double prime minus what? X y triple prime divided by 2x, right? Then plus what? Plus c. Then if I cancel out here, I hope you are seeing the board. Then if I cancel out here, what will I have? Y prime equals to what? X squared y triple prime over 2 plus, open here with x, you have what? Xy prime prime minus what? X squared y double prime, triple prime. Yes or no? Plus c. So multiply everything here by 2. What do I have? 2y prime is equals to what? X squared y triple prime plus what? 2x y double prime minus 2x squared y triple prime plus what? 2c. Yes or no? Do you get? Alright. Then, so, okay, I can rub this part off. Then, so from here, if you collect all the like terms and you cook everything you want to cook, I think by the end of the day you have what? 2y prime is equals to what? 2x y double prime, are we together? Minus what? X squared y triple prime plus what? 2c. And I can say that here, my c is equals to what? 2y prime, y double prime, are we together? Plus x squared y triple prime, Abi? Divided by what? 2. Do you get what I've done, please? Please just follow. Okay, good. Then from here, I have gotten A, I have gotten B, and I've gotten what? C. Don't sleep, oh. Don't sleep, oh. No one no sleep now. Let's continue. Then for me, I've gotten A, I've gotten B, I've gotten C. What am I substituting back? I'm substituting back in my what? General equation. So what's the general equation now? So I have here to be y is equals to what? Ax squared, ax cubed plus what? Bx squared plus what? Cx. Then here, what will I have here? I'll have y is equals to, what is my A here? My A is y triple prime over 6 multiplied by what? X cubed. Then plus, what is my B? My B is y double prime minus x y triple prime over 2 multiplied by what? X squared. Then plus C, which is 2y prime minus what? 2x y prime prime plus what? X squared y triple prime. Are we together? Divided by what? Divided by 2. I think it should be very, very easy for me to multiply everything here by what? By 6. So multiplying everything here by 6, what will I have? I will have what? 6y equals to what? S cubed y triple prime plus 3x squared open bracket y double prime minus what? xy triple prime, then plus 3 open bracket 2y minus 2x y double prime plus what? X squared y triple, y triple prime. Are we together? Open your bracket here, so you have what? 6y equals to what? X cubed y triple prime plus what? 3x squared y double prime minus 3x cubed y triple prime plus 6y prime minus 6x squared y double prime plus what? 3x squared y what? Triple prime. Then I can say that no. Oh, there was an x to multiply this. There was an x to multiply this from here. And there will still be an x here. Now I should have 6xy here. And this one should have been cubed. And this one should have been what? Cube. Yes or no? Happy now? Okay, this one have been, okay, squared and cube. So I can say that this one and this one cancel out, right? Then I can now be left with 6y equals to what? X cubed y triple prime. This one and this one here will give me minus 3x squared y double prime plus what? 6x y prime. Take everything here to the, or take 6y to the other side. Then you can have x cubed y triple prime minus what? 3x squared y double prime plus 6x y prime minus 6y equals to what? 0. That's my final answer. So at the end of the day, I got a what? A third order first degree linear homogeneous differential equation, just as I predicted. Do we understand? Do we understand? Okay, now we are done with the formation of equation, and the next thing we are going to now is verifying solutions. Verifying solutions, yes? Predict, how did I predict it? Well, I can say that so far so good from experience that all equations that has to do with the formation of differential equations at the end of the day will later yield to a linear and homogeneous equation. I think that's what happened here. That's what happened, where is it? Here. That's what happened here. So that's that. Just a nudge. Okay, now I want to verify solutions. So there are two ways to verify solutions. Now there are two forms of verifying solution. There's not two ways, those two forms. Now the first form is you verify solution using an implicit solution, or you verify solution using an explicit solution. For 205, I stopped at only explicit. So yeah, for this class I'll be doing explicit solution and implicit solution, both at the same time. Are we ready? Okay, now let's start. Number 1. So let's start with the subheading, which is what? Explicit solution. Explicit solution. And explicit solution. And this explicit solution, so I hope you know what explicit means now. Abi now? Explicit solutions are solutions in which y is clearly written in terms of what? X. Yes or no? Okay, now let's start. So number 1. So verify that y equals to a sine 3x minus b cos 3x is a solution to the ordinary differential equation y double prime plus 9y equals to what? 0. So I want to verify that. I want to show that if I work on this, I will go back to what? To this. I'll get what I'm trying to say. So now let's check whether it's true or not. So to check whether it's true or not. Okay, let's start. The thing is that it's just a simple process, but you just have to follow the order of what you have here. So the question says you had a what? Y prime prime, and here you had a what? A normal y. So it means that you have to differentiate this fine boy here. How many times? Twice. and put your normal y inside this equation. And at the end of the day, if you evaluate it, your answer must be what? 0. Should we try that? Let's go. Now, so from here, y prime here, what will y prime give me? That will give me what? 3a cos, what is that? 3x, are we together? Then minus, okay, plus 3b, what is this? Sine 3x. Then y double prime here should give me minus 9a sine 3x plus 9b cos 3x. Okay, I have my y prime prime here and I have my y. So let's substitute that here. So what will I have here? I'll have what? Minus 9a sine 3x plus what? 9b cos what? 3x. Are we together? Then plus what? 9 multiplied by what is my y? My y is what? A sine 3x plus what? B cos what? 3x. And at the end of the day, I must have what? 0. Yes or no? Okay, sorry. This one here is minus. So opening your bracket here, what do I have here? Minus 9a sine 3x plus what? 9b cos 3x. Then what do I have here? Plus what? 9a sine 3x. Then what do I have here? Minus 9b cos 3x. Abi? So if you collect like terms together, what will I have? I will have minus 9a sine 3x plus 9a sine 3x, right? Then plus what do I have here? 9b cos 3x minus 9b cos 3x. And at the end of the day, everything gives me what? 0 plus 0, which is the same thing as what? 0. So because I have 0 here, then I can say that this solution here is an exact explicit solution to this what? Differential equation. Are we together? Alright. Yes, we can. But that will be another solution of second order differential equations. So I don't want to jump ahead of my shadow. Let's start taking it step by what? Step by step. Are we together now? Okay, let's verify. Another one. Explicit. Should we go on? Okay, now explicit solution. That's number 2. So let's say what to verify that yeah, y equals to exponential, okay, minus exponential 3x, or let me say a exponential 3x plus b exponential x is a solution to the ordinary differential equation. This time around, I can have y double prime minus 4y prime plus 3y equals to 0. So let's work with this. So let's check if everything here will give me what? Give me 0. Are we together? Can we start? Okay, good. So starting with this, how to clean this part here. Alright, so that means how many times am I differentiating? I'm supposed to find a y double prime, I'm supposed to find a y prime, and I'm supposed to input my what? My y. Yes or no? So let's carry on with that. So from here, so my y prime here, which is differentiating this one here, should give me what? 3a exponential 3x plus what? B exponential x, right? And my y double prime here will give me what? 9a exponential what? 3x, I mean now, plus what? B exponential what? X. So I have everything there and I'm substituting them back inside this place here. So what will I have? What is my y prime prime? So that will give me what? 9a exponential what? 3x plus what? B exponential x. Are we together? Then what's next one? Minus 4. What is my y prime here? 3a exponential what? 3x plus b exponential x. And then the last one that I have here is what? Plus 3, open bracket. What is my y? My y here is what? A exponential what? 3x plus what? B exponential what? X. And at the end of the day, everything here must give me what? 0. So let's verify and let's find out. By open bracket here, you have 9a exponential 3x plus b exponential x minus, what would this give me? 12a exponential what? 3x minus what? 4b exponential what? X plus what do I have here? 3a exponential 3x plus what? 3b exponential what? X. And now together. Then if you collect like terms together here, what will I have? I will have 9a exponential 3x plus 3a exponential what? 3x minus 12a exponential 3x, right? Plus b exponential x minus 4b exponential x plus what? 3b exponential what? X. Then if you add up this one here, what do I have here? 12a exponential 3x minus what? 12a exponential x plus 4b exponential x minus what? 4b exponential x. And everything gives you what? 0 plus 0, which is equals to what? 0. So therefore, this answer is a solution, is an explicit solution to the equation. Do you understand? Alright, let's look at another thing that is here. So I want to check from your manual. Okay. Now another question that we have here is that they ask us to show that. Now they ask us to show that the solution y equals to a x exponential x is a solution to the differential equation. Here you have x dy dx minus y open bracket 1 plus x equals to what? 0. Now this is a question from your manual. And also I would advise that there's a particular law that's in your book, Existence and Uniqueness Theorem, that you have to know it. So I won't be stating it. So it's in your manual, just go and read it up. I know it. Or you can probably Google it, ask anyone, but just know it. It's very important. Now, this is what I have, and this is my y. So the question asks me to show that this answer here will give me this. Are we together? Then how do we verify that answer? I think the only way we can verify the answer is by what? Is by differentiating. Yes or no? Now let us differentiate this answer that is here. So how will I differentiate this? I'll use product rule, right? So now let's go. So I can say that here I have, so dy dx, so everything here can be my u, everything can be my what? V. I can have what? Equals to what? Ax open bracket exponential x plus what? Exponential x open bracket what? A. Yes or no? By product rule, if I did this one product rule, u dv plus v du will give me this. And if I open this bracket, what do I have? I have ax exponential x plus what? A exponential what? X. So I brought my dy dx. So let me substitute it back inside where? Inside this place. So what do I have now? I'll have x open bracket. What's my dy dx? Ax exponential what? X plus what? A exponential x, right? Then minus, let's use y to open this bracket. Then I will have minus y, which is what? Ax exponential x open bracket. What do I have? 1 plus what? X. Are we together? Are we together, please? Then from here, let's just, from here I can now have, what will this give me? I can have ax squared exponential x plus ax exponential x. Are we together? Then opening the bracket here should give me what? Minus ax exponential x minus what? Ax squared exponential x. And I think if I collect like terms together, I can have ax squared exponential x minus ax squared exponential x plus what? Ax exponential x minus ax exponential x. Then at the end of the day, what do I have? 0 plus 0 equals to what? 0. So it's verified. Okay, how many examples have we done so far? We've done 3. Have we? Okay, let me see if there's one type of example that we can do. Okay, I think that will be that about that. So I hope we all grab. Abi now. Now let's look at the second part of it, which is what? Implicit solutions. Implicit solutions. So implicit solutions. In these implicit solutions, so we want to check. So we'll be having some of your okay. Implicit solution. Okay, they ask us to show that. Question asks us to show that number one. Show that here x plus y plus exponential xy equals to 0 is an implicit solution to 1 plus what? X exponential xy dy dx plus 1 plus y exponential what? Xy equals to what? 0. That's a question. So the question asks us to show that x plus y plus exponential xy is equals to 0 is an implicit solution. Please, are we getting this thing, please? Huh? Okay, good. So I want to write, look in this part. Look at it. It looks full. Okay. Alright, so now, so what do I have there? Let's write the solutions again. What is the solution that I was given? I was given as what? X plus y plus what? Exponential xy equals to what? 0. And whenever you have that they ask you to show that something is an implicit solution, the only thing that they ask you to do is that differentiate your solution implicitly. Then the answer you get is your final answer. Do you get what I'm trying to say like that? So whenever they ask you to show that something is an what? Implicit solution, the only thing you have to do is what? Differentiate your solution how many times? Implicitly. So it is unlike your explicit solution that you have to differentiate according to the number of times you have in your what? Your question. I get what I'm trying to say like that. So let's use implicit differentiation here. And implicit differentiation means that each time I'm differentiating y, I am adding what? Dy dx to it. Yes or no? So let's start. So from here, if I differentiate implicitly, what will I have? I will have 1 plus 1, or let me just call it dy dx, then plus. Now this time around I have exponential xy, right? Now in exponential xy, if we take it step by step, so let's take exponential xy, let's take xy out. Are we getting it? So if I differentiate xy, first of all with respect, okay, let's differentiate xy, and I think I will have what? X dy dx plus what? Y. Yes or no? That means if I differentiate everything on top here, this is what I will have, which is what? I will have x dy dx plus y, then everything multiplying your what? Exponential what? Xy equals to what? 0. Are we together? Are we together? Then so from here, open your bracket. Then by opening the bracket here, what will I have? I will have 1 plus what? Dy dx plus what? X exponential what? Xy plus what? Y exponential what? No? S exponential xy dy dx plus what? Y exponential what? Xy equals to what? 0. So let's collect like terms together. Then I can have 1 plus y exponential xy plus what? Dy dx, right? Plus what? X exponential what? Xy dy dx. Everything here is equals to what? 0. Yes or no? Then 1 plus y exponential xy plus what is common here? Dy dx. Then if I remove what will I have? 1 plus what? X exponential what? Xy equals to what? 0. Then you find out at the end of the day, what I have here is the same thing as what I have in my original question here. So if I can go back to my question from my answer, then that means this solution is what? Like it's correct, an implicit solution. Do you understand? Okay, good. Another example. So now I want to show that okay. Yes. Yes. I'll still get the same thing. But after I get the same thing, I will still have to linearize it to get to this place back. So it's a little bit stressful. It should still be the same thing, that it should be dy dx equals to minus f of x over f of y, then cross multiply, all this kind of stuff. Still give you this thing back, but you just stress us. Okay, let's look at this question. I'm trying to get it hard from where this man said. Okay, so that's number one. Number two here is saying that we want to verify that, what am I verifying? I'm verifying that 4x squared minus what? Y squared. I'm guessing this is 4. I am guessing this is 4 equals to C is, okay, they asked us that, okay, let me just leave the rest, is an implicit solution of y dy dx minus 4x equals to what? 0. Are we together? Okay, now, so as I've said earlier on, as I said, I am guessing that this is what? This is 4. You can't see clearly from what is in the book. Then from here, so let's now see solution. And from the solution here, so I can say that, let me write out this one, which will give me what? 4x squared minus what? Y squared equals to what? C. Yes or no? And I told you that whenever you're having implicit solution, what do you have to do? Make sure you differentiate your answer in such a way that you go back to your what? Your question. So let's go on with that. So if I differentiate this, what do I have here? I have what? 8x, right? Minus what? 2y dy dx equals to what? 0. Right? C is a constant now. Then from here, if you divide everything here by 2, what do I have? 4x minus y dy dx equals to what? 0. Then if you multiply everything that is here by minus, then what will I have? Y dy dx minus what? 4x equals to what? 0. The same question that I have back here. Abi now? Do you understand? Do you understand? Okay, good. So let's do one more example on implicit solution. Okay. So Jesus, wow, this looks all right. Okay, this looks beautiful. So now, next one I want to show is that I want to, like, that's question number what? Question number 3. So I want to do what? Show that, what do I have? Show that y minus c all squared equals to cx is an implicit, I think the person that is saying find help with this implicit differentiation. I think you are saying your help already. I've been now. Implicit solution to 4x y prime all squared plus 2x y prime minus y equals to 0. So now I want to show that that one on top will give us the one we have below. Abi? Okay, let's see. I look as if we want to bend the rules that have been guiding this for some time. Don't just bend it. So from here, let's have solution. So I can say, breaking this one down again, what can I have? Y squared minus 2yc plus what? C squared equals to what? Cx. Differentiate everything with respect to what? To y. Yes or no? If I differentiate everything with respect to x, sorry, then I have what? 2y dy dx minus 2c dy dx equals to what? C. Yes or no? Now, if I factorize the y dx outside, then what do I have here? I have 2y minus 2c equals to what? C. Yes? Then I can have what? The y dx is equals to what? C open bracket, 2 open bracket, y minus c. Yes or no? So by the time you find out that what I have here is not what I have here. Now this one here, we cannot quickly jump to conclusion that it is not an implicit solution. So what they are just trying to tell us here is that according to the workings of your manual is that we have to substitute this answer inside this place and make sure that it gives us what? 0. That's the only little touch we have with this. So can we try that? So if I try that here, what will I have? I will have 4x. Now what is my y now? So I have c over 2 open bracket, y minus c, everything squared, right? Plus what's this? This is 2x c over what? Y minus c 2, right? Then minus what's my y? My y. Now this time around, I did not have a y. Yes or no? Yes or no now? Do I have y? I don't have y now. But I can find y. Right? Can I not? Can I not? Can I not? Do I have y in the equation? I don't have y now. But I can find y. Can I not? So let's look for the y that is missing. So from here, okay, from here, I just want to look for y. From here, I can have y minus c all squared equals to what? Cx. Right? Then from here, if I square root both sides, I can have y minus c equals to what? Cx raised to power what? Half. And from here, I can have that y is equals to what? Cx raised to power half plus what? C. Right? And let me put that here. So what would I have? Minus cx raised to power half. I hope you know that if I use minus here, what will I have here? Minus c. Then let's look at it critically. Can expanding this one give me 0? Huh? Can expanding this one, let's look at it critically. I don't think it can. Right? I don't think it can. I don't think it can. So since this one, since expanding this one cannot give me back this solution, then I can say that y minus c all squared equals to cx is what? Is not the solution. Are we together? So it's not a solution. Do we get? Do we get? Okay, now the next thing I want to look at here, following the order in your manual. Next thing I want to look at here. Now I want to look at this thing that they call Wronskian function. Jesus. Wronskian function, which is okay, Wronskian, okay, that's WRONSKIA, and Wronskian function. Okay. So this Wronskian function, they have a way that it is denoted here. So in Wronskian function, so basically what Wronskian function is all about is to show the linear dependency or independency of a solution. I'll go to my pencil like that. So let me just run through your notes and let me just summarize what you have. I will get on a pencil like that. So first thing I wanted to note here is that in Wronskian function, now note this, the number of solutions you have gives the dimension of the matrix to be formed and the number of times to differentiate the given solution. So this is one thing you should note. You should note that first thing you should notice that the number of solutions you have gives the dimension of the matrix to be formed, and number of times to differentiate the given solution. Are we together? And Wronskian function, basically. Okay, let's take down this question. Are we ready? Okay, let's write. Okay, solution. Not the solution, the question. Are we there? Given that y1 of x, are we there, equals to x, y2 of x is equals to x squared, and y3 of x is equals to x to the power minus 1, is a solution to x cubed y triple prime plus x squared y double prime minus 2x y prime plus 2y equals to 0, which is x for all x greater than 0. Then the question shows that it will so from here, so you have to show that you will show whether it is linearly dependent. Show whether it is linearly dependent or otherwise, and generalize and find its general solution. So are we there? Are we done writing, please? On to clean. Okay. Okay. Okay, I want to clean this part. So okay, so let's talk about this Wronskian function. Now the thing is that I said something here that number of solutions you have give you the dimension of the matrix to be formed and the number of times to differentiate the solutions. I'm getting what I'm trying to say now. So let me now explain what I have here in light of what I've written on the board. Now, how many solutions was I given? I was given that this is a solution, this is also a solution, and this is what also a solution. So if I want to find the Wronskian function, which is written as W of
f1 of x, and this is f2 of, okay, sorry, this is f2 of what, x, and this is what, f3 of x. The Wronskian function written in this format. I'll get on a pencil like that. Now what it means is that you write your solutions. So how many solutions do I have? And I have x, here is the first solution. And second solution is what? X squared. And the third solution is what? X to the power of what? Minus 1. I'll get in it. Now what this one means is that I will have a 3 by 3 matrix. But what to complete the remaining 2 rows and columns will be number of times you differentiate. So if I differentiate x once. So let me just say it. If you have 3 solutions, you differentiate twice. Note, if you have 3 solutions, you differentiate what? Twice. If you have 2 solutions, you differentiate how many times? Once. Do you understand? So from here, so if I now have this, then if I differentiate x, what do I have? 1. X squared will give me what? 2x. This one will give me what? Minus x minus 2. Differentiate 1 here, what do I have? 0. Differentiate this one will give me what? 2. And this one here will give me what? 2x minus 3. So now you know that this one is determinant and this is not a matrix. I'll get in it. Now if you find the determinant of this matrix here, what will I have? I'll have x. Let's just do the normal way now. So x, everything here will leave, everything here will leave. Then I'll be left with what? 2x squared times this, which will give me what? 4x minus 2. Then this one times this one plus what? 2x is by what? Minus 2. Are we together? Then minus what? X squared. This one will leave, this one will leave. Then what do I have here? 2x is by what? Minus 3. Then plus the next one, which is what? X is by minus 1. So this one will leave, this one will leave. Then what do I have here? I have 2. Then if you open your bracket here, what will I have? At the end of the day, I will have what? This one will give me x open bracket 6x to the power of what? Minus what? Minus 2. Minus what? 6x. No, this one will be 6x squared. So this will give me what? 2x to the power of what? Minus 1. Right? By indices, right? Then plus this will give what? 2x to the power of what? Minus 1. So if you open this bracket here, what do I have? You have what? 6x to the power of what? Minus 1. And this one here will vanish. I will get some trying to say like that. So please note that if, listen, if your Wronskian function of whatever solution that you are given, f of 2 of x plus, sorry, comma, f of 3 of x here, if after you solve everything here and the answer you have is 0, if after you solve it and everything you have here is what? Is 0, please, let's come back now. Let's come back. So if you solve everything here and the answer you have is 0, that means that this solution is what? Linearly dependent. What do I call it? Linearly what? Dependent. Now if it is not equal to 0, that means it's what? Linearly what? Independent. So now unlike this case, you find out that by the time I did everything here, I did not have 0. Then what do I have here? I have what? 6x to the power of what? Minus 1. So this makes the solution what? Linearly independent. Yes or no? Now as this thing is not linearly independent, so the next question asks us to find the general solution. So you can only have a general solution when your Wronskian function is what? Linearly independent. And general solution in this term will now be given as y will be given as c1x plus c2x squared plus c3 x to the power of minus 1 will be a general solution. Note, or let me just say it in a way that you understand, and it is that whenever your answer is not equal to 0, that is your Wronskian function is not equal to 0, the thing that you do is what? You multiply arbitrary constants to all of your solution and you what? Add them together, and that will give you a what? General solution. Do you understand what I'm trying to say like that? Do you understand? Okay, we'll have another example for better understanding. So in this case now I want to check. So this is the question. The question says that Matthew, given that y1 of x equals to what? Cos 3x, and what? y2 of x is equals to sine 3x.
given that these are solutions to y prime prime plus 9y equals to 0, the first thing you have to do is that you show that, show whether it is what? Linearly dependent or otherwise, and hence what do? Find its what? General solution. Are we together? Okay. Now I want to test this. Another one to test now. So then from here, as I've said that you have to check for your Wronskian and all of this kind of stuff. So now let's now look for a solution here. So this will give me the Wronskian of, how many functions do I have here? I think I have f1 of x and what? f2 of what? Of x. These are only solutions I have here, which is 2. If I have a 2 solutions, how many matrix? What will be the dimension of the matrix I want to form? It will be a 2 by 2 matrix. Let's form that. So this one I will have this time to be what? Cos 3. Sorry, this will be cos 3x, and this one is what? Sin 3x. Then here, so how many times will I be differentiating? Once. So if I differentiate this, what do I have here? Minus 3 sin 3x, and this one will give me what? 3 cos what? 3x. Then if that's going to be the case, then the next thing that we have to do here is what? Now let's just multiply. Find the determinant as usual. To find the determinant here, what will this one give me? The determinant will give me what? 3 cos squared 3x plus what? 3 sin squared 3x. And at the end of the day, if I factor
out 3, and I have 3 open brackets cos squared 3x plus sin squared 3x. What would this one give me, please? Everything will give me what? 3, because cos square a plus sin square a is equals to what? 1. So everything will give me what? 3. And since this one is 3, that means that the Wronskian function is what? Linearly independent. That is, this solution are what? Linearly independent. So what will now be the general solution? Y will now be what? C1 cos what? 3x plus what? C2 sin 3x. Do you understand? Do you understand? Adding of these two here will give you what? General solutions. So please, you have to pay close attention to your matrix determinant, because ordinarily one mistake can turn linearly dependent to linearly what? Independent. I guess what I'm trying to say like that. So please, you have to be watchful. Now the next one we'll be looking at now, according to your manual, so the next one we'll be looking at now, according to your manual, okay. Alright, okay. Now the first one we're looking at, according to your manual now, will be solutions to ordinary differential equations. So that's what you'll be looking at now. I want to look at the solutions to ordinary differential equations. Now, how do we solve ordinary differential equations? So from here, there are various methods that we can have. Now the first one, I might want to do a little bit introduction to you, or according to what they did here, they just jump straight because they believe you guys might have known it. So don't let me assume like that. So direct, let's start, direct what? Integration. Then the next one that I have here is separation of variables. Then the next one that I have here will be homogeneous, and the next one that I have will be linear differential equations.
And the next one I have would be Bernoulli differential equations. Then the next one I have there would be number 6, would be exact differential equations, and this one too will be DE. Then number 7, which will be an addition to you guys, will be non-exact or inexact. I think it should be non-exact. And non-exact differential equations. So let's start taking it step by step. Then we'll move on. We'll start with what? Direct integration first, right? Okay, let's start. So starting with direct integration first, solutions. Yeah, that's for a piece of advice. Probably if you want to practice questions, you can use K-Stroud as your practice to question. How together? Use your K-Stroud, or you can use HKDAS, preferably. Preferably use HKDAS because the question in HKDAS are more mature. Let me start with. They are more mature. And when you see in John Bed or probably K-Stroud, are more matured. When I mean matured, I mean matured questions. Don't worry. So probably next time, probably we'll have some exercises from HKDAS. Now let's look at direct integration first. Direct integration. So in direct integration, now how do you know a direct integration question? Direct integration question are always written in this format. The y dx is also always equals to what? A single function of what? A single function of x. I get what I'm trying to say like that. So all differential equations that you solve by direct integration are always written in this form, what? A single function of x. So let's have examples. And we start. Okay. So from this part, so let me just say it one more time so that we can probably call whoever you want to call. I think this is 10:58 now. So if you have anyone in hostel that is interested in MTS 301, we have that by 1 p.m. so they can do well to come around. All together by 1 a.m. It's marathon now. We did here together now. Have you now? So let's continue. So now let's take this as an example now. Let's look at this. Let's say you have dy dx. Please, and yeah, that reminds me again. So if you are very weak in integration, it is not a sin. It's just showing that you have to learn. If you are very weak in integration, please try as much as possible. Try as much as possible to what? Go and master integration. I can direct a YouTube link, or I can give a YouTube link to go and watch organic chemistry tutorial. You can go and watch, or probably. Okay, I started integration in MTS 201 a couple of minutes ago. Those of us that were around, you can look at it. So when next time I have an integration class, if you feel you are weak with integration, you can come and we learn integration again together, because whether you like it or not, 80% of what you are doing this semester is based on what? Integration. Starting from your first order, second order, Laplace, all of them are what? Integration. I guess I'm trying to say like that. Okay, so back to business. So here, let's say I have y dx equals to what? 6x squared minus 8x plus 9. Now what do you notice here? You notice that apart from your differentiation or your derivative, which is what? The y dx, everything that you have there is what? A single function of x. Yes or no? And how do you solve something like this? You solve something like this by what? Multiplying both sides by dx, which will give you what? Dy equals to what? 6x squared minus what? 8x plus 9 dx. Are we together? Then from here, what do? You would integrate both sides. Integrate both sides. Then by integrating both sides, what do I have? I have integral dy equals to what? Integral 6x squared minus what? 8x plus 9. What do I have here? Dx. And by integrating dy, you end up having up y equals to, if you integrate 6x squared singly, you have what? 6x cubed divided by 3 equals, minus what? 8x squared divided by what? 2 plus what? 9x plus what? C. Why am I adding C? Because at the end of the day, I'm having what? An indefinite integral. And anytime you are evaluating an indefinite integral, your answer must always have what? An arbitrary constant. Are we together?
Then if you break this one down, you have y is equals to what? 2x cubed minus 4x squared plus 9x plus what? Plus c. So this will give us a solution to that differential equations. Are we together? Okay, let's look at another example. Now, example number 2. Let's say that here you have 3x squared dy dx equals to 2 minus 4x. Yeah, let's have something like this. Now I want to differentiate something like this. Although you know that it looks a little bit simple because simple petty differentiation. I mean petty integration now. Then let's just take it step by step. So from here, you notice that this one here is different from this. In this one here, I had my dy dx equal to something straight up. But this one here, I have something disturbing my dy dx, which is what? 3x squared. Then how do I solve that? The only way I can solve 3x squared is to what? Divide both sides by what? 3x squared. I can say that dy dx here is equals to what? 2 minus 4x, everything divided by what? 3x squared. Then, and with this, since I have a single function of x down here, it can be broken down to give me what? Dy dx is equals to what? 2 over 3x squared. Are we together? Minus what? 4x over what? 3x squared. Are we together? So from here, let me just let me clean this part. Are we still together, please? Okay, good. I want you to follow me to the end. Here you go. Let's roll together. You are lost. Away. And you cannot talk. Why are you lost? Okay. I'm too fast. Okay. I will slow down. Now dy dx in this case here, if you look at this, let's write it using algebra. I mean using indices. This can give you what? 2 over 3x to the power of minus 2. Right? Then what do I have here? Minus, what can I have here? 4 over 3, open bracket, 1 over x. Yes or no? Then from here you can what? Multiply both sides by what? By dx. Then what do I have here? Dy, open bracket, this is 2 over 3 x to the power of minus 2 minus 4 over 3, 1 over x dx. Yes or no? Then you have what? You integrate both sides. So by integrating both sides, you have integral of what? Dy equals to what? Integral of 2 over 3 x to the power minus 2 minus 4 over 3, 1 over x dx. Yes or no? So if you integrate dy in this case, what will I have? Y equals to. So if you integrate this one, you end up having 2 over 3 x to the power of minus 1 over minus 1. Yes or no? Then minus 4 over 3. If you integrate 1 over x, what will I have? Ln of what? X plus what? C. Then if you write this one very well, what will be your answer? Your answer here will be y is equals to minus 2 over 3x. Because x is power minus 1 can what? Can come down. Then minus what? 4 over 3 ln x plus what? Plus c. And to make your answer look a little bit more positive, you can move these two sides here to the other side. Then I can now have y equals to, y plus 2 over 3x plus what? 4 over 3 ln x is equals to what? C. Are we together? Are we together? Alright, now let's look at another example. Now another example, let's say example 3. Let's have this one to be okay, theta, or okay, let's do it this way, cos theta d theta over dt is equals to, okay, let me put dt over d theta, sorry, dt over d theta is equals to tan theta plus okay, and put sine theta here. Yeah, let's have something like this. And after this, let me now have t of 0 equals to 1. And this is another equation. And whenever I have an equation like this, cos theta, and whenever I have a differential equation that a condition is attached to it, then you can call this differential equation what? An initial value problem. So this kind of equation is known as what? IVP. I get what I'm trying to say like that. So anytime, how do you know an IVP? An IVP is any differential equation that after the normal question, the next thing that you have is what? You have a condition attached to it. Then this condition attached to it makes this differential equation become what? An initial value problem. Do you understand? Now let's solve this. So now let's work with this. So it looks a little bit somehow. I am playing with trig. So let's see. So now I can say that dt d theta here should give me tan theta over what? Cos theta, right? Plus what? Sin theta over what? Cos theta. Are we together? Are we together? Then so from here, if you want to work with this, you can say that dt d theta is also the same thing as tan theta here is the same thing as writing probably sin theta over what? Cos theta. Are we together? Multiplied by 1 over cos theta. I hope you know. Then everything here plus what? Tan theta. Yes? Right? Abi now? Then so from here you can have dt d theta is equals to what? Sin theta over what? Cos squared theta. Are we together? Then plus what do I have here? Tan theta. And so from here, what do I have to do? Multiply both sides by what? D theta. Then multiply both sides here by d theta. What do I have? I have dt is equals to, open bracket, sin theta over what? Cos theta. Are we together? This is tan, okay. Cos squared theta. Then plus, plus what? Tan theta. Everything multiplied by what? D theta. Yes or no? Then what do I do from here? You what? Both sides. So we integrate both sides. Now by integrating both sides here, what do we do? So I can have, what do I have? Integral dt is equals to integral. Now here I have sin theta over what? Cos squared theta plus tan theta d theta. Are we together? Please, are we together, please? Then so from here, everything here will give you what? T. Let me break down this integral sign to give you integral of what? Sin theta over what? Cos squared theta d theta. Are we together? Plus integration of what? Tan theta d theta. Are we getting it? So from here, let me break down this. So let me carry this one out. So if I want to integrate sin theta over what? Cos squared theta d theta. So I want to use integration by what? By substitution. I mean now which one do I substitute? I think it's easier for me to make let u is equals to what? Cos theta, right? Then from here, if you differentiate both sides, I can say du is equals to what? Minus sin theta d theta. Yes or no? And d theta will give you what? Minus du over what? Sin theta. Yes or no? Do you get what I've done here, please? Then let's substitute everything that I have here back inside this place. Then what will I have? I'll have integration of what? Sin theta over, what will this one give you? U squared. What's your d theta here? Multiplied by minus du over what? Sin theta. This one can cancel out. Then I'm now left with what? Minus integration of what? U raised by minus 2 du. Yes or no? Yes or no? Then from here, what do I have? So if I integrate this one, I will have what? Minus open bracket u raised by minus 1 over minus 1. I be now plus c. Then this one can cancel out. Then I can have this one to give you what? 1 over u plus what? Plus c. But what is your u? Your u is what? Cos theta. So the answer I can have is what? 1 over what? Cos theta plus what? Plus c. And what is 1 over cos theta? is the same thing as saying what? Sec theta plus what? Plus c. So I've differentiated this part. And let's go to the second part. It looks long, Abby. Sorry, continue. Let's continue. So let's go to the second part here. What is in the second part here? I'm differentiating what? Tan theta. So if I differentiate tan theta d theta. So it is the same thing as saying integration of what? Sin theta over what? Cos theta d theta. And there's a trick in integration that says if you differentiate the denominator, you get your what? Numerator. But this time around, that trick does not want to work, but it will work. If I differentiate cos theta, what am I supposed to have? Minus sin theta. But what do I have here? Sin theta. So I can put that minus I'm supposed to have outside. Then what do I now have? The ln of your what? Denominator. Are you getting it? So now what will my t be here? So I can answer that t here will now give me, what is everything here? Everything here was what? Sec theta plus what do I have here? Minus ln cos theta plus what? C. Are you getting it, please? Then from here you can have t is equals to what? Sec theta minus ln cos theta plus what? C. I'm supposed to leave my answer like this, but I would not. Do you know the reason? Because I already have a condition which states that t of 0 equals to 1. So if I want to interpret this condition alone here means that t is equals to 1 when theta is equals to what? 0. So let's put that here. So all I have here, I'll have 1 equals to cos, sorry, not cos now, sec 0 minus ln cos 0 plus c. Then I hope you know that this one here, sec 0 is the same thing as 1. I mean now, because sec is inverse of cos, and 1 over cos 0 is what? 1 over 1, which is the same thing as what? 1. Then minus ln cos 0 here is what? 1 plus c. Then if you press your calculator, you have 1 equals to 1. Everything here, ln 1 is what? 0 plus c. Then I can say that here, my c is equals to what? 0. So if my c is equals to 0, what will I do? I'll substitute this answer back inside the what? This question. Then my final answer here will now be what? T is equals to what? Sec theta minus ln cos what? Cos theta. That's my final answer. Do you understand, please? Do you understand, please? Alright, let's write. So that will be that about that for differential equations, so direct integration, so you can solve as many questions as you can solve. So now let's look at the second subtopic. Let's look at the second subtopic. So for the second subtopic here, what do I have? We have separation of what? Of variables. Are we together? Separations of what? Of variables. So I want to separate variables. Then how do we know that we are supposed to use separation of variables? All separation of variable questions are written in this format. dy dx is equals to f of y multiplied by what? F of x. You can have it in this format. You can also have it as dy dx is equals to f of y, sorry, f of y over what? F of what? F of x. So now the main thing you have to know in separation of variable is that the questions are always written in a form that it should be easy for you to separate x from what? From y. I get what I'm trying to say like that. That is how you recognize what? Separation of what? Variable. How do we recognize direct integration? Recognize direct integration that apart from your derivative, every other thing you have is what? Of a single function. Abi now for separation of variable, the only way we can recognize it is because they are written in such a way that the dependent variable and the independent variable can be what? Separated. Do we understand? Okay, now let's have examples. So these examples, now let's get the examples from a manual. So we had this one first. Number 1 here is dy dx is equals to x minus 5 divided by what? Y squared. So this is what you have. Then from this point here, you were asked to what? To solve. And yeah, I hope you know that it is very, very easy for me to separate y from x in this space here. Yes or no? So how do I separate y from x? I can do what by what? Cross multiplying. So if I cross multiply here, what do I have? I have y squared dy equals to what? X minus 5. What do I have here? Dx. Then from here, I can have what? Integrate what? Both sides. So integrating both sides here. Integrating both sides. So what do I have? I have integration of what? Y squared dy equals to what? Integration of what? X minus 5 dx. So if we integrate y squared here, what will I have here? I will have y cubed divided by 3. Then this one will give me, if I integrate this one will give me what? X squared divided by 2 minus what? 5x. Good. Now here, there's now a situation I wanted to pay cognizance to. Now you find out that what I did here, I integrated y and x indefinitely. Yes or no? Away. This would have solved. See paper inside you. Now here, what do you notice? Notice that I integrated y and x indefinitely. Yes or no? So that means on normal norms, I'm supposed to add my arbitrary constants to both y and x. Yes or no? But please, as long as differential equation is concerned, it is mostly advisable to add your arbitrary constant to your what? To your c, than rather to your what? To your y. I get what I'm trying to say. It is mostly advisable, although there are some scenarios whereby the c is added to the what? To the y and not to the x. But to avoid confusion, although by the time you have, if you add c to the other side, you end up having the same similar answers, but you take you a long step to move from this answer, the first answer, to this particular type of answer. I guess what I'm trying to say like that. So just let it be advisable that whenever you have something like this, add your arbitrary constant to your what? To your x. Do you get? So this would be my what? My final answer. What did your people do? I think they did the same thing too. I'll get some pencil like that. Okay, let's look at another question. Okay, I think at the end of the day they ended up here by solving for y. You can solve for y or choose to leave the answer like this. Anyone you want to do. Okay, let's look at this question again. Question number 2 says this. It says you have to solve dy dx equals to y minus 1 over x plus 3. Then you have this condition, which is what? Y of minus 1 equals to what? 0. Are we together? So now, what do we do here? First thing I have to do here is what? Cross multiply. Yes or no? Yes or no now? So by cross multiplication, what do I have? Then you notice that I have x plus 3 dy equals to what? Y minus 1 dx. You find out that both of them are having opposites. They're having opposite of each other. Then how can I make all of them come to each other? I can say that I divide both sides by x plus 3 and y minus 1. Abi now? So if I divide both sides by what I just said, then I can have what? dy over what? Y minus 1 equals to what? Dx over what? X plus 3. Are we together? Are we together? Then so from here, what do I do now? I what? Integrate both sides. So then by integrating both sides, what will I end up having? Then by integrating both sides, I think I will end up having, what will that be? I'll end up having, I'll have integration of, let's just split this one to be 1 over y minus 1 dy equals to integral of 1 over x plus 3 dx. Yes or no? So now, so that trick of differentiation I will use here. So if you differentiate your denominator here, what will I have? The numerator. Yes or no? So I can call this one ln of what? Y minus 1 equals to this one is what? Ln of what? X plus 3. Yes? Plus c. Are we together? Now let me now tell you another thing to do. Whenever you have ln on both sides, you exponent both sides. I get what I'm trying to say like that. The only condition for it to exponent both sides is if I have ln on my right hand side and I have what? Ln on my what? Left hand side. So what do? Let's go by take exponents of what? Both sides. So if I take exponent of both sides, what I have? I write exponential ln of what? Y minus 1 equals to exponential ln of x plus 3 plus what? Plus c. All together. And I hope you know that. If you don't know before, know now that exponential and ln are like fire and water. They eat each other. So exponential and ln will cancel out here to give me what? Y minus 1 equals to. Now before I cancel this one out, do you know that I can still break this one out to give me exponential ln of what? X plus 3 multiplied by exponential c. Yes or no? Then according to the law of indices here. Then from here you can choose at your own discretion to let. So I can say that let exponential c equals to give me a. Then if I represent this now, what will I have? I will have y minus 1 equals to what? X plus 3 multiplied by what? A. So this will be my answer. But don't worry, don't forget that the question gave us a boundary, initial value condition. And what does this thing mean? It means that y is equals to 1 when x is equals to what? Minus 1. Sorry, y equals to 0 when x equals to what? Minus 1. So substituting that, what do I have? 0 minus 1 equals to what? A open bracket minus 1 plus what? 3. Yes or no? Then what do I have here? Minus 1 equals to 2a. And here I can say that a is equals to what? Minus 1 over 2. Since I've gotten a, I can substitute that answer back here and say that my answer here is what? Y minus 1 equals to what? X plus 3 multiplied by what? Minus 1 over what? Over 2. Then if I want to make my work look a little bit more mature, I can multiply everything by what? By minus. So if I multiply everything by minus, what do I have? I will have 1 minus y equals to what? X plus 3 multiplied by what? 1 over 2. I hope you understand what I've did. I multiplied everything by what? By this minus. Then if you multiply everything by 2, you can end up having what? 2 open bracket 1 minus y equals to what? X plus what? Plus 3. So you can leave your answer like this, or you can decide to solve for what? Solve for y here. Do you understand? Do we understand? Huh? Okay, good. So let's look at another example. I'm working on all the examples you have here. I think you still have 2 examples more. Have 2 examples more. So now for these 2 examples that we have here, and from these 2 examples, okay, let's look at this one this time around. So the question says we should solve dy dx is equals to 6x to the power of 5 minus 2x plus 1 divided by what? Cos y plus what? Exponential what? Exponential y. Now we have something that looks like this. And from something that looks like this, what do I have to do here? Cross multiply. Yes or no? So let's cross multiply. So by cross multiplying, I have what? Cos y plus what? Exponential y. Everything multiplying what? Dy equals to 6x to the power of 5 minus 2x plus 1. Everything multiplying what? Dx. Then from here, I can do what? I can integrate both sides. Please, you see that most of what I'm doing, I am writing the steps. Please ensure that you write the steps too. That marks. So we have integrate both sides. So now by integrating both sides here, you will end up having integral of cos y plus what? Exponential y dy equals to integration of what? 6x to the power of 5 minus 2x plus 1 dx. Yes or no, please? By integrating. I've been now. Away. Oh yeah, now. So from here, by expanding this, help the person that is beside you now. Their father did not pay for this one, but we are dashing them this one. Oh yeah, wake up, wake up, wake up, wake up. Let's continue. Alright, so from here, I think I can integrate this one here separately. Yes or no?
So by integrating this one separately, what do I have? I have I have what? Sine y plus what? Exponential y. Yes or no? Yes or no? Then if I integrate this, what will I have? I'll have 6x to the power of 6 divided by 6 minus what? 2x squared divided by 2 plus what? Plus x plus what? C. Then by expanding here, you can have what? Sine y plus what? Exponential y equals to x to the power of 6 minus what? X squared plus x plus what? C. So this should be your what? The final answer. Are we together, please? Are we together? Okay. You know, I still get time now. I want to sleep. Okay. Jump in. Oh yeah, now. All right, let's continue. Right, ready, go. All right, good. Now this time around, we have dy dx is equals to tan y over what? X squared minus 1. So I think by cross multiplication, but this time around, let me do it in the way I think you should be able to understand. So by cross multiplication, I want to cross multiply, but at the same time, it is not the normal cross multiplication. Now, do you know that this one can come here, this one can come here? Happy now? So by swapping these two together, you have dy equals to what? Tan y equals to what? Dx over what? S squared minus 1. That's a wicked laugh. Now, if you look at this now, if I want to work with this one this time around, I can have dy cot y. Abi now, or better still, let me write it in this way. Cot y dy is equals to 1 over what? S squared minus 1 dx. By God's grace, right? Then so from here, what do I have? I do what? Integrate both sides. Now by integrating both sides, what do I have? I have integral of what? Cot y dy equals to what? Integral of what? 1 over what? S squared minus 1 S squared minus 1 dx. Are we together? Okay. So now, it looks as if we might want to run into a problem small. A little bit problem. Now, let me isolate my right hand side. Let me bring it out. Then by isolating my right hand side here, what will I have? By isolating my right hand side, I will have integration of what? 1 over what? S squared minus 1 dx. By following difference of 2 squared here, what will I have? Integration of what? 1 over x plus 1, and this is what? X minus 1 dx. Are we together? And by this, the only way I can integrate this is to do integration by partial fraction. So now let me isolate what is inside there. So by isolating it, I have 1 over what? X plus 1, and this is what? X minus 1, which is equivalent to a over what? X minus 1 plus b over what? X plus 1. Then I can say that this one is the same thing as 1 over x plus 1 x minus 1 equivalent to a open bracket x plus 1 plus b x minus 1 divided by what? X minus 1 and what? X plus 1. Are we together? Are we together? Then so from here, so I can say that I have 1 is equal to what? A open bracket what? X plus 1 plus what? B open bracket what? X minus 1. Then from here, I think we can use cover up rule. So eliminate any one of your choice. I can say that let x equals to 1. So if x is equals to 1 here, what do I have? I have 1 equals to a open bracket 1 plus 1 plus b open bracket 1 minus 1. So from here, I think I can have my a to give me what? 1 over 2. Yes or no? Then the other one, if I said let x is equals to what? Minus 1, what will I end up having? I'll have
1 equals to a open bracket minus 1 plus 1 plus what? B open bracket minus 1, which will give me 1 equals to minus 2b, and b is equals to what? Minus 1 over 2. Are we together? Are we together? Alright, then from here, moving back to this side, okay, we're together. Alright. So from that, no, you know that from here, I've gotten A and I've gotten what? I've gotten B. So I've gotten A and B. So what am I supposed to do? Let me plug them back inside this place. Then by plugging them back, so I hope you know that at the end of the day, I will have this 1 divided by x plus 1, x minus 1 is equivalent to, what is my E now? So I can have it as 1 over 2 multiplying 1 over x minus 1. Yes or no? Yes or no? Then I can have minus. Do you know why it is minus? It is minus because what I have on my B side is also what? Is also minus. So I can have minus 1 over 2 open bracket 1 over x plus what? X plus 1. Then I can now return both of this one back inside my what? Original equation. Are we together? Then so from here I can now have integration of 1 over x squared minus 1 dx is integration of what? 1 over 2 open bracket 1 x minus 1. Are we together? Are we together? No one talk now. Dx, please. I need your response to know that you are still alive and with me. I know you are alive. Well, I want your response to show that you are with me. I want you to be with me. Don't leave me alone. Don't leave me alone. So let's continue from here. Then from here, what do you notice? I hope you know that from here I can confidently split this integration into 2. Yes or no? Abi now? So now splitting this integration into 2, what do I have? I have 1 over 2 integral of 1 over x minus 1 dx, right? Minus 1 over 2 integral of what? 1 over what? X plus 1 dx. Then moving up here, I will have this to be 1 over 2 ln of what? X minus 1 minus 1 over 2 ln of what? X plus 1. Then if I want to combine both of them together, I can first of all factor out 1 over 2. Then this will give you what? Ln of what? X minus 1. Okay, should we do it straightforward? Should we do it straightforward or take it step by step? Let's take it step by step. X minus 1 minus ln what? X plus 1. And I hope you know that anytime you see subtraction between logarithms, it is what? Division. Everything here is now the same thing as saying 1 over 2 ln of what? X minus 1 over what? X plus 1. Then I can write it as ln of what? Open bracket x minus 1 over what? X plus 1. Everything is by what? Half. Yes or no? So what I've just done is that I have just successfully solved the right hand side. So let's come back and solve the left hand side. It's not me that give you the question, it's your manual. How many pages days to do it, sir? Okay, that's this part. What they did this part is what we are breaking down so that you can understand. So it's not my fault, it's your manual that I gave you. Alright, now breaking the other parts down. So let me come to the other side. So if I want to break this other part, so what do I have? I have integration of what? Cot y dy. And cot is the same thing as saying inverse of tan. And inverse of tan is the same thing as saying cos x over what? Sin x. No, but this one is not x this time around, is what? Is y and what? Y dy. Then you can notice that from here, what do you notice? Notice that I have, if I differentiate sin y, what do I have? Cos y, what? Sin y. So now, if I now come back to this place here, I can now write my equation in this form that integration of what? Y dy equals to integration of 1 over x squared minus 1 dx. So what is this answer here? Ln sin equals to, what is this answer here? Ln x minus 1 over what? X plus 1 raised to the power half plus what? Plus c. I cannot leave my answer like this. Yes or no? Yes or no? Yes, I can't leave my answer like this. The reason is because I have ln on both sides. So what do? I take exponent of both sides. Take exponents of both sides. Am I taking exponent of both sides? Then what do I have here? I have exponential ln of sine y equals to exponential ln, what do I have here? X plus 1, sorry? X minus 1 over what? X plus 1 raised to the power what? Half plus what? Plus c. Then this is the same thing as saying sine y equals to, should I break it down? Let's break it down. Exponential ln x minus 1 over what? X plus 1 raised to the power what? Half multiplied by what? Exponential c. And I can say that exponential c is the same thing as what? A. Then at the end of the day I have what? Sine y equals to a open bracket, what do I have here? X minus 1 over what? X plus 1 raised to the power what? Half. I have half here. Should I leave it? No, I'm not leaving it. So I don't want to leave this answer. So what do I have to do? I square both sides. Abi now? So squaring both sides here will now give me sine squared y equals to, what do your people have here? And let's call it a open bracket x minus 1 over x plus 1. Now, a good question. Why is my a not carrying squared? The reason why my a is not carrying squared is that a is still an arbitrary constant. So don't know whether a is a valid number or a is what? Is 0. I guess I'm trying to say. That's why it's better we leave it like that. I think, can I leave my answer like this? No, they did not leave the answer like this. So let me leave the answer the way they left it in the manual. Cos multiply. Then you can have sine squared y equals, sine squared y open bracket x plus 1 equals to what? A open bracket what? X minus 1. So this is my what? My final answer. According to what your textbook had. Do you understand? Do you understand? Okay, good. So I think we have about 22 minutes to go. Let me see. These people did not do what I expected them to do. No, they didn't do what I expected them to do. Okay. All right. Good. I think they later did what I expected them to do. Okay. Now, so sorry. Jumping straight up to now the next method here. What's the next method here? Homogeneous differential equation. Now let's write this homogeneous differential equation. The next one is what? Homogeneous. What is this? Differential equation. Now, how do you recognize homogeneous differential equation? Now, apart from that order that I gave you, are we together? Now, homogeneous differential equations are written in such a way that the highest power of x is equal to the what? Highest power of y in the differential equation. Are we together? Okay, let's look at one typical example that your manual did. Your manual did this. Your manual asks you to solve this, which is what? 2xy dy dx is equals to 4x squared plus what? 3y squared. Your manual asks you to solve this. Sorry, I am on page, where's this squared? Page 41. So they jumped and put this one at the back, but it's supposed to be in the front so that you can learn it and go and learn the one they put at the back in the front. You get what I'm trying to say? Now, with this part now, so what do I have to do first? The first thing I have to do is what? I have to divide both sides. So I can have dy dx is equals to what? 4x squared plus what? 3y squared over what? 2xy. Are we together? Then so from here, now you will notice that there is no magic that you can do that can make you separate x from y. Yes or no? Okay, good. Now whenever you have a situation like this that x and y cannot be separated from each other, you can just write this thing. Let y equals to what? Vx. Are we together? We'll still differentiate that equation, but let's call this one equation what? Equation 1. So anywhere I see y, what am I substituting there? Vx. So what do I have there? I have what? Dy dx is equals to what? 4x squared plus 3 open bracket vx all squared divided by, what do I have here? 2x divided by what? Vx. Then from here I have dy dx is equals to 4x squared plus what? 3v squared x squared. Yes or no? Then divided by what? 2v x squared. Then at the end of the day, I can factorize x squared. Then I can say that dy dx is equals to what? X squared open bracket 4 plus what? 3v squared divided by what? 2v x squared. So x squared can cancel x squared. Are we together? Okay. Continuing. Don't be scared. I did that one. Don't run away now. I did that one. I wanted to call everybody asleep so that they can wake up. Are we together? Okay. Now, so from here, working with this, what can I have? I can have dy dx is equals to what? 4 plus 3v squared over what? 2v. Now, I've gotten to a threshold. So I can now say that recall y is equals to what? Vx. Then from here, I can now differentiate both sides. So if I differentiate both sides, what do I have? I have dy equals to what? Dx. Then I can use product rule here. Yes or no? Which is what? This is u, this is what? V. I have v open bracket 1 plus x. And if I differentiate v with respect to s, what do I have? dv dx. Yes or no? Then I can have here to what? dy dx is equals to what? V plus x dv what? Dx. I'll get my pencil like that. I'm getting it. Then so from here I can now substitute dy dx, which is equals to this, back inside this place. Then from here I can now have, what do I have? What is my dy dx here? V plus x dv dx is equals to what? 4 plus what? 3v squared over what? 2v. Then what do I do? Collect like terms together. Bring v to the other side. Then what do you have? You have x dv dx is equals to what? 4 plus 3v squared over what? 2v minus what? V over 1. Are we together? Now so from here, let's say we have x dv dx is equals to, now what's the LCM here? 2v. Then I have what? 4 plus 3v squared minus, what do I have here? 2v multiplied by what? V. Yes or no? Then from here, what can I have? I will have x dv dx equals to what? 4 minus 3v squared minus what? Sorry, plus 3v squared minus 2v squared over what? 2v. Then moving on to this side, what do I have? I have x dv dx is equals to what? 4 plus v squared over what? 2v. Are we together? Are we together? So from this side, if I multiply both sides by 2v over 4 plus v squared, what will I end up having? I will end up having 2v over 4 plus v squared dv equals to 1 over x dx. Do you know what I did, please? Okay, this is what I did. So let me do it step by step. I thought that jumping will help us. Now, let's cross multiply. So I can have x dv multiplied by 2v equals to what? 4 plus v squared multiplied by what? Dx. Divide dx everything. So I can have dv multiplied by 2v equals to what? 4 plus v squared multiplied by what? Dx over what? X. Are you together? Then from here, divide both sides by this one again. But then what I have? dv multiplied by what? 2v over what? 4 plus what? V squared equals to what? Dx over what? X. Are we together, please? Do we now get what I've done now? What I did first is cross multiply. Then by cross multiply, start dividing through by what? X. Then divide through by this. Then I add this. And from here, what can I now say? Integrate, what is that? Integrate both sides. Now from integrating both sides here, what will I have? I will have, let me say, integration of 2v over what? 4 plus v squared dv is equals to integration of what? D of 1 over x dx. Are we together?
Are we together? Then from here, if I integrate this part here, you find out that if I differentiate the denominator, I will end up having the what? The numerator. Yes or no? So from here, what will I now have? I will have ln of what? 4 plus what? V squared is equals to what? Ln of x plus what? Plus c. And at the same time, what do I have here? I have what? Ln on both sides. So what do I do now? I what? Take exponential of both sides. So take exponential, take exponents of both sides. Then if I take exponent of both sides, at the end of the day, I will end up having, what will I end up having? Yeah, I will end up having, probably if you have anyone in hostel, I think we still have about 30 minutes, that is interested in MTS 201, you can call them. We have that class by 1 a.m. this midnight. You understand? So please don't be selfish. I will get what I'm trying to say like that. Now, so from here, so continuing from here, so what do I have? I can have exponent ln 4 plus v squared equals to exponent ln x plus c. Are we together? Then so from here, then what can I have? I can have 4 plus what? V squared is equals to what? Exponent ln x plus, multiplied by exponent c. Are we together? And exponent c at the same time is equals to what? A. Then what do I have here? I have 4 plus what? V squared is equals to what? Ax. Yes or no? But at the same time as I have Ax here, my question was not in terms of V originally. It was in terms of what? X. So I can now say that, recall that y equals to what? Vx. Then from here, if y equals to Vx, I can say that V is equals to what? Y over what? X. Then substituting this one back here, then I will have what? 4 plus what? Y over X all squared is equals to what? Ax. Then opening, simplifying this one, what will I have? 4 plus what? Y squared over what? X squared equals to what? Ax. Multiply everything by what? X squared. Then I have what? 4x squared plus what? Okay, 4x squared plus y squared is equals to what? Ax cubed. I think this is the best form I can leave my what? I can leave my answer. Yes or no? Yes or no? Okay, so is that what they got here? Okay, yeah, that's what they got. Okay, let's look at one more. Let's see if we'll be able to finish that before the end of this class. Let's see. Are we done writing? Okay, let's write quickly. So where have you guys gotten to in 5 in class? I understand the laughter, don't worry. I understand the laughter. And I have something like this, which is 2x dy dx equals to x plus y. Don't say that. I like it share. I do not like it share. So from here, sorry, I just like you guys to know it's good to be hardworking now. Have you now? So let's start. So from here, what do I have to do? Divide both sides by what? 2x. So do you know what thing I would advise you to do is that, first of all, note this formula. Are we together? The next formula that I should note is this. Note this formula. You might not necessarily know how to prove them, but just, I won't ask you to memorize it, but just what? Just note these formulas that I put in box. Do you understand? I wish sure. Then from here, what do I have? Then I will have here to be
dy dx is equals to what? X plus y over what? 2x. Are we together? And I hope you know that this one, it is written in the format that x and y cannot separate from each other. Then what is the next thing? I said that let's what? Y equals to what? Vx. Then what do I have? I have dy dx is equals to what? X plus vx divided by what? 2x. Then cleaning the second part.